hole, a peg hole, a sheet of cardstock, and a hole punch. And so we're going to use them to simply create what we call a pinhole projector. And so in order to use these or to make these, you need a few items from home, but number one, make sure to never look at the sun directly, but number two, make sure when you are making and creating and using these that the sun is to your back, so that the sun's light can cast light through the holes. And
you just, what, put it up and have it
coming
put
through.
A shadow on the ground?
Absolutely, and so on the paper model, we are going to put a hole here, and the light is going to go directly through it. Peg hole, the colander, and the NASA 3D printed model already has a hole. All you have to do is wait for the eclipse to happen and see the view of the sun on a surface area.
That's great. So Leslie, can you go over those materials just one more time?
Absolutely. So at home, you probably already have a colander. This is just a pegboard toy from my son's toy box, and a sheet of cardstock and a hole punch. But NASA has a cool event online. You can see our URL somewhere on our screen, and you can go online and make these items at home to use.
So really you just need something with a hole.
You need something with a hole.
That
the sun's light can shine through, so on the surface area, and you can see the eclipse on that surface area.
Simple, effective. Leslie, thank you so much for your help today.
Leslie.
And folks, this is a good time to remind everybody that it is dangerous to look directly at the sun without specialized eye protection for solar viewing during today's events. Now, we have a very special guest that you might recognize popping in to share some important tips to make sure that you stay safe during an annular eclipse.
Hi, eclipse enthusiasts. Lance Bass here, and I want to tell you how to protect those eyes and stay safe during a solar eclipse. During these celestial events, the sun, earth, and moon are in sync, creating solar eclipses. During an annular eclipse, it's not the moment for a sun staring contest. Grab those eclipse glasses and shade your eyes from the ring of fire. What you'll witness is a true cosmic marvel. The moon will move between the sun and the earth, but the moon is a bit too far away from Earth to completely cover the sun. So, when you look up at the sky during this annular eclipse, you'll see the sun creating a glowing ring around the moon. Because the sun is never completely blocked, it is never safe to look directly at an annular eclipse without special eye protection for solar viewing. This I promise you. You should wear eclipse glasses so that you don't say bye-bye-bye to your vision. Seriously. And eclipse glasses are not the same as regular sunglasses. No, they're not. Safe solar viewers are thousands of times darker and will have a specific certification that you should look for right here. Don't be a space cowboy and try to look directly at the sun. If you don't have eclipse glasses, you can use an indirect viewing method, like a pinhole projector. You can make one of these with something as simple as an index card with a hole, or a colander, or even your hands. With the sun at your back, you can safely project an image of the sun through the hole onto a nearby surface, like the ground. It's gonna be me who is wearing my eclipse glasses, and so are you.
Now, don't forget to be in sync with these safety tips, folks. Seriously, listen to Lance and protect those eyes. We really want everybody to enjoy today's events. Now, let's check in with Joy and Michael in Albuquerque, New Mexico. Joy, Michael, how is the energy over there?
Hi, Terra and Gina. The energy in Albuquerque is buzzing. We are so excited for the annular eclipse to pass through New Mexico in just under an hour. I'm joined with one of NASA's eclipse experts, Dr. Michael Kirk. Thank you so much for joining us.
Oh, it's an absolute honor and a privilege. I'm so excited to be here today.
So we're currently on the grounds of the Anderson Abruzzo International Balloon Museum in Albuquerque, and behind us, the Albuquerque International Balloon Fiesta is also happening. And in fact, a balloon is also about to get inflated right behind us, which is really, really exciting. So Michael, have you seen an annular eclipse before?
I have seen an annular eclipse in New Mexico back in 2012, but this is a special event here today. With the Balloon Fiesta going on, there are literally thousands of people behind us, all getting ready for this event. This is one of the most special eclipses I've ever been to.
This will be my first annular eclipse. I'm really excited, and the skies are looking really clear, so I have my fingers crossed that it stays that way. So we have these incredible balloons over the past week, but did you know that NASA also does science experiments and develops technology using balloons? They're slightly different from hot air balloons. So to learn more, I chatted with Chris Yoder from NASA's Scientific Balloon Program. Hi, Chris. Thank you so much for joining us.
Thank you for having me.
So you're part of NASA's balloon program. What is the difference between a NASA scientific balloon versus a regular hot air balloon?
Good question. So hot air balloons are air-filled, and the air is heated to create the buoyancy through the lift that gives them flight. Generally, they float at a couple thousand feet, and they go up and down in a matter of hours. Scientific balloons, on the other hand, are quite different. So our largest balloons can fit a football field inside their equator, and they can fly for much longer. So payload capacity is about 8,000 pounds, several SUVs. The duration can be up to 5 or 6 weeks at a time, and the altitudes can be up to 160,000 feet, about 4 or 5 times the height of a commercial airliner.
Wow.
So quite a bit different, yeah.
That's incredible. And you launch all over the globe. So you launch from New Mexico in the US, New Zealand, and even McMurdo Station in Antarctica. Why do you launch from all those different places?
In short, we go where the science needs us to go. Some scientists need Northern Hemisphere science for galaxies and star formations. That's why we go to Sweden. Same thing in the Southern Hemisphere. That's why we go to Antarctica. Most missions need some kind of trial or test system. So they'll fly from New Mexico to prove their science or even just collect science at a shorter duration. And then for missions that are a little more risky, we'll go out to PMRF in Hawaii.
So can you describe to me what launch day is like?
It's an incredible feeling, right? So you see the balloon be released, you hear the rustle of the fabric and the rush of the wind as it stands up. You see the balloon be released on the vehicle and ascend, and it just gives you chills every time you watch it. It's a really great feeling.
That sounds incredible. So how many of these balloon experiments have been sun-focused or eclipse-focused?
So about 8 to 10% of our portfolio is heliophysics missions. One of the ones that stands out in my mind is one I got to see launch in 2019 from New Mexico. It's called the BITSI mission, and it was looking at the corona, or the kind of the outer edge of the sun, and looking at how that behaves under different conditions.
That sounds amazing. Thank you so much for joining us.
Thanks again for having me.
Our balloon program has been around since 1961, so it's no surprise that our balloons are constantly innovating and discovering new science. So let's dive into some of the big science discoveries that have been made with scientific balloons.
High above Earth's surface floats a critical tool in NASA's exploration arsenal: scientific balloons. Massive, helium-filled, high-tech balloons lift heavy scientific experiments into near space to get a clear view of our planet and the cosmos. Launched around the globe, these unique NASA missions provide a fast and cost-effective alternative to rockets to study Earth, our solar system, and beyond. Balloon science has led to many important discoveries. For example, astrophysicist John Mather studied heat from the early universe using balloons, which later contributed to his Nobel Prize-winning work confirming the Big Bang theory of an expanding universe. A special type of high-altitude balloon can carry telescopes above the clouds for extended periods of time to study the dark matter in distant galaxy clusters. One of these superpressure balloons, called SuperBit, captured the Tarantula Nebula 160,000 light-years away. This winter, crews in Antarctica are preparing to launch the Gusto mission. Its infrared telescope will examine the complete life cycle of a star. NASA's scientific balloon program, guiding a path to discovery above and beyond.
Joined with us now is the Balloon Museum Manager, Nan Maslin. Thank you so much for joining us on probably the busiest week of the year.
I'm so happy to be here with you all.
So we're here, the Fiesta started in the 70s with a small group of people, and now there are hundreds of balloons. Can you tell us more about the event and what it means to the city?
Absolutely. Well, it started in 1972 by a pilot named Sid Cutter, who had the idea to get a few hot air balloons together. He managed to get 13 together in a mall parking lot, and they expected a handful of people to show up, and hundreds did. And that's when he knew he was really on to something. And 51 years later, there's 100,000 people behind us on the field right now.
Oh my goodness. So the Balloon Museum, it's where you work and it's where we are right now. Could you tell us a little bit about the relationship between the Balloon Museum and the fiesta itself?
Absolutely. We are very good neighbors. We are here 365 days of the year. We started in 2005, and we start with the early ballooning in the 1700s up through today, exploring the history, science, art, and just wonder of ballooning. And if you haven't been to Albuquerque, we invite you all to come back and check out this museum.
And what do you love most about the fiesta and the museum this week?
New Mexico is such an enchanting place to be, and the smell of roasting green chili in the air, there's nothing like it. There's a reason why Georgia O'Keeffe chose this place as her home. It's because of the open sky and the beautiful landscape, and we get to enjoy so much of that here. And when you think about it, there's like a spotlight shining on Albuquerque, and I think it's probably the best place in the whole wide world to be right now. Today, balloon fiesta and an annular eclipse. I can't imagine anything better.
And how do you feel about an annular eclipse falling at the same time as the event this year?
It's just fantastic. I'm so happy to be here with you all, and Mother Nature has provided us the perfect sky today. Looking this direction, I don't see a single cloud. There's a bite out of the sun already, like it's bitten out of an apple, and I just am so excited to see the annularity.
Amazing. Thank you so much for being with us today. I'm really excited to enjoy the annular eclipse together.
Me too.
So next, we are honored to hear from NASA Administrator Bill Nelson.
Hey everybody, we're so excited that you're joining us today for this solar eclipse. It's when the moon passes between the Earth and the sun. It's a big day for NASA scientists because eclipses present unique opportunities to study the sun. And what we learn from these eclipses, along with our heliophysics research, has incredible benefits for our human exploration. The sun is a powerful, hot, glowing ball of hydrogen and helium, and it actually holds together the entire solar system. Without its energy, we couldn't exist here on Earth. Just think, it influences everything. What we do on Earth, growing crops, our economics. It even affects our physical, mental, and emotional well-being. We see its influences reflected throughout our culture as well, in art, music, religion, sports. And when you look up today with your eclipse glasses, I hope you're going to remember all the ways that the sun impacts us. NASA will never stop studying our closest star for the benefit of all of us, terrestrial beings here on planet Earth.
Thank you, Administrator Nelson. So, Michael, we've been getting a lot of questions on social media. Shall we dive in?
Yeah, let's do it.
Okay. So, I have a question here from Priyesh Patel on YouTube, and they ask, do events like eclipses occur in a similar pattern geographically?
Oh, absolutely. Geographically, we get the same sort of shape of an eclipse that will move slightly northward in its progression. So this is called the Saros cycle. And every 18 years or so, there's a repeated pattern of an eclipse, and the pattern itself repeats a little bit further north each time. And so we get these overlapping patterns that are exactly the same over time.
Amazing. I didn't know that.
Yeah.
That's really surprising. Okay, and before I go on to my second question, I just want to mention that in the telescope view now, we are seeing a partial eclipse and a lot of bite out of the sun.
Oh yeah, it's getting a bit bigger. We're not quite to 50% yet, but yeah, it is getting there. It's pretty exciting.
That's so exciting. Okay, so the second question I have is Sammy Connor on YouTube. And they ask, how does the Ring of Fire eclipse affect the light from the sun reaching Earth?
Ooh, that's a fantastic question, because this has something to do with the science that we can do with eclipses as well. So as the sun gets blocked by the moon progressively, there are parts of the sun, active regions specifically, that will be blocked, and the light from the active regions won't be able to hit the Earth's atmosphere. So we can actually study the effects. We can actually study these effects. We'll hear a little bit more about this later in the program.
Amazing. Okay, so a third question is, one of our viewers on YouTube asks, how do eclipse glasses work?
Ooh, that's a great question.
So these things.
Yeah, we have eclipse glasses. Okay, so you see the lenses right here. This is a mylar film, and the coating on it blocks over 99% of the white light that comes here. Not only that, but it also blocks infrared and ultraviolet light, so it keeps your entire eye safe. So it's really that coating that keeps us safe from the powerful sun's light.
I'm glad.
Yeah, me too.
Thank you so much, Michael.
Of course.
So remember, wherever you're watching in the show, ask a question in the comments below using the hashtag AskNASA, and we'll be answering more later today. So now let's head back to Tahira and Gina in Kerrville, Texas.
Thank you, Joy and Michael. The weather looks great in Albuquerque, New Mexico.
It does, yeah.
So, folks, if you're just joining us, we're following the 2023 annular solar eclipse as it sweeps across the Americas. Now, coming up soon, James at our eclipse desk will be plugging us into our very first views of annularity taking place in Eugene, Oregon. Now, Gina, as we anticipate this beginning first moment, can you walk us through what exactly is happening when an annularity takes place?
Sure. So when the annularity is taking place, that's when the moon is going to be in front of the sun. Now, for the annular eclipse, it's not going to completely block the sun, so we'll have that ring of fire that we get to see in the sky. And if you take a look at that live feed from the telescope that we're seeing right now in Kerrville, we already have a bite taken out of the sun from our perspective as well.
Wow, and so that's just going to pass directly over, but not fully cover it.
Exactly. We'll still have that ring peeking out.
Beautiful. And I mean, we're seeing something, but will anything else happen? Like, will we feel anything?
Yeah, so that's the fun thing about these solar eclipses is the fact that there will be environmental changes. So we'll feel that temperature drop, maybe a change in humidity and wind as well, but also nature will respond. So check out, how it feels around you. The birds will nest and go back to their trees. The crickets will come out, starting to chirp. It'll feel kind of dramatic when this happens too.
Can't wait to feel that with you today. And folks,
great.
I mean, it's not just us here on Earth plugged into today's action. Emily Ferfaro with NASA Communications had a chance to chat with two astronauts aboard the International Space Station to learn more about the sun from their unique perspective off our planet.
Jasmine, Satoshi, this is so exciting to be talking with you. This is the coolest thing that I've ever done. As you know, all eyes are going to be on the sun on October 14th as we experience an annular solar eclipse. And so I'm wondering, have either of you ever seen a solar eclipse of any kind?
Emily, actually, coincidentally, my very first day at NASA was August 21st, 2017. Which was an incredible solar eclipse. All my classmates and I got to go outside and stare up with everyone. Pretty much everyone else at NASA was outside in those moments looking at the solar eclipse. So that's something I'll always remember.
Wow, oh my gosh, what an incredible first day that must have been. Solar eclipse events provide scientists with a unique opportunity to study the sun in different ways. So with that, I'm wondering, how do you study space weather and impacts from the sun on the International Space Station?
Well, Emily, from the International Space Station, we have a really unique vantage point looking back at the Earth. But also there are several experiments actually mounted right outside here on the Japanese experiment facility outside of the GEM module.
Regarding the space weather, specifically from solar flare activities point of view, a specialists on the ground kindly observe it continuously, and when there is a big solar flare, they notifies it of us, and we move to a relatively safe place on the International Space Station.
Wow, I am so glad that you're well protected up there on the International Space Station. I want to touch back on the annular solar eclipse. This celestial event kickstarts NASA's Heliophysics Big Year, which is a global celebration of sun science and a year where we're inviting the public to do as many sun-related activities as possible. And so I'm wondering, what is your favorite thing about the sun?
Well, Emily, for me, I don't particularly like the dark, and I don't particularly like being cold. So I'm a big fan of the light and the warmth the sun brings. We wouldn't be the planet we are without the sun.
Yeah, Emily, I echo Jaws, and I like the brightness and the warmth of the sun, and I'm looking forward to the next solar eclipse.
That reminds me of something that my friends in heliophysics say, which is that the sun touches everything. With that, I want to thank you so much for taking the time to chat with me today about the sun, and I hope that you both have a great view of the eclipse wherever you might be, and good luck with the rest of your mission.
Thanks so much, Emily. Have a good one.
Station, this is Houston ACR. Thank you.
I mean, how cool is that? Can you imagine seeing the shadow of an eclipse on Earth from space? It would just have to be incredible. Now, folks, the crowd is growing here in Kerrville, Texas, as we inch closer to our moment to witness that Ring of Fire effect in person. Now, it's a good time to check in with James at our eclipse desk. James, how are things looking on your end?
Hate to hear, yes, so we're still just a little bit away from the annularity here in Kerrville, Texas. Really cool to see the science going on in the International Space Station. Coincidentally, there's actually some really cool science going on just a little bit to the west of us in just a few moments in White Sands, New Mexico. And right now I'm actually joined by scientist Jamie Favors, who can walk us through exactly what we're about to see with this sounding rocket launch. Jamie, thanks so much for joining us.
Thank you so much, James.
Yeah, so is this your first annular eclipse?
It is, yeah, and first time launching rockets into an eclipse too, so.
Amazing, and we're about to have the first of 3 launches. I understand we're kind of timing these launches out to specific times here, right?
Yeah, so you're exactly right. So we'll have 3 launches during the eclipse, about 35 minutes before the peak. That'll be this first one, right in the middle of the peak, and then 35 minutes after the peak. Studying that upper atmosphere, the ionosphere, kind of see what are those impacts from the sun that really change, important features of the upper atmosphere that impact things like radio communications, satellite operations. Yeah.
And we just had a launch yesterday in Cape Canaveral, Florida, of our Psyche mission. That's going out into deep space, but these rockets, which just launched actually here,
Perfect.
this is just took off, so this is actually going to come back down afterwards.
That's right. So we're seeing first stage burnout here, about 6 seconds in. Blink out for a second, so the rocket's still moving along. There we see the rail, the pad that we just launched from. So as we're launching into space, we're going to start making measurements roughly about a minute into launch. So we're a few seconds in now. I bet we're getting pretty close to the second stage lighting off at this point to take us all the way into space. So roughly that 1 minute mark is where we start to do a lot of the science. The payload separates from the rocket. We have some deployables we'll release from that payload out at that point. We'll start moving that payload around in space so that it's starting to make good measurements. We have these booms or arms that come off of the payload, start making different measurements there of like magnetic structures, electric structures in the upper atmosphere, as well as temperature and density. One way to kind of think about this, what the shadow of the eclipse is doing in that upper atmosphere is it's creating these waves as all those temperature and density changes are occurring. So kind of think about it in the way of like a boat moving through the water.
Yeah.
We've all seen a boat move and you see the waves propagating out from it or moving away from the boat. That same thing is happening here with the eclipse and that shadow. So with those 3 rockets, we're launching one right before the boat moves through,
yeah, exactly.
one right in the middle of the boat coming by, and then one right after the boat moves through, or the eclipse shadow.
Sweet, and so we are just now a couple minutes away from actually getting annularity here in Kerrville, Texas. Our first view is actually going to be up in the Pacific Northwest, up in Eugene, Oregon. They are going to be experiencing this starting at around 9:17 local time. Jamie, thank you so much for joining us. Best of luck for the next 2 launches.
Yeah, thank you so much, James.
Back to you, Tahira.
Wow, I mean, if the day wasn't exciting enough, now we've got a rocket launch in the mix. It's
so exciting.
It's incredible. And I mean, what a NASA broadcast, right? And so thank you, James and Jamie. Now, Gina, we have a lot of great questions rolling in from our viewers online. How do you feel about taking a few?
Let's do it.
Okay, let's do it. So our first question is from Entertainment on Facebook, who asks, how often do eclipses happen?
Great question. Well, thank you for that. So there are actually eclipse seasons. And so we can get eclipses about 2 to 3 times a year. You might expect them to happen every time there's a new moon, but that's not the case because the orbit of the moon is tilted by about 5 degrees, which means sometimes the shadow is a little too high and it doesn't hit Earth, and sometimes a little too low. So we need those eclipse seasons as that sweet spot.
Okay, nice. And so I actually have a really great follow-up to that.
Okay.
Spectacular Science podcast on YouTube asks, how do you predict solar eclipses then?
Okay, well, it's actually pretty straightforward how to calculate the eclipses because we have a good understanding of the moon's orbit. We have a good understanding of the Earth's orbit and how that whole system is connected. And so we kind of take the geometry and the inputs that we have, and we're able to pretty accurately predict those eclipses. And so these are things that we can look out decades in advance to understand when eclipses can occur.
Oh, cool. And so how often would an eclipse pass in the same city? Do you know?
Well, so for total solar eclipses, it's very unique for an eclipse to pass more than, it's about once every 375 years that a location can experience it. So it's pretty hard to be in the same spot to see a total solar eclipse more than once.
Awesome.
Yeah.
So we have a user on X who asks, will the International Space Station photobomb the eclipse? That would look very cool.
Yeah, and so we just got to hear from the International Space Station, and the unique thing about our astronauts on board is that they have a totally different vantage point for studying the eclipses, and they get to actually view the shadow of the moon as it passes over the Earth. And there are experiments that we have on board the space station as well. And so, with NASA, we have all of these different eclipse experiments that are taking place, and we try to take advantage of every perspective that we have.
Awesome. So we have a final question from Dante. This is going to be a quick one.
Okay.
But Dante on Facebook, who wants to know, will the moon block solar wind along its path during this Ring of Fire eclipse?
Oh, I love that question. So the solar wind is actually a stream of charged particles that's constantly coming off of the sun, and it interacts with the Earth and other planets in our solar system. Now, the Earth's magnetic field actually blocks a majority of those particles from interacting with Earth. Some are able to get through and interact with our upper atmosphere, but for the sake of the eclipse, most of the particles will still kind of be able to be deflected around the Earth's magnetic field. There will be some that are able to interact with the moon, but it wouldn't have a huge impact on what we experience at Earth.
Fantastic. Thank you so much, Gina. And thank you to everybody sending in these questions online. We will get to some more of what you want to know by later on in the show. So keep sending those questions in using the hashtag AskNASA. Now, let's check in with Joy and Michael to see what's new in Albuquerque. Joy, how's it going?
Thanks to her and Gina. So we're just under 30 minutes away from annularity in Albuquerque, New Mexico. Michael, shall we put on our glasses to see what the sun and moon are doing?
Yeah, let's do it.
Okay.
Okay, so you're seeing a deep partial solar eclipse. More than half of the sun is blocked out, and so you just see a crescent of sunlight peeking out.
Wow, that is amazing. Annularity is just going to be stunning. I can't wait.
Oh, I can't wait either. This is terribly exciting. You can see a balloon inflating behind us. We have annularity coming. It is all coming together today.
I just can't believe that an annular eclipse is happening at the same time as the fiesta.
It really feels special, doesn't it?
And actually, earlier this week, I even got to fly in a hot air balloon, which is just amazing.
That's fantastic.
I met an amazing balloon pilot, Jonathan Wolf, who's been launching balloons in Albuquerque for decades. So let's take a look at our ride. So for complete newbies, how does a hot air balloon work?
It's a great question. It's physics, simply. We heat up the air inside the balloon, and that makes it less dense, and then that makes it float. Now, what that means, though, is we can only control up and down. The way we fly and the way we navigate is by choosing different layers of air to fly in.
And I've heard that there is a box, the Albuquerque box. Could you explain what that means?
Certainly. It's one of the reasons why Albuquerque is a famous place for ballooning. Sometimes what happens is at a higher elevation, the wind is going to the north, and at the surface, it's going to the south. That's what we call the Albuquerque box. Sometimes the box works out such that you can fly to the south and go up, fly to the north, and then come down and fly back south and land right where you took off, which is an extraordinary and wonderful accomplishment. It's super fun when you can do that.
So for someone who's never been in a balloon, what is it like?
It's unlike any other form of flying. In a balloon, you're actually outside, right? You're standing in a little basket and there's no windows. You're just out there in the air, and it's just science, right? It's buoyancy, like I said, it's applied physics, but it feels like magic.
It's a ballooner eclipse.
Oh yeah!
I love that.
It's very calm. There's no movement, no wind. When you're moving with the wind, so you're at equilibrium. It feels very calm and peaceful. At the same time, it's really exciting and it's intense. So it's this wonderful combination of intensity and mellow, serene, tranquil beauty, absorbing nature. You can never experience that in any other form of flight.
Wow, that brings back great memories. And if you can hear the wind behind us, they're actually inflating the balloon I rode in just behind us, which is so cool.
So was that your first balloon ride?
It was my first balloon ride, yes.
Oh my goodness, how did it go? I remember taking one about 20 years ago and it was fantastic. What was your experience?
The most surprising thing is that when you're up there, you don't feel any wind against you,
right,
because you're actually moving with the wind, so it feels completely calm.
Oh, that's fantastic. So would you do it again? I found it terribly relaxing.
100%, yes. So it was actually also not that chilly, and we were only a few hundred feet off the ground as well.
Wow, that's amazing, because it's been chilly here all morning.
So as we learned earlier, NASA's scientific balloons fly much higher. They actually reach a part of our upper atmosphere where our International Space Station lives and where some of our satellites fly as well. So it's really important we learn about this upper region and how it could affect our lives on Earth. And NASA and NOAA are two agencies in the US that work together to help study this. And I'm joined with two people who can tell us more. So we have Dr. Elsia Talat from NOAA and Dr. Kelly Corrick from NASA. Thank you both so much for joining us.
Very excited to be here.
Very excited to be here. Thank you so much.
So let's start off with the basics. Elsia, what are those changes we see in that upper region?
Well, part of what we call space weather, which is the variable conditions on the sun, the Earth, and near Earth space due to solar and geomagnetic activity and storms. And that can affect human activity and our technological infrastructure.
Wow, fascinating. So, Kelly, how does space weather actually affect our life here on Earth?
Well, Elsa had alluded to the fact that it challenges our technology. So our power grids are sensitive to those currents that can be induced by this, as well as our satellites could also be impacted by these flares or the space weather. And we get some beautiful things too. We get the aurora out of it.
Nice.
Have you ever seen the aurora?
I have. It was absolutely beautiful. I laid on the ground for hours in the snow watching it.
So talking about space weather and the activity in our upper atmosphere, how do NOAA and NASA work together to better understand those phenomena?
Well,
let's start with,
NOAA is a go-to resource for space weather information. It watches the sun and the Earth 24/7, and it's the nation's official source of forecast warnings and alerts for space weather to help decision makers prevent and mitigate the effects of space weather here on Earth. And in order to do this, we need information, and NOAA works with NASA to design, develop, and deploy space weather operational satellites to safeguard our society.
And what's NASA's role?
So NASA is a partner with NOAA, and we focus on the science and make sure that we're understanding our star and can do better and better predictions. So scientists use models and the data from all of these satellites in order to better understand space weather.
And what are some of the biggest mysteries around space weather? What don't we know about it?
Oh, there's so much. I mean, let's start at the sun, right? That's the focus today. Even how to predict flares long term, or those large coronal mass ejections, those billions of tons of material that come off. We don't quite know how to predict them for a long term yet.
Well, I'm so glad we have two agencies on the case. Thank you both, Elsa and Kelly. Thank you both for joining us. So, did you know that space weather is also affected by solar eclipses? One citizen science project does experiments during the annular solar eclipse and the total solar eclipse. So let's learn more about that project.
When the moon blocks the sun during a solar eclipse, there is a noticeable impact on Earth's upper atmosphere, known as the ionosphere. These changes can affect radio communications, including amateur radio, also known as ham radio.
Ham radio is a way you can talk to people all around the world. You set up a radio and antenna. You talk into the radio sends a signal up to the antenna sends a signal up to the sky. It bounces off of the electrified layer of the sky back down to Earth, where you can talk to the person on the other side.
During the 2023 annular eclipse and the 2024 total eclipse, the Ham-Sci Citizen Science Project is inviting ham radio operators to transmit radio signals. The goal is to have people make as many radio contacts as they can with operators in different locations during these celestial events. By recording how strong their radio signals are and how far they go, ham radio operators and scientists can learn about how the ionosphere changes during solar eclipses.
Sometimes you can talk around the world and sometimes you can't. And that's all based on what the ionosphere is doing, what the sun is doing. When it works and you are able to talk to these faraway places, I find that really magical.
To learn how you can participate, follow Do NASA Science on X and Facebook.
There are currently ham-sci experiments happening right now across the country, and there'll be more during the total solar eclipse on April 8th, 2024. If you want to learn how to participate, go to hamsci.org. So next, we're thrilled to be joined with the acting director of NASA's Heliophysics Division, Peg Luce. Peg, thank you so much for joining us.
Oh, it's such a pleasure.
So, how are you feeling about the annular eclipse today?
Wow, it's happening, and we've been looking forward to this for so long. These are a rare celestial event that people can actually experience the effects of, so it's really exciting.
I'm so excited.
I am too.
So we've been chatting about the sun all morning, but can you tell us in detail what heliophysics is?
That is a good question. Many people ask. Heliophysics is actually a word that isn't yet in the dictionary, so we want to put it there. But helio is the sun. Physics, the science of matter and energy and how they interact. So we study the sun, how it works, how its energy flows out and affects all the planets, creates the solar system. And it's a very complex field and very exciting to study.
So we heard earlier that the sun touches everything. Can you describe a little bit about how the sun touches other NASA science disciplines?
Yes. So we like to say that heliophysics is really the science that interfaces and collaborates with all of the other areas of science that NASA studies. For instance, the sun is a star. And it's the only star that we can actually study up close. So for our astrophysics friends, we can learn in detail how our star looks, how it changes, how dynamic it is. So when they're using their tools like James Webb Space Telescope to study distant stars, they have up-close information from what we have learned. And then, of course, the sun's energy flows around all of the planets. It interacts with the Earth. Space weather affects the atmosphere of the Earth. And so it really is a collaborative and exciting field of study.
I love that the sun touches everything at NASA. So how does NASA touch everything we have here on Earth?
So I like to take this opportunity to remind people about NASA science. So most people, when they think of NASA, they think of astronauts and human spaceflight, which is, of course, so exciting. But NASA science is rewriting the textbooks all the time. We have so many discoveries and just so much. We have a Parker Solar Probe that is flying through the corona of the sun. We have the Voyagers that are outside the heliosphere. We have so much to learn that I could never even begin to talk about it. But I want to invite people to go to NASA at Home and check it out. You'll get just a little bit of more information about all that NASA science does.
It's an exciting time for NASA science.
It really is.
Yes.
Thank you so much, Peg.
Thank you.
So now let's head back to the eclipse desk in Kerrville, Texas, where they're about to start tracking the start of the annular eclipse across the United States.
Thank you, Joy, Michael, and Peg. And Joy, you are absolutely right. Folks, we are moments away from the start of today's annular eclipse in Oregon. Now, I know I'm excited. This will be the first time I've ever witnessed one of these events, and I hope you are too.
It'll be my first annular eclipse as well. But Tahira, I was lucky enough to see the 2017 total solar eclipse, and that experience was amazing. So I think we're in for a treat today.
So this is going to be a totally new experience for you.
It will be, yeah.
And so, Gina, actually, you know what? Let's go ahead and see if we can pull up the telescope feed from our friends at Time and Date. Wow.
Look at that. San Diego.
Oh, San Diego. We've got a live view of San Diego, California right now. What a beautiful partial eclipse.
Yeah, I mean the sun, it's a crescent. Normally we refer to the moon as a crescent moon, but this time it's the sun.
And I mean, normally we see, you know, the sun in the sky, the moon in the sky. Occasionally they might be together, but to see them overlapping, it really reminds you that we're a part of this just entire system.
I know.
And so
interplaying together, right? And you can tell, I mean, from this view, you can really appreciate the fact that from our perspective, the moon and the sun seem to look like they're the same size, even though in reality they're not, right?
It's incredible. You know what? Right now, let's go ahead and check in with James at our eclipse desk. James, what's the latest?
Yeah, hey Tahira, so we have officially kicked off annularity here in the United States. If we look at our Eclipse Explorer, you can see that the area of effect of that annular eclipse has now hit Eugene, Oregon. They should have a phenomenal view there. And just a reminder to all of our viewers who are in that region, the Pacific Northwest, be sure to use your eclipse glasses as you're looking at the sun and the moon above. You should have a beautiful sight at this moment. That's going to last for just a couple minutes, so really take advantage of that big moment. You just saw that view in San Diego. Even if you're outside of this area, you might still have a beautiful view of a partial eclipse. And if I zoom in onto our little area of annularity, you'll notice kind of a couple little bumps and things here, which you might initially think is because it's low resolution. Maybe it's a little bit, you know, low res here, but the inverse is actually true. We actually have an incredible amount of data feeding into our Eclipse Explorer to generate the images and the predictions that you're seeing on your screen. This tool takes into account two unique things. One is obviously the topography of Earth, so mountains, river valleys, all kinds of little divots and things as that shadow moves across the land. But also, and really interestingly, it takes into account the shape of the moon. When you think of the moon, you might just think it's perfectly circular, but there are so many little objects like mountains and craters and all kinds of things dotting the surface that are all being fed into this prediction that you're seeing here that will then show you exactly what the shadow is going to look like. You won't really be able to see this difference from the ground, but if you're up in space looking down at this, you'll actually be able to see that area kind of ripple almost as it's moving across the terrain. So definitely I encourage you to check out this tool. It's a really phenomenal one that's really just using so much data to feed into this. And again, even if you're outside of this area, I encourage you to use our tool to kind of predict what you're going to see. So if I scroll all the way over to the East Coast and I zoom all the way out here, you can just see just how large this area of partial eclipse is. This kind of outer circle that you see here is areas that might be having a partial eclipse. So if I click on, for example, Philadelphia, I know quite a few people watching there. It looks like it might be a little bit rainy, but if the sky clears up for you, you'll have a peak coverage for your partial eclipse at around 1:21 local time. So still plenty of time for you to get your glasses ready in order, get your pinhole projectors created. You had that instructions earlier in the broadcast, and really just take advantage of this incredible celestial moment. These don't really happen very often, so it's a really unique experience to be able to witness this live from here in Kerrville, Texas. Just a few moments, we'll actually be able to have that view from right here. I can hear the crowd already kind of buzzing. People have all their glasses ready to go, already kind of looking up and observing that partial eclipse. You just saw the coverage in San Diego. This is really sweeping across such a big area of the United States, and it's going to continue to move closer and closer and closer to us. You can see already since I've just started this conversation here, we've already moved away from Eugene, so they are no longer in annularity, and this is continuing to move into parts of Nevada. This will then continue to track further southeast to our friends out in Albuquerque at the Balloon Festival. They'll have a phenomenal view there, intermixed with the balloons and everything. It'll look awesome. And And you're also seeing right now our live view of Kerrville, Texas. You can see we're already in pretty good coverage here with the partial eclipse. If I click on Kerrville on our interactive map, you can see that we're expecting our peak coverage of the annularity to begin at 11:50. And I'll remind you again, if you're using our interactive tool, these are all clickable too. So if you wanted to click onto those and to see exactly what time and exactly what it's going to look like, actually, this is a prediction of what it's going to look like in your neck of the woods. And so actually the path you're seeing this moon taking is the exact path it's going to look like the moon's taking in real life for you. So that little googly eye is showing that directionality. So for us, the moon has already entered in from kind of above the sun here. It's going to continue tracking down, eventually giving us that incredible ring of fire effect. I can't wait to see this live. This will be the first time for me ever seeing an annularity live. I'm super excited. So the hit is coming up again in Albuquerque, New Mexico. In just a little bit, they'll get a phenomenal view there. Keep tracking it. But for now, back to you, Tahira.
Incredible, James. And I mean, I think earlier you said buzzing. Like, Gina, it feels like the town is coming alive.
It is.
It's starting to get a little colder here.
I know, I'm kind of chilly.
So,
I mean, looking around, you can just see people are kind of lounging back with their safety eclipse glasses and just taking it all in and getting excited for this.
And not only will Kerrville see today's annular eclipse, they're also positioned to see the total solar eclipse next year, right? Like, how awesome is that? And so, folks, let's take a look at how the city has been preparing in the lead up to these special events.
Kerrville is the eclipse capital of the state of Texas. It is known as being the capital of the Texas Hill Country. It's the epitome of Texas. Ranches, deer, beautiful streams like the Guadalupe here.
Kerrville is very welcoming.
It's a wonderful community.
Tight-knit, small.
It has about 25,000 people.
Kerrville is blessed to be in that special square. Not only are we going to witness the annular eclipse in 2023, we're also going to witness the total solar eclipse in 2024.
We're talking about crossroads, you know, we get it twice.
Two eclipses is coming right here, right where I stand. Well, it's statistically extraordinary.
We get two in less than 6 months.
Everybody's excited about it. City council, county commissioners, everybody's working diligently to be able to provide safe opportunity for the influx of people.
This will be the biggest event in the history of the city, and that's why the city is preparing. We're preparing to make the event enjoyable for everybody who wants to see this tremendous natural phenomenon.
I think that Kerrville has done an awesome job of preparing, way in advance.
It's getting that message out to people to make sure that they're taken care of personally, but then there's the science part of it, letting them know what is an eclipse.
And I'm just having a great time going out and talking to civic organizations and clubs and talk about eclipses. So this will be my 4th and 5th solar eclipses.
I've seen total eclipse in Nebraska. I drove 1,200 miles for a little over 2 minutes, and it was well worth it.
And just couldn't believe the experience of the eclipse. I mean, it's still just, it literally gives me goosebumps every time I talk about it. It's a visceral, emotional experience that is just, you have to experience it to understand.
I thought I knew what it would be like, but I gasped at the sheer wonder.
It's going to be a, you're going to hear that intake of air and awe.
It was the most beautiful natural thing I've ever seen. So to have an eclipse basically in my backyard is just, it's indescribable.
As you can see, the town is alive, preparing for these spectacular moments. Now, Gina, the sun not only impacts us here on Earth, right?
That's right, Tahira. So the sun impacts our entire solar system. And in fact, when we explore with NASA, that's something that we have to take into consideration.
So I'm glad you said exploring, because I actually just recently learned that the sun even impacts human exploration in the solar system, which I thought was really cool. So let's take a second and see how studying heliophysics is actually helping us prepare for sending humans to the moon and Mars under our Artemis program.
NASA has studied the sun and its influence throughout our solar system for decades. The Artemis program will provide a better understanding of solar activity through 2 new missions. Hermes is an instrument package that will monitor space weather from the moon and be placed on NASA's Gateway, an orbital outpost being built for lunar operations and eventually Mars exploration. The dual spacecraft ESCAPADE mission will examine the effects of solar wind on the red planet's atmosphere. Heliophysicists at NASA are working to protect astronauts who will travel to the Moon and to Mars by increasing our understanding of the space environment through which they must travel. With safety ever at the forefront, the agency is using spacecraft observations and simulations to better understand space weather. That's a look at your Artemis Moon Minute.
Folks, I've learned that it is almost time for Annularity to make its move into Albuquerque, New Mexico. We've got Joy standing by at our other desk who is going to tell us about an upcoming NASA mission and show us live views from this solar eclipse. Joy, Michael, on a scale of 1 to 10, how excited are you right now?
I think I'm about a 20 right now. What about you, Michael?
Oh, I am so excited. You can see the light changing. It's getting a little bit chilly. I am so excited.
I cannot wait.
Yeah.
So now we're joined with NASA scientist Dr. Nikki Weil, who's going to tell us about a new sun mission. Firstly, Nikki, how are you feeling today?
It is so amazing to be here. I'm so excited to be able to be a part of this festival and witness the annular eclipse.
So Nikki, what is the PUNCH mission and what does it stand for?
So PUNCH is a NASA small explorer. It stands for Polarimeter to Unify the Corona and Heliosphere. So the corona is the outermost atmosphere of the sun. It's the part of the sun that you get to see during a total solar eclipse when the moon totally blocks out the main body of the sun. And then the heliosphere is the bubble carved out by the sun as that corona turns into a solar wind and fills our solar system.
So I know that PUNCH has a big outreach effort as well, especially looking at humanity's interaction with the sun and observing the sun. Can you tell us a little bit more about that?
Yeah, humanity has been studying the sun and the moon and those different cycles for millennia. And one place where there's a lot of evidence of that studying of the sun is over in Chaco Canyon here in New Mexico. And actually our PUNCH outreach team, some of our PUNCH outreach team is over there in Chaco right now, where there's just so much evidence of ancient and modern sun watching. The ancient sun watching there evidence is on the rock of the sun, there's this petroglyph of what we think might be the 1097 total solar eclipse that actually went right over Chaco Canyon on a path similar to the annular eclipse today.
That's
and then
amazing.
of course, the modern sun watching is what we're all doing here today, and of course our Native American partners on the PUNCH outreach effort that still honor some of their traditional sun watching efforts, and then of course our NASA missions like PUNCH and Parker Solar Probe.
That's amazing. And you mentioned PUNCH shows and studies the sun's atmosphere, the corona. Why do we need to study the sun's atmosphere?
The corona is amazing because it is hundreds of times hotter than the photosphere below it, the surface of the sun, the part that we should never look directly at. So that's amazing. That's like if you walked away from a fireplace and it got hundreds of times hotter. Now, we know it has to do with the magnetic fields rooted down in the sun, but we don't know exactly how that energy gets into the corona. So that's one of the things we're really interested in studying.
Right, so we're looking at a live shot on camera of this eclipse. We're getting really close to annularity. So what are you looking forward to as a scientist when you think about eclipses and especially with the new mission coming up?
PUNCH is going to be so amazing because it's going to take images of the corona and that plasma as it fills the solar system in regular white light, like we could see it with our eye if our eye were sensitive enough and if the moon always blocked out the main body of the sun. But it doesn't, and that's why we need NASA missions like PUNCH to do that for us.
Fantastic. I can't wait for the mission to launch.
Yeah, me neither. I'm super excited about it.
So we're like we're moments away, minutes away from the annular eclipse here. Nikki, thank you so much for joining us. I hope you enjoy the annular eclipse.
Yeah, thank you so much. This has been great.
And I hope you keep safe from the wind. The wind has kind of picked up right now. So yes, so the skies are clear, the wind has picked up, but we have a clear view of the annular eclipse. So remember, The annular eclipse is moments away from Albuquerque and the sun is never completely covered. So during the eclipse, you have to keep your eclipse glasses on the entire time. You can also use other indirect viewing methods too, like a pinhole projector if you don't have eclipse glasses. So Michael, do you have your glasses ready?
I have mine ready.
Great. So now let's go to a full screen view of the telescope here in Albuquerque. Wow.
Wow.
We are minutes away and you can see that the ring of fire is almost here.
Yeah, the sun is just egressing over into the moon, or the moon's egressing onto the sun. We're getting closer and closer. The light here on the ground is visibly different, and looking up at the sky, where we see a thumbnail moon. It is, or thumbnail sun. It is gorgeous.
Wow. The ring of fire, the almost ring of fire, it looks so sharp and clear with our beautiful skies today.
Yeah, it really is almost that Johnny Cash moment. We're getting close to the ring of fire. It is really beautiful to see happening in real time as well. This is one of those events where I can sit and watch and see how the moon is progressing and see that changing.
I can't believe that the moon, we can actually see the moon moving in front of the sun right now. You can literally see it. It's just incredible.
So as we approach annularity, you might be able to see Bailey's beads. These are bright points of light of the sunlight coming through the valleys on the moon itself, right before the annularity begins.
You can even hear the crowds in the background. You can just feel the atmosphere building up.
Yeah, it is palpable. Everybody is super excited here. I know I am just thrilled. We are just in the final countdown. You can hear some people starting to cheer and starting to get all pumped up themselves.
Wow, the ring of fire is almost here. I'm just going to take my glasses off briefly, and you can see the crowd. Everyone is just staring safely at the sun right now. It's just amazing that we're all united looking at this amazing celestial event.
And make sure you take a look at the shadows around you. You're going to see these crescent shadows everywhere as different objects create natural pinhole projectors. And so make sure that you do have a moment to take a look at the world around you, because there's a beautiful rings. So let's take a minute and just be quiet and enjoy the view. It is a gorgeous sight to behold.
Everyone is cheering. This is so amazing.
Yeah.
Wow.
Yeah.
This is amazing. You can hear people screaming in the background.
People are so excited. And take off your eclipse glasses safely, of course, and make sure you look at the shadows around you, look at how the environment has changed, and just make note of this entire event.
Wow, this is so amazing. This really puts our planet in perspective with the whole solar system, you know?
It's truly spectacular. It's one of those natural phenomenon that I just feel so lucky to be here at this place at this time to be able to observe it.
Wow, I'm just looking at a tiny pinhole below, and I see a little ring, like a little spotlight. This is so cool.
You can see ringlets dotting everywhere around here. See people taking pictures of the ground.
How are you feeling, Michael?
Oh, this is spectacular. You know, we've been preparing for this event for so long to actually be in this moment and to be experiencing it live is just tremendous. Joy, how are you feeling?
I'm just in awe. You know, I can feel the temperature drop, and this ring of fire feels so long. It's just about 4 minutes long, and it feels just incredible that we are seeing moon right in front of the sun right now.
So that moon's shadow is traversing across the ground at a few thousand miles an hour, almost Mach 3. So even though it seems like it's lingering, it's actually making really good progress, and pretty soon our colleagues in Kerrville will be seeing annularity too.
Wow, and the crowd, everyone is still staring, looking at the annular eclipse. I love that everyone is here together, enjoying this together. Wow.
Yeah, you can almost hear a little bit of an awe and reverence among the crowd. Like initially there was a bit of cheering, and then everything got a little bit quieter as people took in the sight. I think that, you know, as people experience this event, it strikes both, you know, personal but also communal, and it's a really beautiful, beautiful event to see.
I would say we have about thousands of people in the fiesta today and hundreds on the museum grounds. Everyone is just excited about this eclipse, and it's just so lovely to see.
I think also what I really love to do is to look at the crowd and see everybody looking up at the sky with their glasses on in the same place. It's just, it's fun to do a little bit of people watching as well.
Yes. Wow, this is a perfect ring of fire. It's just so crisp.
Yeah, it's fantastic. I'm so excited for the science that is going to be coming out of this too. Of course, I always come back to the science, and this opportunity to have the moon covered to this extent is going to provide us really amazing data about how the sun and moon and Earth how they interact with each other.
Oh my goodness, we have about 30 seconds left of annularity here. I just want to absorb this moment.
It's so fast and so slow.
Definitely. Wow, what a sight.
Sometimes you just have to take a moment to take it in.
Yes. Oh my goodness. Well, we have a few more seconds left of annularity in Albuquerque.
Yeah, we're closing down on the last little bit. See if you can see a Bailey's bead possibly popping up right as that edge of the moon it aligns with the edge of the sun. Just seconds left. Really such a gorgeous sight.
It really is. Oh, that is going to be a moment to remember.
Absolutely.
So Kerrville is going to be experiencing this very, very soon. So let's head back to them in Kerrville, Texas to see what they're up to.
Oh, I mean, Joy and Michael, like, I got goosebumps watching you experience annularity, and Gina, like, that is about to be us soon.
It's true. I mean, so Tahira, we're about 550 miles away from them, and we will have annularity in about 10 minutes because, as Michael said, the moon's shadow is traveling more than 1,000 miles an hour. Everyone's so excited.
Yeah, as you can see, the crowd is just getting excited for today's opportunity. And folks, it's starting to get dimmer here. Like, it is going to be amazing.
Yeah.
So, Gina, other than sheer beauty, why do we observe eclipses at NASA?
Well, NASA can learn a ton of different science from the eclipses. So let's talk about exoplanets for a second, because when we study exoplanets, we are actually using eclipses. The planet itself is passing in front of its host star, and so we can learn about the exoplanets. There are eclipses on other planets in our solar system that we can study, but here on Earth, the science that we're able to do will inform us about the upper atmosphere and how it responds to the sun. So really understanding kind of that sun-Earth connection. We can do lunar science as well, and of course, solar science, learning more about the sun.
So eclipses are touching Earth science, planetary science, sun science.
Everything.
It's incredible, and NASA's studying it all.
Yes, exactly. We take advantage of that, for sure.
Absolutely. I mean, spectacular sight, spectacular science.
Yeah.
So, folks, we have James standing by at our eclipse desk with a telescope operator who's going to show us the next city experiencing annularity. James, how are things looking?
Yeah, hey Tahir, I just had a quick look outside. It is really surreal here. It's kind of hard to process exactly what we're seeing because it's daytime, but it feels like it's not. It's starting to get already very close to annularity. You can hear a lot of screams behind me now. Right now, we're actually getting the annularity in Roswell, New Mexico. They should have a phenomenal view outside right now. And I'm actually joined by a telescope operator who's been providing a phenomenal view for us all morning with her telescope. This is Kat Troche. Thank you so much for joining us today.
Thank you so much for having me. This is so exciting.
Yeah, it's really mind-blowing seeing it. And so you have quite the setup. Could you walk us through exactly what you have outside for us?
Sure. I have a Celestron 6 SE. It's a Schmidt-Cassegrain telescope with a solar filter on the front and a DSLR camera that's streaming to YouTube.
And so a Schmidt-Cassegrain telescope's a bit of a unique telescope. Usually you think of kind of like a long cylindrical thing, but this concentrates the image in a different way, right?
Right. So it's a little bit more compact. It's definitely designed for astrophotography in mind. And how it works is there is a glass corrector plate in the front. It's clear glass. And the light from anything that you're looking at, whether it's planets or in this case today the sun, will travel through the corrector plate to the primary mirror that's at the back of the telescope. Then that will bounce back into the secondary mirror that is attached to the corrector plate on the front, and then it'll go through again back into the diagonal that's attached to the DSLR camera or an eyepiece if you're looking at it.
So a pretty complex process, and also you have to have special protection for the telescope itself because you're used to looking at pretty dim objects. What do you have set up for that?
So I have a white light solar filter, and it is incredibly important. Just like protecting your eyes, you need to have solar equipment for your telescope or your camera if you're photographing the sun.
Yeah, and so also this is obviously moving really quickly across our sky. You just heard from Michael that this is really quite a quick event here. So how do you keep it in the field of view of the camera?
Well, thankfully, the remote control that's part of the telescope actually has a city database set up, so I can program it for city and state, and Kerrville was actually listed.
Look at that. Very awesome. And yes, so you can see it's already moving very quickly towards us. This is where annularity is going to be currently taking place. You can see we're next in line here, coming up in just a little bit. So very excited to continue tracking this across our skies. Thank you so much for providing this awesome view for us all morning. You can really see it's really getting close now. It's got this beautiful crescent to it. Usually we're used to a crescent moon. We've got a crescent sun today. I mean, really awesome. And in just a few moments, we're going to have the ring of fire of annularity. Very excited to have that. Thank you so much for joining us, Kat.
Thank you.
And back to you, Tahira.
Thanks, James and Kat. Now, we have about 6-ish minutes, 6:30, until annularity makes its way here to Kerrville, Texas. As you can hear, the anticipation is high.
They're so excited.
And so, Gina, as we count down to the big moment, let's take a few social questions.
Let's do it.
Okay. So we have something to see here on X, who asks, am I seeing a couple of sunspots on the telescope feed?
Yes, so you are seeing some sunspots. As I look at the live feed, maybe not so much right now because the moon is blocking most of the sun, but when the moon wasn't covering as much of the sun, you could see some darker spots, some black spots here and there, and those in fact are sunspots, which are areas of really intense magnetic fields, and the surface of the sun is actually cooler, which is why they appear darker than the rest of the bright sun that we see. Now, we heard a little bit about space weather and some of that solar activity that's coming towards Earth during, some of the sun's activity, and basically these sunspots are where that activity can come from. And right now, the sun is in the part of its solar cycle where more of those sunspots start to appear. So the sun goes through an 11-year cycle, where it becomes active and then where it becomes less active. And right now we're inching towards what we call that solar maximum. And so more and more of those sunspots appear, and that's what we're seeing today.
That is incredible. And I mean, again, talk about activity. Gina, this crowd right now, like folks, if you could see it, I don't know if you exactly.
There you go.
We have folks looking up already with the eclipse glasses on. You see the live telescope feed in your on the screen right now. We are moments away. What I think is super cool, we've even got some folks out here with their own telescopes and cameras to really capture this spectacular event.
Yeah.
And so again, it looks like we've got about 4 minutes. The crowd is growing, and I'm interested to see how everything kind of calms down too. So we'll see. Gina, I have another question. This is from Baron on YouTube, who asks, does a solar eclipse have a material impact on the atmosphere?
Oh, I love this question, because with the eclipse, we really are trying to understand the Sun-Earth connection. And so you can almost think of the eclipse as a controlled experiment. Basically, the fact that we often, experience changes in our atmosphere during the nighttime, but the eclipse is almost able to turn off and on the sun. So
even right now, we were blasted with the sun earlier, and now it's just
chilly.
like it's darker.
Yeah, and so it's the upper atmosphere that we're really interested in understanding, and the energy and the radiation from the sun creates what we call the ionosphere, this upper part of the atmosphere that's filled with charged particles. And so when the sun's radiation is not hitting the atmosphere, that ionosphere, it changes in its density, its temperature, and we're really trying to understand those changes, and the eclipse gives us that opportunity to really turn the sun on and off, which we can't do
in
in
a little
any other
experiment
circumstance.
that honestly all of us also get to be a part of.
Right?
So that's really cool.
It is.
Thanks, Gina. So our next question is from Hunter on YouTube, who asks, does the solar eclipse affect the moon when it happens at night?
Okay, great question, Hunter. So today, as we're experiencing a solar eclipse, that means that the moon is between the sun and the earth. Now, the lunar eclipse that can take place is when the moon is actually on the other side of the earth. And so today we're experiencing that solar eclipse, and we see that the moon is very dark.
And it looks like, too, we're getting a live feed.
Looking at that feed.
All of another annularity taking place right now. Odessa, Texas. Wow.
Oh, there we go.
It's cool to see this comparison right now. What is that? What's on the side of the screen?
We might have some solar activity.
Is that a Bailey's bead?
Yep.
Or solar activity? Wow.
Wow.
That's incredible. It is leaving Odessa right now and heading
It's coming our way.
Us,
You
Gina.
can
Oh my
see it
goodness.
in the other live feed that we just have that teeny tiny sliver of the sun left peeking out.
Wow. We've got about 2 minutes here, folks. As you can hear, the crowd is chanting and counting down until our moment right now. Oh, that is beautiful.
It's coming in so quickly, too.
And you can
And I'm going to grab those glasses so that I have them.
Okay, wow. So before we hit our moment and peak in annularity, folks, it's a good time to give a reminder that it is never safe to look directly at the eclipse without proper eye protection when watching even a partial or annular solar eclipse directly with your eyes. You must look through safe solar viewing glasses or a handheld viewer at all times. Do not look at the sun through a camera lens, telescope, binoculars, or any other optical device while wearing eclipse glasses. Wait, 1 more minute, folks. If you don't have eclipse glasses, you can use an indirect viewing method like a pinhole projector, which has a small opening and will project the image of the sun onto a nearby surface. You just heard it. We are under a minute away from the annular eclipse making its way across our area into Kerrville, Texas.
It feels like it's gotten here so quickly. We've been counting down.
I know.
And now we're less than
It
a
is
minute.
beautiful. And so, again, you're witnessing firsthand the moon passing between our star and the Earth. And we're taking this full screen right now. Gina, let's take this opportunity and get a closer look.
All right.
Oh my gosh,
And looking
this is
around,
the
I mean,
first
everything
time.
is so dim. Oh, wow.
Oh my God. Wow, you know, like, why am I emotional right now?
Oh, there we go.
Oh my God, this is...
I mean, it doesn't look real.
I didn't think I would cry. Like, what the heck is going on? Wow. This is...
Wow. It looks great.
I mean,
you can just see. It looks like a perfect circle of the sun peeking out. It really is that ring of fire that we have here.
Wow. Gina, I thought I'd have goosebumps, but I'm like literally shaking. This is crazy.
I know. I agree.
So, I mean, this
And
is
I'm
your
just-
first annular eclipse. I mean, was it what you expected?
It is to hear. I mean, we've seen all of the photos from previous annular eclipses, but just as I look again, I mean, it's incredible how the moon and the sun are able to line up like this.
And again, I mean, the moon is way smaller than the sun, but right now it's really giving it a run for its money.
It is. Yeah.
Why is that?
Well, so a little fun fact about our moon that's pretty incredible. It's 400 times smaller than the sun, but it's also 400 times closer to the Earth.
No
and
way,
that
400
is the magic number here, yeah. The fact that 400 and 400, that means in the sky, the moon and the sun appear to be the same size. And that is unique to us on Earth. No other planet in our solar system has that ratio that makes it so special.
So you're saying that if we viewed an eclipse on another planet, it wouldn't look like this?
It wouldn't. I mean, I'm sure it would be great to see, but it would not look as spectacular as this.
Wow, okay, I'm gonna turn behind me really fast.
Yeah, looking around. And you can just see everything. The shadows are a little bit different. It's dim. You get this hazy feeling, but the sky is still blue. That's what's strange about it.
Oh, it's so sweet. We've got parents like holding little eclipse glasses on their kids to look up. This is just, it's really amazing how just like, I don't know, a natural phenomenon can really make the world pause for a second.
Great.
Wow.
You heard the cheering and now it's quiet
now
again
it's
as people are just looking.
And so for us, this is going to last about 4 minutes until it crosses, right?
That's right.
And why is that? Is that the same in every city or?
Yeah, so there's actually the length of the maximum eclipse can change based on several factors. I mean, each eclipse is unique. And so one thing has to do with where in the moon's orbit the moon is, because the moon's orbit isn't circular. So it will go faster and slower at different parts. And that will make the shadow travel at different speeds. Also, where the shadow is landing on Earth will have an impact, because if you're at the equator, you're going to be rotating much faster than if you were at the poles. And so for that fact, it changes the length of that maximum eclipse too. And that's true not just for annular eclipses, but for the partial eclipses, for the totality, for total solar eclipses as well. And I imagine, you know, our folks at home getting some of those partial eclipses are also having a great experience too.
Wow. I don't know what I expected, but it wasn't this. Like, this is incredible. And so, Gina, I'm sure, I mean, you're in heliophysics, sun science. I'm sure some of your teams are studying today's eclipse. Like,
oh yeah, absolutely.
So, what kind of science can only happen right now, you know?
Right. We've heard about the sounding rockets that are experimenting.
Oh,
you know,
that's right.
today,
We saw one, yeah.
studying the upper atmosphere. And so we're really interested in knowing, like right now in our location, as that radiation from the sun's being blocked, how does the upper atmosphere change? And so in addition to that, I mean, we really want to understand how those sunspots, what's going on when they're covered versus when they are not covered. We can tell the difference in that radiation that's coming from the sun. And so there's so much science that we can do.
And this is just, folks, this view is just so incredible. Before we fully pass through this transit, let's check in with James at our eclipse desk. James, I know you are seeing this. What do you think?
It's truly a surreal moment. It feels like almost nighttime. It's been really breezy, chilly.
That was so
the shadows
awesome.
are all like little rings as well. It's just a beautiful sight. Kind of hard to put into words the exact feeling. I mean, we've been preparing for this for a while. We've, been tracking this all morning with our Eclipse Explorer, but actually to see it in person and to take it in, it's a really incredible moment, and this only lasted about 4 minutes. You can see on our Eclipse Explorer, this is already passing off of Kerrville, heading further southeast to parts of the Texas coast on the Gulf. And the morning is far from over here. For a lot of folks in Central America and South America, their morning is just starting off here. The partial eclipse is affecting still a large part of the region. You can see this whole area that's highlighted here in the larger ellipse here. That's all being affected still by that partial eclipse. And you can see on our track that this is going to continue moving further southeast all the way into parts of South America before the morning's over. it's been just incredible tracking this. And actually, Kerrville, we're in the path of the total solar eclipse for next year. So if I turn on the path for next year, you can see X marks the spot here in Kerrville. We're going to be coming right back here to witness this incredible cosmic event once again, getting that incredible view. Just really, again, very hard to put into words just how amazing this is. Just a stunning experience, and it's been an honor to be here with you this morning, tracking this event as it's moved across. We started the morning in Eugene, Oregon. Now it has arrived and already passed us in Kerrville. I'll continue to track it for a little bit longer here, but for now, back to you, Tahira.
Thank you, James. And folks, this is just the beginning. Today's event kickstarts NASA's Heliophysics Big Year, which is a year where we're encouraging people to do as many sun-related activities as possible in the lead up to next year's total solar eclipse. Now, Joy and Michael in Albuquerque are going to share some of the ways you can play a part. Joy, what can we look forward to?
Now that the annular eclipse is here, the fun has just begun. So today is the official launch of NASA's Heliophysics Big Year. This is a year-long celebration of solar science, and it's modeled after the Big Year concept from citizen scientists in the bird-watching community. So they're challenged to see as many birds as they can, but in the Heliophysics Big Year, we're challenging you to do as many sun science-related activities as possible. And so one way to participate is through NASA's citizen science projects. Here are a few sun-related ones you could join.
Did you know that you can participate in solar eclipse science with NASA? NASA's citizen science projects are collaborations between scientists and members of the public, no matter your citizenship. Several volunteer science projects are gearing up for the 2024 total solar eclipse that you can join. Total solar eclipses don't just look cool, they provide a rare chance to see the sun's faint outer atmosphere. Using telescopes and cameras that are safe for viewing the sun, volunteer scientists across North America will capture images of the total solar eclipse. Scientists will study these images in detail, tracking how plumes of solar material move through the sun's atmosphere. But be careful, without proper tools and techniques, you can damage your eyes and your camera. Did you know you can listen to an eclipse too? Amateur or ham radio operators will send radio messages to one another during the eclipse to see how changes in the upper atmosphere distort radio signals. As the moon blocks one portion of the sun, it can make other portions easier to see. Working with local scientists at an observatory in Southern California, participants will observe magnetic hotspots on the sun as the moon passes over them, revealing details they normally can't detect. Want to learn more? Follow Do NASA Science on X and Facebook to see how you can get involved in NASA citizen science.
So as you can see in the telescope view, the moon is now moving away from the sun, which is really, really amazing that we're still seeing this partial eclipse.
Absolutely, and I think I can see a sunspot in there too, and I think on one of the earlier shots, I could see a prominence. So we're seeing NASA's sun science happening in real time.
So we're getting some amazing questions online. Shall we ask some more?
Yeah, let's get into it.
Answer some more. Okay, so we have a question from Peter Chang on X, and they ask, can filtered telescopes see flares on the sun during totality?
Oh, that's a really good question. The answer is yes. It depends on what filter, though. So if you use just a white light filter, then you have to have an exceptionally large flare in order to be able to see it. If you use a filter like an H-alpha filter that specifically selects one color of red light, then you're going to be able to see flares a little bit more frequently, even even during totality as the corona adjusts to that flare as it erupts.
Okay, so we have time for one more question. Yuri on X asks, if a solar system had more than one star, would they have more solar eclipses? Would they all look like the same eclipses that we have here on Earth?
Ooh, that is getting a little sci-fi, but that's okay. So if we had more than one sun, you'd have to have a moon to block both suns, or maybe two moons to block both suns. So you'd have to have a very complex geometry to get everything lined up perfectly so you could get solar eclipses with two suns and two moons, and oh, it would get very complicated.
Thank you so much, Michael.
You're welcome.
Okay, so now we're joined with NASA's heliophysics lead, Denise Hill, who's going to tell us more about how you can participate in the Heliophysics Big Year. Hi Denise, how are you today?
Great. Did you see that? That was my first annular eclipse, and we got a prominence. I am so stoked. That was the dopest thing ever. Okay, okay. Heliophysics big year. So, as you've heard before, the sun touches everything. And the Heliophysics Big Year is a celebration, a global celebration of sun and sun science and what we have going on. But it's also, I think I heard you say it, Michael, it's about the community and being communal and just the unity of hearing everybody cheer. The sun touches us all in so many different ways. And so the Heliophysics Big Year is going to help us kind of discover all the ways the sun touches us scientifically, but in other ways as well.
And why is it a big year for the sun?
So you saw what just happened, right? Oh, well, that's nothing. Coming up in April 8th, we have the total solar eclipse, and then Parker Solar Probe's closest approach, which will end out the Heliophysics Big Year, but it's the mission that has literally touched the sun, and it's going to be making its closest approach. And then from there, every single month during the Heliophysics Big Year, and it's a big year because it's more than 12 months, but during that time, we have themes for on different ways people can explore the sun and how it touches them. So we have themes like fashion. We're going to be delving into physical and mental and emotional health. The sun touches us in so many ways besides. And then we have missions. In just a couple weeks, we have our AWE mission that is launching, and it's going to be the first space weather station on ISS. And we are so excited. You have no idea.
Wow, there's so many new NASA events and opportunities coming up. Is there any other like science events that maybe people could get involved with themselves?
Yeah, for sure. So we've talked about citizen science a bunch, and that is one of the ways for sure for people to get involved and to do NASA science with real scientists. And then there's also, like, you are a scientist. Every single one of us is a scientist. And we're going to share ways that you can explore the sun, do your own little scientific investigations yourself. And so, yeah, the science is going to be front and center. There's also going to be some other things as well.
That's great. So what are you most excited about in this upcoming big year?
For me, it's the unity, right? Like the sun touches, it doesn't matter what race you are, what ethnicity, what culture, religion, whether you live in a rural community, urban community, it doesn't matter. The sun touches us all. And we like to call it our extraordinarily ordinary sun, because our sun is supposed to just be ordinary. But it is responsible and touches every living thing on Earth. And no other star that we know of has that level of responsibility. So that gives me hope that you can be ordinary and have an extraordinary impact.
That's amazing.
Well, I think our sun's pretty extraordinary by itself, so I don't know.
Thank you so much for joining us, Denise.
Thanks for having me.
So if you want to learn more about the Heliophysics Big Year, you can visit go.nasa.gov/heliobigyear. Michael, are you excited for the Heliophysics Big Year?
I am so excited because I get to be a rock star for an entire year, and then I go back to being a normal scientist again. No, it's going to be fantastic for science, for outreach, for everything. I am so excited for this.
Well, the Heliophysics Big Year has so many opportunities for folks around the world to get involved with NASA science, especially during the 2024 total solar eclipse. And one group of citizen scientists will be using their sensors to make observations. They'll gather sound recordings and help with data analysis to understand how wildlife will be impacted by solar eclipses. And you can help them too, no matter your citizenship. So now let's learn more.
During a total solar eclipse, it is almost like day becomes night very quickly.
So knowing that there's going to be a change in that light and life-giving energy means that we can predict when animals are going to have a rapid shift in their behavior,
which results in changes in the acoustic environment or the soundscape.
So the Eclipse Soundscapes project is a project to determine how eclipses affect life here on Earth.
And there's a lot more to observation than just what you see. It's also important to think about what you hear.
We're measuring how the rapid onset of darkness during an eclipse affects wildlife by measuring the changes in sounds that they make.
The general public is best suited for this type of project because the general public is everywhere.
And that's really the power of the participatory science component of this project. It enables recordings and observations of soundscapes across the diversity of ecosystems covered by the path of totality. we might think of some ecosystems having a greater influence of human activities on the soundscape, whereas in other ecosystems, say a remote part of a national park, we might have a lower influence of human activities and greater influence from the sounds of life and Earth.
The only way to properly preserve a species is to understand it. The only way to understand it is through scientific study on their behavior, their patterns, and their habitat requirements. One of the things we'll be doing during the total solar eclipse is setting up these recording stations. So these are our acoustic monitoring stations. And what we're doing is listening for calls of the different bat species with the hopes of maybe picking up some of those endangered species like the northern long-eared bat. We're hoping the results of this study will inform us about the health of our bat populations on Hot Springs National Park and help improve future conservation efforts.
The Eclipse Soundscapes project is an inclusive and accessible project that is inviting the general public to get involved in NASA science alongside scientists and subject matter experts.
Wherever you take your observations, you might be giving us information that has never been recorded before. And that is really useful and interesting to a scientist.
Wow, that sounds like an exciting project that anyone can get involved with. So if you want to learn more about Eclipse Soundscapes or any of other NASA's other citizen science opportunities, go to go.nasa.gov/HeliaBigYear. Well, thank you to everyone joining us online and here in Albuquerque, New Mexico. It's been an unforgettable day, hasn't it, Michael?
Oh, it certainly has. I will never forget this day. It has been just a day full of activity and memories that will last a lifetime.
So although the annular eclipse is over in Albuquerque, we still have one more day left at the Balloon Fiesta and 1 year to participate in as many sun signs related activities as possible in the Heliophysics Big Year. So now let's head back to Kerrville, Texas, where Tahira and Gina will chat about the upcoming total solar eclipse. Thank you so much for joining us, everyone.
Thanks, everyone.
And thank you, Joy and Michael. I mean, it sounds like we have so much to look forward to over this next year. And folks, even though peak annularity just passed in Kerrville, Texas, we are still getting an incredible view on this live telescope feed. You can see the moon is now passing over the sun and honestly on its way to make another city's day. Now, it is a good point to remind folks that X marks the spot here in Kerrville, Texas, where the 2024 total solar eclipse will pass in just 6 months. This very lucky city is in the path of totality and will be one of the places to witness the moon completely blocking out the face of the sun and darkening the sky as if it were dawn or dusk. Now, Gina and I are here with NASA Chief Scientist, Dr. Kate Calvin, to learn more about what we can expect for next year. Kate, thank you so much for being here with us.
Thanks for having me.
Great to have you. And so, Kate, can you start off and just give us an idea of what science we can expect only for a total solar eclipse?
So one of the things that scientists are really interested in studying is called the corona. It's a part of the sun's atmosphere. It's the source of heat and particles that come towards Earth. But normally it's too bright, and so you can't really observe it directly. Scientists use instruments called coronagraphs to block some of that light, but it's still hard to see parts of the corona.
It's not the same as a total eclipse?
Yeah, the total eclipse gives the best environment for studying the corona.
Right, but we were so lucky to just see that prominence coming off of the sun.
And what is the prominence?
And so that's actually some of that solar particle, some of the particles coming off of the sun, the ejecta, and we can kind of see it hanging there, which either turns into an eruption, some of that activity that we can observe, or it can kind of just quiet down as well. Yeah. So, Kate, can you tell us, how can the public get involved with the total solar eclipse?
Oh, that's a good question.
Yeah, so we have a number of citizen science projects. These are projects where people anywhere around the world can help contribute to our science. You don't have to be in the path of totality to contribute. We have projects for everyone. And they're different projects. Some of them you need cameras or telescopes or equipment. Others you can use just with your cell phone. And so we have one project that's called on the Globe Observer app. It's to help understand the effect of eclipse
eclipses on Earth's weather, and you can do that just with your phone.
Do you need a science background, or?
Anyone can contribute. We walk you through what you need to do, and sometimes it's as simple as taking a picture or recording a sound. And so you can all contribute to our science.
So anybody can get involved?
Anyone can get involved.
Perfect. And then can you tell us a little more how the eclipse science that we're doing will help to inform kind of the broader science at NASA?
Yeah, and so like I said, we're trying to study the corona, this source of heat and particles towards Earth. They affect Earth. They can disrupt electronics. They can lead to northern lights. So we're really interested in that in Earth and understanding the effects on Earth. But there's also the sun affects other planets and bodies in the solar system, like the moon and Mars. And so when we think about exploring the solar system, we want to understand the sun and its role in it.
Wow, that's incredible. I mean, we have so much to look forward to next year. I want to know real quick, what's your peak excitement for next year's total solar eclipse? You know, we'll start with you, and then Kate would love to hear your thoughts.
Sure. So I'm really excited to compare what we saw today, that annular eclipse. How does it compare to that total solar eclipse? You know, I got to see a total in 2017, but every eclipse is unique, and so
such a scientist.
I know.
Want to do
that
a
is
little
my experiment. How many data points can I get? But not just that. You know, we're hearing everything about the heliophysics big year, and so it kicks off today. And that total solar eclipse in April will be the next event. So how many events can I participate in for the heliophysics big year?
Amazing. What about you, Kate?
I'm interested in sort of the things beyond just what you see, but what you feel, so that it's going to get cooler, and we might hear some
Even
animals.
Today, we felt that.
Yeah, and I really want the full body experience of the eclipse.
That is incredible. And I mean, today has been a spectacular day. So folks, let's check in one last time with James at our eclipse desk to see how he's doing. James, what's it like?
Yeah, Tahira, I'm still in awe of the moment that we just had here a couple minutes ago here in Kerrville, Texas. Just a stunning view of that ring of fire here. And as you can see on our Eclipse Explorer, the annularity has now shifted off into the Gulf of Mexico. So if you're in a boat out there, you'll have a phenomenal view. But we're going to be here once again next year, April 8th, 2024 in Kerrville, Texas. I've got the path of the 2024 total solar eclipse up here on the screen. You can see it's tracking right through us in Kerrville and then affecting an entirely new area here that is going to be stretching all the way up to parts of New England, all the way up to Maine, even parts of Canada. So a really large area there as well. So definitely save those pinhole projectors and certainly keep a hold of those eclipse glasses. You're going to need them for next year. We're going to be right back to cover all of that incredible stuff next year with you. It's been amazing tracking this today. And again, this is still moving onwards to Central America and South America. So if you're tuning in from there, you have a great view incoming. And in many parts of the country, there's still that partial eclipse. A truly awe-inspiring morning and a wonderful day for all. So thank you so much. Back to you, Tahira.
And thank you so much, James, for bringing us into the action during today's show. Gina, so wow. I mean, this was both of our first experiences. So final thoughts.
I mean, what a day. At this point, you know, I'm ready to look at those calculations for the eclipses and check out not only April, but what else can I see in the future, because these are spectacular to
A little
see.
eclipse chaser now.
Exactly.
You
I'll
know?
chase them around the world.
No, and it has been so fantastic having you on today's show to
Thank
really
you.
just like help break down what we are experiencing today. And
Of
so
course.
again, thank you so much for everything.
Thank you for having me.
And folks, the action isn't over yet. You can continue to watch views of today's annular eclipse as it moves across the path by visiting go.nasa.gov/eclipse 2023 live. That live stream will continue running until 4:30 p.m. Eastern as this eclipse continues its way through Central and South America. Now, unlike today's Ring of Fire effect, we are going to witness the moon completely block out the face of the sun during next year's total solar eclipse. The sky is going to darken as if it were dawn or dusk. You can learn more about eclipses and what's in store for April 8th, 2024 by visiting go.nasa.gov/eclipses. The total solar eclipse is sure to be a rare event and one you will not want to miss. So stay up to date with sun-related events and how we are studying our star by following NASA Sun on social media. Folks, thank you to everyone who has tuned in to today's coverage of the 2023 annular solar eclipse. We hope to see you back here next April as we ring in the last total solar eclipse that will pass through the mainland U.S. for 2 decades. Now, here's how you can celebrate the countdown to April 8th by joining our heliophysics big year.
We are one of 100 billion stars in a vast galaxy, but for all of human culture on Earth, one sun that nourishes us all.
That is what stirs humankind. That's what unites us.
Experience the wonder, the beauty, and the power of our star.
One sun across space, time, and culture.
Let us continue the quest to unfold this universe. And let us continue to find unity in our discovery.
You're looking at live pictures of the sky above the Utah Test and Training Range. In less than an hour, a 4.5 billion-year-old piece of the ancient solar system will be landing here in the desert. This is live coverage of NASA's OSIRIS-REx sample return.
There's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Welcome and thank you for joining us live from the Army's Dugway Proving Ground in Dugway, Utah. This is special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space. I'm Lauren Ward, and joining me is Dr. Jim Garvin, Chief Scientist at NASA's Goddard Space Flight Center. He's a planetary geologist by training and also probably one of the most excited people around here today.
Lauren, literally, I'm over the asteroid.
Better than over the moon, over the asteroid. Well, I'm excited to share the stage with you today. We've got a lot to discuss and a huge adventure straight ahead. And for those joining at home, Jim and I will be taking your questions live throughout the show. You can send those our way by using the hashtag AskNASA on X, YouTube, and Twitch. And if you want to follow along this final guide of the mission at home, scan the QR code on your screen and check out NASA's Eyes on the Solar System, where you can view a complete 3D simulation and follow the OSIRIS-REx sample return capsule to the ground. And during the broadcast, you'll hear directly from the mission team, so listen very closely for those operational callouts. Before we get into the action, though, tell me, Jim, what are you most excited about?
Lauren, it's the masterpiece of engineering we have here. Just think about this. In 50 years, we've gone from bringing things on the moon back with crews to all robotic sample return for science that's literally beyond words. It's sublime. So we can't wait to see what we're going to learn.
We cannot wait. So OSIRIS-REx is an acronym for Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer. Yes, it's a mouthful, but the mission describes an audacious objective. Send a probe on a long journey to an asteroid, map it, grab a sample, then bring it back to Earth for analysis. Following launch on September 8th, 2016, the plucky probe took an extraordinary route through the solar system until it reached the asteroid Bennu. Then, after more than a year of mapping the surface in exquisite detail, OSIRIS-REx made a careful descent in October 2020 to collect a sample. 3 years later, we are here at Dugway Proving Ground in the deserts of northeast Utah, awaiting that capsule containing the sample, which experts tell us is essentially a time capsule of the ancient solar system. We've got a great team joining us this morning as we experience this thrilling conclusion of this grand adventure. Sophia Roberts is located near our landing zone, and she'll be speaking with some key players in the mission. We'll also hear from James Traley, who will be tracking mission operations and bringing us real-time updates, essentially our eyes and ears inside mission control, which sounds to me like a good place to jump into the story. James, good morning. How are we looking?
Yeah, good morning, Lauren and Jim. It's already been a very bright early morning for all of our team members involved in this mission. Just a little bit further north from us, about 4 hours ago in Waterton, Colorado, the team met to assess the readiness to release the SRC from the main OSIRIS-REx spacecraft. And I'm very happy to report that they gave the green light, they gave the go command officially to release the SRC from the OSIRIS-REx. Let's listen in on what that command sounded like. That command came after more than almost 4 billion miles of spaceflight and years of planning, plotting, and dreaming about this asteroid Bennu. The SRC has now been separated from the main OSIRIS-REx spacecraft and is coming in rain or shine today. So team members are keenly aware of the weather conditions out on the range. It's looking pretty great for today. We did have a bit of rain the other day, which softened up that landing spot just enough to make the SRC land perfectly smooth on that surface. The temperatures are going to be around the 50s, 50 degree Fahrenheit. Low winds out there, calm winds at the surface around 6 miles an hour, pretty light. Very clear skies this morning as well. As we were actually driving out, I saw a shooting star, a meteor, and in just a few moments, the SRC itself will be streaking across the skies as we begin to track it. Just a few moments ago, We heard the helicopters take off from here to head out to Wig just at the edge of the landing ellipse. Our high-altitude plane is up in the sky, ready to take images in the infrared of our SRC, and we are here ready to go to cover all of today's mission events. I'm going to be right here with you all throughout the process as we get closer to that entry, descent, and landing. But for now, back to you, Lauren and Jim.
All right, thanks, James. We'll be back to you for mission status updates throughout the morning. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. In less than an hour, the sample will touch down in our landing ellipse at the Utah Test and Training Range, managed by the Air Force, about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us, where the sample will end its journey today. Tomorrow morning, a C-17 aircraft will take off from the runway behind us and deliver the sample to NASA's Johnson Space Center in Houston.
Unbelievable.
Unbelievable.
Can't wait.
Oh, gosh. I can't wait to see that C-17. Oh, that's going to be breathtaking. We have a lot of ground to cover, and we'll be bringing you into the heart of the action. For all of NASA's many missions over the years, OSIRIS-REx lives in an extremely rare category. It not only ventured out into space with cameras and sensors, but it's bringing a physical sample of the ancient solar system back to Earth for detailed analysis. Mission planners selected a small asteroid called Bennu as their destination. Following a successful touch-and-go procedure to grab a sample on October 20th, 2020, OSIRIS-REx has been making its way back to Earth. It's been a thrilling ride, already packed with technical achievements and scientific discoveries. Today's historic landing continues that saga, promising exciting research ahead. Beside our main event this morning, we've got a ton of extremely cool stuff. We'll hear from a special guest astrophysicist whom you probably recognize more for his chart toppers. We'll speak with one of the helicopter pilots about his role in getting recovery teams out to the landing site and bringing the capsule back home. And we'll even hear from the cast of the film Asteroid City. And of course, we'll give you a front row seat to the mission itself, the science, the engineering, and why a mission to gather space rocks, well, rocks.
Right.
NASA's first asteroid sample return happens in less than 35 minutes. Let's now take you to Wig Mountain, where our field reporter, Sophia Roberts, is standing at the forward edge of the vast landing zone, where she joins us live now. Sophia, paint us a picture.
Lauren and Jim. Now, it is a bright and chilly morning, but the excitement certainly is rising. Now, let me give you a lay of the land of what is going to happen today. The sample return capsule is going to hit the top of the atmosphere at approximately 8:40. It will descend through our atmosphere for 13 minutes before touchdown. Once it does touch down, our team with the recovery team will go to the sample or the capsule and start that carefully rehearsed recovery process. Now, I am on the edge of the landing zone that we call the ellipse. It is a huge landing zone that is larger than the size of Rhode Island. And behind me are the helicopters that will be taking those recovery teams to the capsule once it lands. Now, these teams are prepped and ready to go. We're just waiting for that capsule to arrive. Back to you, Lauren.
Wow, Sophia, I think she has the best seat in the house.
Oh my God, take me there.
I want to go there. All right, let's get some quick facts about the OSIRIS-REx spacecraft. Filled with fuel, the vehicle weighs more than 4,600 pounds. That's about the same size as 3 large cows. Did you know that, Jim?
I did not, and I'm afraid of those cows.
Let's stay away from the cows. With its solar arrays extended, the spacecraft is about 40 feet long, or the size of a short school bus. The solar arrays can power up to 3,000 watts, which is the same as a portable generator. Once on Bennu, the 11-foot robotic arm collected dust and pebble samples, while the cameras got up-close images of the asteroid. How about that? And then, of course, there's the SRC, or the Sample Return Capsule, the capsule that's separated from the main vehicle and is currently on its way to our landing zone in the Utah desert. So, Jim, I think importantly, the team can't just open up the capsule right on the desert floor, right? What happens next?
So next, we have to safe it, we have to bag it, we have to contain it, and transport it to the clean room about a mile from here. And in that clean room, we will actually bring the sample return capsule in, take off the back shell and the heat shield, and carefully arrange to nitrogen purge that special sample container inside, so it does not introduce any contamination from Earth, because we want asteroid, not Earth.
That's right.
And I love missions like this because I find my own imagination just bursting with possibilities and questions. And so with about a little bit more than 30 minutes to go before the SRC hits the top of the atmosphere, we're going to take a few minutes to dive into the nuts and bolts of the mission itself. We've got a great mission overview to help explain. Take a look.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
Wow, I get chills every time I see that.
Me too.
Amazing. All right, so we know you have questions, so please continue to send them to us using the hashtag AskNASA. But before we go any further, I've got a question for you, Jim. Why is the mission called OSIRIS-REx? It sounds like a new hybrid kind of dinosaur or something.
It does, but it's actually the name of an Egyptian deity, a bird deity, but it means all the stuff the mission's going to be doing. So we're going to be searching for clues to the origins of our solar system chemically, looking at how we can ground truth all the data we have for asteroids from Earth, other spacecraft right up close with samples. We're going to look at the resource potential of asteroids, metals, hydrated water and hydrated minerals, and also consider security of our planet from these kinds of objects. It's a big name with a big mission with many things it has to do. It's multiple missions in one.
Yeah, 3 missions in one, in fact. We know we have a global audience for this event, and throughout the morning we'll be taking questions submitted via social media. So let's take one now. All right, what do we have? At S4Mule_B asks, what's the significance of studying asteroids like Bennu for advancements in planetary science?
These are literally the time capsules of the early solar system with those bits and fragments we can never get here. So we go and bring them home to connect ourselves to the place we live, our solar system. So that's one of the big takeaways of this. We will read the clues of Mother Nature on how our world works in the context of all the rest of the planetary system.
Fantastic. All right, let's take another question. What do we have? All right, from at ndanger817. Approximately how large is the sample size, and what kind of analysis will be performed?
So it's about 8 or 9 ounces. It's about a size of a baseball and a half, and the kind of analyses are amazing. There are toolkits and instruments that can look at nanoscale characteristics that you wouldn't imagine. We could see the hairs on a foot of an ant, but we'll look at those in the context of another object in the solar system. So, wow.
Wow, indeed. All right, we'll be taking some more questions throughout the morning. Okay, so let us head back to the ellipse to talk to Sophia. I understand, Sophia, you've got a critical team member with you. Take it away.
Thanks, Lauren. Yes, I am joined right now by Stu Wiley, who is the Oscar or on-scene commander of this recovery mission. Thank you for joining me, Stu.
Thanks for having me, Sophia.
All right, so you are the person who kicks off this whole process before even the recovery team gets on the ground. Can you walk us through your process?
Yeah, so essentially what's going to happen is that once the capsule is undershoot, we'll have a better idea of where it's going to land on the range. And based on that, I'll know exactly what kind of weapon systems we used in that area, what kind of tests we've done in that area. So I'll know better what kind of hazards are in the area. Once I land on the ground, I'll do an initial sweep of the area and methodically move towards the capsule and mark any kind of hazards that I find, whether it be munition hazards, of course, and or the industrial hazards, and even the environmentally sensitive areas that we have out here. So.
All right, and how did you prepare for this today?
So preparation has been in the process for a long time. Between myself and Jasmine Nakayama, we've got 40 years worth of explosive knowledge. Most of it is on this range here, so we know the ranges very well. The team and the UTR have been working together, both Lockheed and NASA, and we've been doing rehearsals so that we are more familiar with their capsule and they're more familiar with our terrain here as well. Yeah, so.
And this is an active proving ground here. So what are the other steps that we have to ensure that our teams are safe?
Yeah, so at the Utah Test and Training Range, we do have a lot of different hazards out here. Like I said, the weapon systems that we test. We're going to keep them safe from that. We have, again, done many of the preparations with them already. They've taken safety briefings. They've been briefed on the actual items that we've dropped out here in their range safety brief. One of the hazards that we're going to be dealing with, though, is the helicopters that you see behind us, and they've been through practices getting on and off the helicopters and working in and around them. But I think the biggest hazard that we're going to have is slipping. We had some recent rain, so that I think is going to be our biggest hazard, but it could be fun too. So.
Well, wonderful. I know that you have your last preparations for the day, so I'm going to let you go, and thank you very much for joining us.
Thank you, Sophia.
Thanks, Sophia. Stu's got a big day today.
Oh, my goodness.
A lot to do. All right, Jim, we know we have space fans from all walks of life all over the world. One super fan in particular is a well-known astrophysicist with an atypical side hustle. But I'm guessing you know him probably more from his side thing than his science thing.
Well, that's right. He's literally space royalty and rock royalty. Perfect for a mission to bring back rocks.
Just a true rock star. Let's let him speak for himself.
Hello NASA folks, space fans, asteroid aficionados. This is Brian May of Queen, as you know probably, but also immensely proud to be a team member of OSIRIS-REx. I can't be with you today, I wish I could. I'm rehearsing for a Queen tour, but my heart's there with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission. Especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking of rock stars, joining us is NASA's Lori Glaze, Planetary Science Mission Director. Welcome, Lori.
Hey, good morning.
Great to have you here, Lori.
It's great to have you. And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here. What an exciting moment.
Lori!
Thank you.
It is a really exciting day. So OSIRIS-REx is part of a larger autumn for asteroid autumn, as we've been saying. Can you talk about some of the other missions that are happening this fall?
Happy to do that. It is really exciting. We have lots of asteroid missions, and actually 4 of them have major milestones coming up this autumn. Right on the heels of the sample return happening today. In 2 days, On September 26th is the one-year anniversary of a little mission you may have heard of last year called the Double Asteroid Redirection Test, demonstrated for the first time humanity's ability to deflect the path of an asteroid. How cool is that? And then coming up on October 5th is the launch of a mission called Psyche, going to visit a special asteroid called Psyche also, which is one of only about 9 of asteroids that we think are made primarily of metal, have a very high metal content, iron and nickel. And then about a month after that, on November 1st, is going to be the first asteroid flyby of our mission called Lucy, which will ultimately visit Trojan asteroids that lead and trail Jupiter in its orbit around the sun. But in November, we'll fly by a main belt asteroid called Dinkinesh.
Wow.
Wow, check that out.
It literally is an asteroid arm. But Lori, one other thing, OSIRIS-REx, is a multi-purpose mission, all this great stuff you mentioned, and one of its key jobs is to help us with planetary defense. How does it do that? Way out there.
So actually, OSIRIS-REx gave us some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but the Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space, and that actually kind of acts as a force that kind of pushes back against the forward trajectory, and so it changes our predictions on where the asteroid might be. Over time, it really makes a difference, and OSIRIS-REx gave us some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable. Nobody appreciates the planetary defense aspect more than me and Jim.
Yeah, we want to be safe.
Big fans, big fans. Really, really quickly here. This isn't the end for OSIRIS-REx. What's next?
Yeah, so really exciting. Now that the spacecraft has released the capsule successfully, about 20 minutes after that release, we're now repurposing the spacecraft for a new mission called OSIRIS-APEX, where APEX stands for Apophis Explorer, and it's off on its new mission to explore the asteroid Apophis, which is going to have a close flyby of Earth in 2029.
All right, stay tuned, everybody.
Unbelievable.
That is fantastic. Well, thank you so much, Lori, for
Thanks,
joining
Lori.
us. You're going to stick around for the show, right?
Oh, absolutely.
Absolutely. Okay. This will be the biggest U.S. sample return since the Apollo mission to the moon. But this is not the first time that anyone has captured a piece of an asteroid. On the arrival of the historic OSIRIS-REx sample, we celebrate that the Japanese Space Agency, or JAXA, has already visited 2 asteroids, Itokawa in 2005 and the asteroid Ryugu in 2019. The missions Hayabusa and Hayabusa 2 proved that it could be done and paved the way for today's ambitious goals of this daring enterprise. All right, let's send it back over to James for an update on mission operations. Go ahead, James.
Yeah, thanks, Lauren. So everything continues to be nominal. I've been tracking the mission status here. Everyone looks dialed in, ready to go. You saw a few moments ago Sophia with Stu Wiley, our on-scene commander. He's ready to go. He understands the mission. They are ready to get out and recover that sample today. And as I mentioned earlier, just a few moments ago, actually I guess a couple hours ago at this point now, the SRC was released from the main OSIRIS-REx spacecraft. When that release took place, it was given an initial spin, which kind of preserves its angular momentum, its speed as it's coming in to Earth's atmosphere. It's similar to throwing a perfect spiral on a football, and teams are hoping for that perfect touchdown today. What you're about to see is basically the equivalent of throwing a touchdown pass over 10 football fields away and landing it perfectly in that end zone. So you can see on your screen now the mission operations team. They are just next door, dialed in, ready to go. They've been monitoring the vitals of the SRC all morning. They've been there in the room, prepared and ready to go. I'm sure they are absolutely thrilled for this moment. They might even see themselves on the screen there in a second, but they are hype and ready to go. This is the Lockheed Martin team just a little bit north of us in Waterton, Colorado. They are also dialed in. They're the ones who gave that initial command this morning to release the SRC from the main OSIRIS-REx spacecraft. You just heard from Lori that OSIRIS-REx is now on its way to its extended mission. OSIRIS-APEX visiting that near-Earth asteroid Apophis. A lot coming up in just a few moments. We're going to hit that key milestone of entry, descent, and landing. 13 minutes of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range. A lot coming up in just a few moments, but for now, back to you, Lauren and Jim.
Thanks, James. Very soon, NASA's Artemis program will be bringing us more cosmic samples to study by visiting a familiar beacon in the sky. Give us 60 seconds, and we'll give you the moon. Artemis 3 will be the first sample return mission of NASA's Artemis program, sampling rocks and regolith from one of 13 candidate regions on the moon, all located near the lunar South Pole. The Apollo lunar landers returned a treasure chest of samples that taught us about the history of the solar system, dating back about 4 billion years ago. Artemis missions will explore areas near the South Pole on the rim of the moon's oldest basin, the enormous South Pole Aitken Basin. Artemis will explore areas nearly 1 billion years older than those explored by Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the moon and Earth, as well as increase our understanding of planetary processes. OSIRIS-REx, the first U.S. mission to collect a sample from an asteroid, will return samples from asteroid Bennu. The rocks and dust collected will offer generations of scientists a window into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS-REx and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute. Boy, Jim, how can you not get excited about that?
Oh my gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Ah, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy that a mission like this has?
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
Big moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great, thanks, Sophia. Wow, I can't wait for Dante to get his moment in the sun.
Goes Dante.
That is amazing. All right, so Jim, the whole OSIRIS-REx spacecraft is not coming back today, right? It's
Absolutely.
just a part of it.
That's right. This is the whole spacecraft, 40 feet long, the size of a school bus. But this special little thing here, the sample return capsule, is bringing home the goodies. And that's what we've just released, and it will be entering the atmosphere, and you'll be hearing all about it. And the samples were collected at the asteroid back in October of 2020 from this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies, the sample return canister and the sample cap, the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent, to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is. And it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from Bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see
Right.
on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
It's the
but,
real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the OSIRIS-REx sample return capsule on its return to Earth. This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests predict. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12 kilometers per second, or about 27,000 miles per hour. That's nearly twice as fast as objects coming back from low Earth orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International, and universities in Australia and Germany, SciFly is coordinating 3 ground stations and 4 aircraft to collect data on the sample return capsule's trajectory, heat shield performance, and the plasma environment surrounding the capsule as it speeds to the surface, all of which will help NASA understand its performance and help future planetary entry missions succeed.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made to, a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to the Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation. Wow. We have a science team led by the University of Arizona. And then we have
recovery operations. Helicopter 1 has departed wing to station keep outside the landing ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science, an expert on how our planet works in climate, can you tell us how this asteroid mission, the samples we return, might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice. Being with the team and thinking about, this spacecraft launched 7 years ago. And now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard. And are you going to stick around for the show?
Awesome.
Fantastic. All right. Well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for all you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because of its
Recovery operations. Helicopter 2 has departed WIG. The station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent progress. Fantastic. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Okay, 2 of the helicopters have already just departed, so the team is already in the recovery process, or at least the beginning phases of it. But right now, we are waiting to hear precisely where the capsule is going to land before the rest of the teams head on over to that location. Now we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is 51 years since we've had such a pristine and large sample of ancient solar system material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational milestones we're expecting throughout the morning. SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. You know, we grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have a lot of critical events that take masterful engineering. We have to hit the top of the atmosphere, transition through a high G, high heat environment, go from 27,000 miles an hour down to eventually 11 for that safe landing. All these things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here. So we're ready to transfer tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, work from thousands of individuals who are making this happen. All right, so we know that you're submitting questions from all over. Let's take a few more social questions. All right, what do we have? At Dev Saran at 5342461. What are the preliminary steps to take to test a sample? The preliminary steps.
So first thing we do is, of course, bag it here and get it into the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today. Period of a few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks and samples of interplanetary dust and lots of things. Those colleagues, in a special clean room perfectly designed for this mission, will unpack those precious samples in the small sample canister, the small device that was used on the end of the TAGSAM, and they will go through a process to get it checked out, to do early reconnaissance, and to protect it very carefully.
That is incredible, and they built that whole clean room. No other asteroid samples before.
Right.
This is the first one.
First ever.
First ever. As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with exhilaration. This is a small step for a capsule and a giant leap for science.
It really is, and if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple call-outs come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles, getting reduced to the scale of mere miles, 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute.
waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS APEX spacecraft is at its closest approach to Earth. That will be on to its extended mission visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft. You can see our SRC. Streaking in. This is from our high altitude cam. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within, that just a few years ago was on the other side of the solar system from us sampling an asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see
PDL milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range, and now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57, and we should have a great view from here on the ground. We've got a variety of different tracking assets, and you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range. Looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, with a slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there, as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing
EDL milestone. We have touchdown. I repeat, EDL SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins of our solar system and potentially the origins of life. We're not in the clear just yet. A key piece of the mission is about to get underway. This is the recovery operation phase. Once the team has officially confirmed the exact touchdown location, they'll be flying out on 4 separate helicopters and will operate much like a Formula One pit crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep, collecting samples along the way. You see our mission ops team just next door. I'll once again remind you that the sample canister itself is not actually going to be opened here at Dugway. The next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag sim that just a few years ago collected pieces from the asteroid Bennu. Today, the goal is to get the sample canister.
Recovery operations. Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that landing ellipse. These helicopters will have a trip out to find that exact touchdown location of the SRC and begin those recovery operations. Stu Wiley, our on-scene commander, will be the first person to approach that SRC. He'll do an environmental safety sweep checking for unexploded ordnances. As he mentioned in his interview earlier with Sophia, he understands this range. He's worked here for a number of years. He will brief the team on any possible dangers that would be presented to them as they begin those recovery operations. And then a team member from Lockheed Martin will begin to take gas and thermal readings once the area is safe of that SRC to determine whether or not it is at safe operational levels for the rest of the team to begin the recovery operations. As I mentioned, this is going to be simultaneous action. The team has prepared. They're all going to be wearing these bright white UV shirts, sample recovery shirts, and you'll see them walking out to that sample in just a few moments here once those helicopters land. A great view once again from our high altitude plane. You can see the parachute there next to our SRC. There is a possibility that there could be unexploded ordnances from that parachute. There is a mortar inside that is to fire to disconnect the parachute from the main SRC to help it come to a final rest. It's a bit challenging to see from this perspective, but there could be some potential roll marks or skid marks as that SRC came to a rest on the rugged desert surface below. As I mentioned, we did have a bit of precipitation here the other day, so that should make for a nice soft surface for that SRC, so it probably had a nice clean landing there. The team will assess as they get out there and check exactly how our conditions are for the SRC and the surrounding area. You heard Stu mentioning the team might need to wear some boots. The operations could get a little bit slippery as they begin to recover that sample. And this is a pristine sample from the ancient solar system and could hold the clues to how everything around us came to be, from the formation of the planets to the origins of life here on Earth. Needless to say, this is precious cargo, and the recovery team is fully aware of the gravity of the situation and the importance of what they're about to do today with these recovery operations. You can see it looks like our parachute has come to a stable rest. The winds were pretty low today, so it looks like it is not billowing at all. It is almost perfectly flat, at least from this perspective, on that desert terrain. And throughout all these operations, the crew member safety is paramount. So you'll see the team probably huddle up a couple times as they begin these recovery operations to make sure that everything is safe and continues to be nominal as they make their initial safety sweep. All of this recovery should be a very quick process, usually. They've rehearsed for this again for months. They've been out here all summer really rehearsing for this moment. They did a drop test last month. They've also had numerous rehearsals actually practicing containing that SRC, getting it on a sample carrying fixture.
Recovery operations, WV has located the parachute on the ground.
You just heard that confirmation from that high altitude plane locating that parachute on the ground. This location info will be relayed to our team members aboard those helicopters as they begin their approach out to the landing zone. We do have that confirmation from the high altitude plane, as you just heard. We're still working to get confirmation from our NASA helicopter. It is on its way out to that landing zone as we speak, so we should hopefully have that view up in just a few moments. You continue to see our team just next door, the mission operations team, all looking at that high altitude view. Right in the middle there, just pointing around with the UV white shirt, is Rich Witherspoon from Lockheed Martin. He has been leading a lot of these operations for the past couple months. He's been preparing the team for this exact moment and really has been a great leader helping us get ready for these recovery operations. Yeah, so this ellipse here, this landing zone, is a quite large setup here, and this was chosen intentionally for this mission. It's about 37 miles by 9 miles total, this landing ellipse, out in the Utah Test and Training Range here in Dugway, Utah. This is an enormous facility. As you heard earlier, it's about the size of Rhode Island, all in all, this whole facility. It's relatively flat, very smooth terrain, this desert surface. So it's perfect for bringing something back and having that nice, safe landing on the desert surface. Just a few years ago, the OSIRIS-REx spacecraft back in 2020 made its tag attempt, the touch and go attempt to actually collect the sample that has now landed in this desert. When it did that, it was only at the surface for just a couple seconds, descending at a speed about 11 centimeters per second, just a little bit faster than a baby that is crawling. It's a very slow pace. But they were able to successfully get that sample and bring it from the edge of our solar system back to us here at that Utah Test and Training Range. You can see our full screen view here of that high altitude view, looking at the parachute at rest on the surface of the desert. This is at the Utah Test and Training Range. It's a wide open expanse here, and the team has this positional info, and they'll be relaying that to our helicopter teams to begin those recovery operations. And what you'll see in a couple seconds here, the recovery team, the recovery crews are responsible for securing the sample return capsule, the landing site around it, and helicoptering the SRC to a portable clean room that's located just next door here on the range. And just a little bit later on, it's going to be attached to a 100-foot long line beneath one of the helicopters, and they'll actually be flown to the clean room. This was determined to be the best possible way to transport that SRC safely and efficiently, to get it on a nitrogen purge and maintain the pristine nature of the sample within. As I mentioned, this is an enormous ellipse, 37 by 9 miles. It's a large expanse to cover by car. It's a very bumpy ride out there as you kind of start to make your approach across this rugged terrain. With the helicopters, it will be approximately a 20-minute flight back with that SRC. They take it at a nice, slow pace, effectively parading the SRC around, just giving it its last big moment as it is served its purpose officially at this point of getting that sample canister safely here to Earth. Once we actually land and begin those recovery operations, you'll see a lot of team members out beginning to take samples, both air and also soil samples from around the area. These are places of interest for the sample curation team that will actually open up the sample canister in the coming days down at the Johnson Space Center in Houston, Texas. They have a phenomenal sample curation facility there, and these samples from asteroid Bennu will join a historic collection of other asteroid materials, including samples from the Apollo mission, samples from both the Stardust and Genesis missions, as well as Antarctic meteorites that were collected by our scientists. In the coming days, we'll actually know exactly how much sample we got back from Bennu. The original mission requirement was 60 grams of pristine sample from the asteroid surface. Based on some very clever engineering, the team believes that they have potentially 250 grams, or 6 times that mission requirement, inside. And so we just heard that unofficial touchdown time was at 8:52 a.m. Mountain Time here at the Utah Test and Training Range in Dugway, Utah. If you're just joining us, you see that view right now from one of our high-altitude planes observing our touchdown location. On your screen just above that crosshair is the orange creamsicle-colored parachute that brought us the last part of our journey down to the surface of the Earth. You heard from Jim earlier that that main parachute is about 24 feet across. Fairly large parachute that helped us decelerate on our last leg of the journey. And so we just heard a confirmation, actually, that the main parachute deployed much higher than was originally anticipated. It was originally supposed to deploy at about 5,000 feet elevation, but it actually deployed at around 20,000 feet, so much higher up. So that would explain our kind of earlier touchdown time than expected here. Still has touchdown on the Utah Test and Training Range. Team members continue to fly out to this location aboard helicopters. As I mentioned, there are 4 recovery helicopters in total. The mission operations team is continuing to monitor the situation. They're the ones who are relaying us that info about that high parachute deployment, that 20,000 foot parachute deployment. They're going to be assessing the situation from their end here, relaying any possible info over to our recovery teams as they begin to make their trip out to our SRC. One of the first goals once the team gets out there is to safe and stow the parachute. Begin to mark places of interest, as I mentioned, for that curation team to begin sampling. This is all a very well-coordinated machine, very well-oiled machine that operates in tandem. They've rehearsed extensively for this moment. So we just heard from the team in that mission operations room that they have visual of the parachute, that orange parachute that you saw on your screen moments ago. But we do not yet have visual confirmation of the SRC itself. The team is continuing to survey the region, looking for that sample return capsule.
Recovery operations. Kilos 1 and 2 are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Preiser, who you see on your screen there from the mission operations room. He just announced that Kilos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments. Kilos 1 and 2 will be surveying this region, looking for both that SRC and also eyeing up the region, looking at that parachute that was deployed.
Recovery operations. All of the ground supported vehicles have left rig and are in pursuit of the landing zone.
So some more team members are going to be heading out to that landing zone as well in support of those 4 helicopters that will be the main group recovering that sample. The main helicopter will be actually attaching that sample return capsule once the team has it located and ready to prepare for recovery operations. They'll load that on long line. You can see once again, some team members pointing at items on the screen here. We'll hopefully get confirmation in the coming minutes of that SRC location. Tim Preiser pointing at the screen now, wondering if he has any more information for us on where that sample return capsule location would be. We do have visual confirmation of that parachute, as I mentioned. Rich Witherspoon radioing out to the team, and now we have a view from our helicopter of the landing location. You can see the sample return capsule dead center on your screen, that kind of dark gray black object right there. And then just to the right of it, a little bit below, is our parachute. It appears to be resting on the surface. We're getting a zoom in now from our NASA helicopter, and you can see now the SRC. At last, we have a visual of it on the surface of the Utah Test and Training Range. I'm sure that is a pleasant sight for the team to see.
Recovery operations. Hilo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protected it the whole way down through that entry, descent, and landing. Lockheed is celebrating that moment. I'm sure they are breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack of dawn, just a little bit further north from us in Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen right there from the OSIRIS-REx spacecraft about 4 hours ago. It then ventured entirely on its own and now sits on its own for us here in the Utah Test and Training Range. So now that we have visual, the teams should be able to begin the recovery operations in just a few moments. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it there, just a little bit off the edge of our SRC. The SRC looks quite charred up from that entry in. That was expected as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere. You can see a great visual of some of that rugged terrain out there. Just a sweeping expanse, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid regolith. This mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then actually transporting it back here to Earth for us to open up and analyze. The surface today was probably a little bit soft, so it looks like it's resting a little bit far off the actual desert. It doesn't appear to have dug in too much with that nose cone from the heat shield. You are here with us as we witness this historic moment. It's the first time the United States has delivered samples from an asteroid to Earth. And these samples will be analyzed for decades to come in laboratories around the world. And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Hilo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep. As I mentioned, our on-scene commander, Stu Wiley, will be the first person of the team to actually approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range, and then also make sure that that SRC is safe for our operations team to approach and begin recovery. You can see where that parachute disconnected from the top of that SRC. That is the back shield that you see right there at the very top with that little bit of white wiring still coming out of the top. Our SRC perfectly landed there on the Utah Test and Training Range. So what you're about to see happening next is the process of recovery operations. This is a key moment of today's events to actually get that SRC from out in the desert into our portable clean room here at Dugway. It is crucial that we maintain the pristine nature of this sample that we got back from asteroid Bennu. It could hold the clues to how everything around us came to be, from the formation of the planets to origins of life here, so the team understands just how crucial the contents of that SRC is, and they're going to work as efficiently and as safely as possible to get that SRC contained, wrapped up in thermal blanketing, placed in a sample carrying fixture, and then attached with long line to our first helicopter there. It'll then be transported the long journey back here, a much more relaxing flight, I'm sure, for our SRC, to our portable clean room at Dugway. At which point the team members will extract the back shell and remove the heat shield from the SRC. It's served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the asteroid regolith out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, on a nitrogen purge, and this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Kilos 3 and 4 have been cleared to land at the recovery site.
And the rest of the team is closely behind, ready to land at the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations. At least from this perspective, I'm not noticing really any drag marks or any kind of roll marks, but the team, once they approach, will mark any possible areas of interest where the SRC possibly came in contact with the rough desert terrain. All of these regions will be sampled by our recovery team and will be passed off to the sample curation team at the Johnson Space Center. As they begin to unload and actually open up the sample canister there, exploring the contents within and making sure that no possible contaminants from the surrounding landing location got into our sample. We're getting a wider view now. We should have the helicopters that have landed nearby coming into view potentially. The team really taking extra precaution as they approach the SRC. As I mentioned, team member safety is paramount during these operations. There are possible potential areas of concern as the team begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm. As I mentioned, it heated up to over 5,000 degrees Fahrenheit. So as the cool desert air begins to cool down that SRC, we want to make sure that it is cool enough for our team to actually begin those recovery operations. We'll also be checking the gas levels of that SRC to make sure that it is not outgassing from the batteries within, heating up during that re-entry. We'll also be making sure that there is no live voltage present. And we see a view now from our high altitude plane that has visual of those helicopters landed nearby, just at the northern part of your screen. You can see one of them on screen now. The top of your screen there, it is centered up. There is our helicopter, and it appears that we have our on-scene commander potentially walking over. This is once again our high altitude WB-57 shot of our helicopters landed at the LZ, our landing zone. You can see some movement on the screen. It appears some team members might be approaching our SRC at this point to begin those recovery operations, the initial safety sweep. We'll just be observing from this high altitude for the next coming minutes as the team actually will be setting up a camera on the ground for us to observe the recovery operations close up. And a note from one of the team members about the SRC itself. So they have approximately 40 hours. That is the amount of time it would take for any air to get into the sample. As I mentioned before, that sample return capsule is a complex network of piping and tubing inside of it, sort of like a labyrinth-like design, and that is intentional to make it incredibly difficult for any possible contaminants from the atmosphere to get into our sample canister. It's also sort of like a nesting doll, if you will, where it has multiple layers of protection that keep that sample safe within. All of that protective layering, once we get that sample into the clean room, will be shed, and we'll be able to actually access that sample canister within. The main goal, as I said, for today is to get that sample canister on a nitrogen purge. That is to maintain its pristine nature. And we have visual once again from one of our helicopters here orbiting around the landing location. You can see our SRC at the bottom left of your screen and its parachute that helped us get the last leg of the journey down. It deployed a little bit higher than we expected, 20,000 feet elevation. Original expectation was at about 5,000 feet. And this brought us down the last leg of the journey. After a punishing initial entry into Earth's atmosphere over San Francisco, about 82 miles in altitude, to now resting on the rugged Utah Test and Training Range desert floor.
Recovery operations. Recovery team is in the vicinity, beginning their initial assessments.
So you just heard confirmation from Tim Preiser that the team is beginning to actually approach the SRC for that initial environmental and safety sweep. You'll soon see our on-scene commander, Oscar Stu Wiley, approaching that sample return capsule. As I mentioned before, he'll be checking for any possible unexploded ordnances. You can see our mission operations team. They have been overseeing all of this morning's events, and they're going to continue. There we go. On screen, you can see front and center there, Stu Wiley, our on-scene commander, and right behind him is Victoria team. They are both wearing personal protective equipment, gas masks. That's for their own safety as they approach, as there could be potential outgassing from that sample return capsule's batteries heating up during re-entry. You can see him scanning the region. He's checking for any possible unexploded ordnances, UXOs.
Recovery operations. Oscar is performing the unexploded ordnance survey.
And you just heard that he is, in fact, doing that survey right now. You can see him walking around the SRC. This is the first person to come in contact with this SRC since it was on the other side of the solar system. We had sent this on a long journey, the OSIRIS-REx spacecraft. Finally delivering the sample, he is motioning over to Victoria team, who is shortly going to approach and begin taking some gas and thermal readings. You can see her walking over and must have given the clear for her to proceed. A little bit closer. Stu continues to pace around the surrounding area. All over here, the team will collect samples. He'll begin to place flags. You can see in his backpack, he's got a couple flags waving in the breeze. Those will be placed at areas of interest for our team members to sample once they arrive and begin those recovery operations. Victoria is now appearing to take out her thermal and gas reading devices. She's taking an initial thermal reading of that SRC as we speak, looking for it to be at an operational temperature of around 100 degrees Fahrenheit.
Operations. Lockheed Martin Safety is performing hazardous environment assessments.
And you just heard that confirmation. So she is performing that hazardous environment assessment, checking the thermal temperature of that SRC, as well as taking any kind of gas readings to make sure that we are at safe operational levels. She is also leading over. This is Victoria team from Lockheed Martin. Stu continues to sweep the area around her for the safe operation of our recovery crew members. There are several nozzles, valves around the SRC, and so once Victoria has the clear to approach, she'll actually open up some of those valves and insert a gas reading device within to actually take some temperatures. And you can see off to the left of your screen, Stu Wiley is actually safing and stowing away that parachute that helped take us the last leg of the journey. It's great news that that disconnected from the SRC. That allowed our SRC to rest as it is now here on the surface of the Utah Test and Training Range. It appears with minimal dragging.
Recovery operations. Oscar is safing and storing the main parachute.
So Stu is going to get that parachute stowed, placed away, as Victoria is front and center on your screen, beginning to take some of those gas readings to make sure that we are not outgassing any kind of noxious chemicals that could be present from that battery heating up within the SRC. And Stu is walking back to the team with that parachute. So the SRC battery is comprised of lithium disulfide, and as such, the possibility of toxic vapors exists if the battery packaging has been damaged during entry or landing. Discharging could cause potential presence of hydrogen sulfide from those batteries heating up, or carbon monoxide. And so that is why Victoria initially had her gas mask on. It appears she has now actually taken it off, so it appears that the gas readings indicate nominal conditions.
Recovery operations. Lockheed Martin Safety has confirmed no hazardous gas.
And you just heard that confirmation, so the safety assessment is successful. Victoria has confirmed that with her gas readings and thermal measurements of the SRC. They'll then go back over, Stu and Victoria, for a team huddle to prepare the rest of the team to begin the recovery operations and actually get this SRC into our clean room here at Dugway and continue the operations. You can see the Lockheed Martin team in the bottom left of your screen, just overjoyed with this moment. This is years of careful planning and preparation leading to this final phase of getting that sample back here to our clean rooms. I'm sure they've been holding their breath all morning, so they're getting closer to finally being able to take another breath and relax as we actually will begin our recovery operations, a key part of today's events. And you might see Victoria approach over and over once again to that SRC to continue to take gas readings. At this point, she appears to be covering up the back shell of that SRC, placing a Teflon cover over. This is where the parachute actually deployed at the top of the SRC capsule, the sample return capsule rather. She'll also be checking for any possible live voltage. And we'll wrap Kapton tape around the two cut cable ends protruding from the back of the SRC where that parachute deployed. You can see her with that covering as we speak, placing it on the back shell. And she has successfully placed that shielding on the back, that Teflon cover. Stu walking around behind, checking the rest of the scene, walking back with the parachute that he now has safely stowed away. And you'll see Victoria opening up a couple gas valves on the SRC, taking those gas readings. Continue to do this throughout the whole process. She's also placing covers on those gas vents too to prevent any kind of contamination from atmospheric particles, particulates entering into that SRC. She's photographing the scene as well too. This is to keep careful note of exactly the procedures that she's going through for her team. So the recovery operations will be getting underway shortly now that the team has conducted their initial environmental and safety sweep. Everything appears to be nominal, which is fantastic. We do, in fact, have that SRC on the ground. The rest of the team will be approaching shortly. But for now, back to you, Lauren and Jim.
Wow. Thank you, James.
Oh.
Can you believe it?
OMG. Touchdown for science. What a great day.
For the folks at home, this is a huge deal, and they did it.
For the first time in history, we brought goodies back home from this kind of object in the history of humanity. So this is big.
This is so huge, and we're all breathing a big sigh of relief. Obviously, we're not completely out of the woods here, and we'll be monitoring what's going on and keeping you abreast of everything that's happening. But for now,
wow,
we made it home.
A great job by that Lockheed Martin team,
yes.
safing that craft.
Fantastic work.
What a spacecraft. We have to name her specially.
Yes, absolutely. In that capsule, everything perfect. So while the capsule was making its way to the ground, mission teams...
Recovery operations, all event covers are in place.
All right. So we're making
good.
progress.
We're making progress.
All right. So while the capsule was making its way to the ground, mission teams in the Colorado control room and the mission ops area here in Utah were, of course, riveted by the live images. These teams have watched and nurtured this mission for more than 7 years of spaceflight, and even longer in terms of construction and design. Gosh.
Wow.
Amazing.
11 years since it was selected to fly. What a job, folks.
Just fantastic. A lot's happened in 7 years. All right, so let's get an update from where the action started this morning. Sophia, tell us everything.
Okay, firstly, I want to say we are so grateful that the capsule is on the ground and in good hands now. Now, from here, from Whig Mountain, I am overlooking the vast landing zone, which, again, is larger than the state of Rhode Island. So, during that time, listening to James's commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast, ancient seabed. So the mountains that are peppering along the edges over here. They are very muted colors. It's beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be, and that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen, and it's still a great day. So back to you, Lauren.
Wow, thank you, Sophia. And thankfully, we got that great image from the NASA helicopter. Wow. Just well done to that team. Thank you for that. So while we're keeping an eye on ongoing operations to prep for the SRC transport, we have a special message from someone who keeps a close eye on the entire manifest of the space agency's travels around the solar system.
Hey, everybody, congratulations to the OSIRIS-REx team. You did it. You designed it, you built it, and you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth, and it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that inspire us, things that unite us.
Recovery operations, we can confirm that the SRC is not breached.
Beyond our reach. And the mission continues with incredible science and analysis going to come. But I want to thank you all for everybody that made this OSIRIS-REx mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic, fantastic news. All right, as anyone who pays just even a little attention to modern spaceflight knows, there has been more activity above the planet in recent years than ever before in human history. There are probes like OSIRIS-REx moving around the solar system, observatories looking out into deep space, and satellites closely examining the health and future of our own planet. There are also human explorers, and we are so fortunate to have 2 of them with us here today. Joining us now are NASA's astronauts Butch Wilmore and Suni Williams, scheduled to launch on Boeing's crew flight test aboard Starliner to the International Space Station. Butch and Suni, thank you for joining us.
Oh, we are honored to be here.
Super exciting day.
What a thrill.
Congratulations.
Absolutely historic. How are you feeling?
Pretty amazing.
It's like, wow, this is what, dreams and imagination is fueled with. This is just amazing. So, it can go from the movies, but this is reality, and we're doing things that people couldn't even believe could happen. It's amazing. Yeah.
And also, we've both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal, but pretty close to exciting and intense, and that parachute opened, it was thrilling. Absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this, of course, this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery operations.
That's the place that our flight
recovery team is performing their safety.
This is a beautiful place. It's a beautiful day this morning. No wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride just like this capsule too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So you guys will be coming back, and maybe someday with samples yourself, brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, headed back to Moon and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier. So much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise woman.
I'm super glad the spacecraft did it, and we'll set the pace and show us how to do it. But I think maybe you'll practice a little bit more before we go, because it's a dangerous environment learning about it.
So much
Sunny and Butch, thank you so much for joining us today. Hopefully you'll stick around for more of the show.
Yeah,
all right, congratulations,
Thank you, guys.
everybody out there.
Really appreciate it. Thanks, guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS-REx asteroid sample return mission. You might be thinking, this doesn't look like a typical NASA facility. And it's not. In fact, it's because of the extraordinary capabilities that we find here, that we find ourselves in the Utah desert in the first place. We're coming to you live from Army's Dugway Proving Ground. We've got a video postcard to share that will give you a better sense of the glorious desert environment all around us. Take a look. Wow. Absolutely gorgeous. The spaces here are vast, rugged, beautiful. I mean, you got to see a little bit from the NASA helicopter, but that was a close-up and personal look.
And look at this. We're in this place that almost looks like Mars, but on Earth, as we're recovering a capsule with the pieces of our universe that will tell us about the early time of our solar system that we can't get anywhere else. And there's the crew out there approaching that beautiful capsule that did the joyful ride from that top of the atmosphere down. 13 minutes of roller coaster riding, and they're getting it safe and ready to start bagging her to come over to the clean room here.
Wow. And explain, why do we do a landing, as opposed to an ocean landing?
Right. So many of our crews land in the ocean, as you know from Apollo. But for this one, we need to bring it back to a place where we can contain the contamination. By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
Absolutely gorgeous. Well, this isn't the first time that NASA has visited Dugway, and it certainly won't be the last. Take a look. When bringing a sample of the cosmos back to Earth, it's important to find a good landing zone that won't compromise the sample. That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it ideal for the task. But OSIRIS-REx is neither the first nor the last mission to land here. In 2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006, NASA landed at Dugway again, this time with a mission called Stardust, which gathered samples of interstellar dust. Both of these missions helped fuel our understanding of the universe and wouldn't have been possible without a safe landing zone, just like OSIRIS-REx. After today, NASA and Dugway are looking towards the future, to the Mars sample return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground. The U.S. Army and Air Force have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery operations. Nominal SRC recovery operations have begun.
Getting an update. Okay. All right, nominal SRC recovery operations have begun. Okay.
Pretty darn good.
All right. Okay, so today could not have gone any better. how did it, I mean, in large part due to our amazing partners here with the military, how did it look from your end?
Oh, it looked amazing. So when you talk about partnerships, this isn't just a Dugway Proving Ground effort. Though you're sitting here on Dugway Proving Ground, the capsule actually landed on the Air Force's Utah Test and Training Range, and so it's going to be brought here to Dugway before it goes to the clean room. So this is a larger effort than just the Army's Dugway Proving Ground and NASA.
And it looks like it might have landed right.
So I got a note just before this from the commander of the Utah Test and Training Range that it did land on Uter, and so there was a little bit of rivalry there. We were hoping, but it looks like it was on Uter.
Right on the boundary, though. Yeah. So close.
So we have a big collaboration at NASA with members of from the Army and Navy, from the military services, that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little bit about the training and other fantastic things you do prepares these people to be crew for flight into space?
Yeah, so if you look at it, the Army is the greatest leadership lab in the world. The types of problems that we have to solve on a day-to-day basis. And we have some of the best workforce that is available. So here at Dugway Proving Ground, we do chemical and biological defense testing. We're part of the Army's Test and Evaluation Command. And so anytime a piece of equipment is going to go into a service member's hands, it's tested by one of our amazing members of our workforce. But we also do training here. And so it gives a chance for folks to come and do things in a realistic environment. And that's really allows them to hone those problem-solving skills.
Right, so that's why the crews are so good who come from the Army and the Navy and the Air Force.
Yeah, we'd like to point out it was an Army astronaut this week who went over who set the record.
Oh, well, there you go. There you go. Well, we couldn't let you go without wishing you a very happy birthday today. Happy birthday. Today is your birthday, and you got a piece of the solar system. How about that?
I don't think I could have gotten a better present from NASA.
No. This is the rarest stuff we've ever had on Earth.
It is, and I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here, and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of the solar system. I think we've set the bar pretty high, really, and so my kids think I'm cool today. I don't know what we're going to do to top this.
Well, we think you're pretty cool, too.
Yes, yes, sir.
And thank you so much for joining us. We've really loved having you.
Thank you so much.
We have a saying at NASA that the only way to reach the stars is if we all go together. The OSIRIS-REx team represents pros at the top of their game, but future explorers are just now finding inspiration in today's events. Here at the Dugway Proving Ground, students attending public school can literally say that a sample of an asteroid landed in their backyard. We visited the school to hear their thoughts about the mission and how their teachers hope it might influence their dreams of future exploration.
My name is Deborah Rockmore, and I am the librarian here at Dugway Elementary through High School. I love that Dugway is part of this. We have a very strong feeling about Dugway. It's a wonderful base. To have it be a prominent area where this is coming down is really amazing to us.
Well, I'm just glad that this little town is getting noticed.
It's a big rock that has kind of like holes in it because they've been flying through the sky with fire because it goes really fast.
Honestly, I find it really cool because you don't really expect this stuff to happen, you know, in your backyard. But I really wish I could see it, but I don't know. I'm going to try my hardest.
I became interested in the mission because I have the NASA app and I get daily updates on photos, and one day I saw a photo that had that Dugway, Utah titled on it, and I was like, I live there. You hear about exciting things all over the world, and it's cool to hear about, but you kind of never think that you'll be, I guess, directly or indirectly involved with it. But to know that it's just happening here within eyesight is pretty cool.
Let's go OSIRIS-REx.
Go OSIRIS-REx.
Let's go OSIRIS-REx.
Let's go OSIRIS-REx.
Let's go OSIRIS-REx.
All right, let's go OSIRIS-REx. I love that energy.
I do too.
All right, Jim, you know, you're a planetary geologist. How did you get into this? I mean, these kids are just at the beginning of thinking about what their career might be. I mean, how did you do this?
I think all kids are intrinsically curious at birth. My mother said I was interested in space at birth. Don't know how she knew. But in any event, I think we all are, and we follow different pathways. If you see things as beautiful as we have here in Dugway, here in Utah, you'll be inspired by the rocks and the things in space, like these special samples we've brought back, which are unique being from Bennu, but not unique in the kinds of materials we have here on Earth, thanks to other asteroid returns. These are the biggest we've ever done, and so we're excited. But I think curiosity is in all of us, and so that's really what it's all about. And these kids are ready to pick up on this energy.
Yeah, we need that future generation. All right, let's get an update from James. James, go ahead.
Yeah, Lauren, so the mission operations team has confirmed that we are able to begin those recovery operations. You've been seeing on your screen in the bottom corner for the past couple minutes, team members beginning to head out and put flags of areas of interest where we'll want to sample for our sample curation team. And also just a note on our parachute deployment, the parachute was set to deploy based on capsule deceleration, and we actually reached that threshold earlier than predicted, and the parachute deployed appropriately. So everything was right there, working perfectly fine. We got that SRC, as you can see, successfully on the ground. It is perfectly resting on the desert terrain, and you see 3 of our team members around that capsule beginning to place flags to begin to collect samples. The team members here you see on screen are Scott Sanford, Dante Loretto, the principal investigator at the right of your screen there, and Francis McCubbin. These are key curation team members who will help us actually get a lot of these samples of the region there, environmental samples, collected and ready to be passed along to our team at the Johnson Space Center for curation efforts there. This is, again, a very key part of the mission. We want to make sure that there is no contamination of that sample return capsule from any possible atmospheric or environmental conditions out at that landing zone, that landing site. And so we're going to continue these operations and actually begin to scoop up some of the samples. And this will work like a well-oiled machine you'll see in a few moments. Dante, who was just on your screen a few moments ago, is wearing an armband, much like a football quarterback, if you will. He'll actually be kind of reading off the play calls as they go out and go step by step to actually scoop into the terrain about an inch down into the surface of the desert, scooping out a little bit of the rock and dust that's there, placing it into a bag, photographing the whole process along the way, making note of exactly where they collected that sample from. All this information will then be passed along to our sample curation team at the Johnson Space Center as they begin to actually open up that sample canister and see exactly what we got within. This has been a long journey. It's been an incredible morning to witness this live. Just such a stunning feat of engineering to get that capsule back here to Earth with samples of the asteroid Bennu. This is why we do science, right? To get these kinds of samples, every piece of dust and grain inside that sample return capsule is a PhD thesis waiting to be written. It's a new discovery waiting for us about the origins of the solar system and our place in it. And the vast majority of that sample, more than 70% of that sample, is actually going to be stowed away for future analysis. We did the same exact thing with the Apollo missions when we brought back rocks from the moon. A large quantity of those rocks and dust from the moon our astronauts brought back were stowed away for future generations with the expectation that our technology would continue to improve and improve and improve, and then we'd be able to ask questions that we couldn't even begin to fathom. And now the same thing we'll be doing with the OSIRIS-REx samples that we brought back from the asteroid Bennu. A lot of these will be opened up 50 years from now with scientists who are yet to be born asking questions we can't even begin to imagine. So our team is just huddling off screen now, and our recovery operations will begin. You'll see a number of team members come out here. They'll be carrying with them a carrying fixture. It's a large metal fixture that has been perfectly designed to have our SRC resting within. They'll be bringing out a lot of thermal blanketing that will be used to protect our SRC during its flight back to the clean room here. Again, we want to make sure that that SRC is safe from any kind of possible contamination from the atmosphere. So they're going to do an excellent job of actually wrapping this SRC up and getting it prepared to transport to our portable clean room. That actual operation of getting that SRC bagged and stowed and ready to go on our long line operations for the helicopter will be a rather quick operation. As you see some team members from Lockheed Martin, their role is largely finished for today. They were operating a lot of the flight dynamics of that SRC, getting it to the ground, and now they can really just take a step back and relax, catch their breath after all the chaos of the morning. Very exciting moment for all of them, I'm sure, to actually see their creation sitting on the surface of the Utah Test and Training Range. Just massive, massive sigh of relief. So as I mentioned, that actual recovery of the SRC will be a relatively quick process, but a number of our team members, including Dante Loretta, our principal investigator, might remain out on the site where you see that SRC on your screen now. They're going to continue to collect samples. You can see a number of flags placed around. There's some pink flags placed there. There are 4 placed in front of the SRC where the team believes the SRC is potentially dragged along the surface as it came to a rest on the Utah Test and Training Range desert surface. On the back side of that SRC are 4 additional pink flags, and those are our regions for control sampling. We'll actually go and sample all of these regions and compare back to areas we believe the SRC did not contact. You can see additionally, it's a little bit hard to make out with the bright color of the desert, but there are a couple white flags present at the SRC. And these are areas of operation for the team to actually be able to walk up to the SRC with the carrying fixture, place it next to the SRC, and actually begin to bag and stow our sample return capsule for transport to the Dugway clean room. So it's been already just an incredible morning. We're now about an hour past landing of the OSIRIS-REx sample return capsule. Just a few years ago, our spacecraft, our intrepid robotic explorer, was 200 million miles away from us on the other side of the solar system. It successfully captured a sample of the asteroid Bennu, stowed it away, and transported it on the long 1.2 billion mile journey to us here on Earth. We experienced an incredible entry, descent, and landing as this team that you see on screen here, the Lockheed Martin team, a couple hours before our broadcast started, gave the green light, the go command, to actually release the sample return capsule containing pieces of the asteroid Bennu. It then floated on its own through the vacuum of space for about 4 hours before coming in contact with the atmosphere over the San Francisco, California Bay Area, traveling at just over 27,000 miles per hour and heating up to over 5,000 degrees Fahrenheit as it encountered the incredible drag forces our Earth's atmosphere presents. We then slowed down under our drogue parachute initially, which kept us stable during our descent down to the Utah Test and Training Range. And then ultimately, at about 20,000 feet off the deck, we gave the command to deploy our main parachute, that orange creamsicle color parachute that has now actually already been stowed away by our team members here at the Utah Test and Training Range. It's been a really wild journey. Very excited to have our SRC on the ground. And you see a view of our mission operations team observing our recovery team that is already out on the landing zone, taking samples, beginning to actually prepare the thermal blanketing, the protective layers for our SRC, and you can see we're documenting this whole process along the way. And so these operations will continue for the next couple minutes, or as long as it takes to safely store that SRC and prepare it for long line operations to get it to the clean room here. We'll continue to take samples, and I will continue to monitor the situation as we proceed here. But for now, back to you, Lauren and Jim.
Thanks, James. And just a reminder to those watching, we are in an extremely remote location. And so if our signal is breaking up, it's because we're out in the middle of nowhere. So we're doing a great job, all things considered. One other thing that I wanted to address really quickly is that parachute ended up deploying really quickly. Did it not, Jim?
It did. It deployed high, and this is a smart spacecraft. That sample return capsule detected the deceleration rate, and it decided that it was important to get that parachute out to slow her down so we could make this beautiful, safe landing. And that's the way this magical autonomous spaceflight works these days. We adjust to the dynamics of the environment. Again, hats off to the engineers that built those systems in so we could be home safe doing what you can see on your screen now.
With a beautiful landing. All right, Jim, let's actually take some social media questions now. Let's get our first one. All right, at CCSV wants to know, will the sample be quarantined like moon rocks are?
Well, in this case, based on a classification of what we call the planetary protection, these samples will not be quarantined in that way. The first moon rocks came back, they were quarantined for a week, out on the carrier and all that kind of good stuff, came back to Houston again very carefully. In this case, we understand the asteroid, the environment. We measured it with OSIRIS-REx, other asteroid samples from our colleagues in Japan, and so we don't have to quarantine them the same way. We do have to protect them, though, from contamination, and there's all kinds of systems in place by our team to allow us to understand the level of contamination. So what we study in science is the pristine asteroid.
That was a great question.
Excellent question.
Excellent question.
Recovery operations. SRC is bagged and secured in the handling fixture.
All right, you just heard that the SRC has been bagged, and we are well on our way to getting that to our clean room here at Dugway. Wow, fantastic news. Missions like OSIRIS-REx transform scientific pursuits into engineering challenges. Smart, curious people with pursue answers with creative verve and perseverance. This year, Hollywood also had a story about a crowd of people situated around the touchdown point of an asteroid. And, well, we couldn't help ourselves. We asked the cast of Asteroid City to say a few words. All right, well, it looks like we are having some technical difficulties, but that's okay. We'll definitely get you that video. It's a really fun one.
It is.
Scarlett Johansson, I mean, A-lister,
Yes.
Can you imagine? All right, so let's get an update from our field correspondent, Sophia. Sophia, do you have an update for us?
Okay, Lauren, turns out the landing site really is just over my shoulder. It is just so hard to see through the alkaline particulate out here on the landing zone. But you know what? This is all in great hands, and we are just very thrilled that the capsule is doing well today. So I'm able to see one of the helicopters just circling over there. But for those of you who have just tuned in, I am on Wig Mountain, which is overlooking the ellipse, which is the vast landing zone. And earlier today, the helicopters, which were shuttling our teams of experts and our scientists, departed from here via helicopter once they found out exactly where the capsule landed. And now they're off on their recovery process and are doing what they do, which has been a carefully rehearsed process. So, Lauren, I'm going to send it back to you.
Great, thank you so much, Sophia. All right, well, let's get back to that awesome video of Asteroid City. You don't want to miss this. Take a look.
Hi, I'm Jason Schwartzman.
I'm Jake Ryan.
And I'm Scarlett Johansson.
Where are you?
Asteroid City, Farm Route 6, mile 75.
Hey everyone, I'm Jeffrey Wright. Junior stargazers and space cadets. Each year we celebrate Asteroid Day.
Hey everyone, I'm Maya Hall.
And I'm Rupert Friend.
And we star in Wes Anderson's new movie, Asteroid City.
In the movie, families from across the country gather in a fictional American desert town for a junior stargazer convention.
I heard there's a real-life reason people will be gathering in the Utah desert this September.
The world will never be the same.
What is happening there on September 24th?
September 24th is going to be a historic day. This is NASA's first asteroid sample return mission and the biggest sample return beyond the moon. Shortly before 9 a.m. local time, the OSIRIS-REx spacecraft carrying precious samples of asteroid Bennu will release the capsule into the atmosphere to lower the samples down to the Utah desert, where scientists are anxiously awaiting the return of these materials.
Wow, that sounds like the plot of a science fiction film.
It's incredible that a spacecraft can go to an asteroid,
grab some pieces of it, and then bring them to Earth.
So what will NASA look for within the asteroid sample?
These pristine asteroid materials will be studied by scientists from around the world. We're going to be looking at the minerals. We're going to be dissecting the rocks, looking at it mineral grain by mineral grain to learn more about how the solar system formed and evolved. We're also going to be looking for water to try to understand how our Earth's oceans came to be. And then finally, we're going to be looking at organic compounds, including some of the basic chemical building blocks of life, to try to understand whether asteroids like Bennu could have delivered the building blocks to Earth, leading to the origin of life on Earth and potentially elsewhere. With the data that we obtained from these materials, we're going to be rewriting the textbooks on solar system formation.
Fascinating stuff. But don't fragments of asteroids land on Earth all the time? Why can't we study those pieces instead of a mission to bring this sample to the Earth?
Yeah, that's a great question. I mean, in fact, the Earth is constantly being bombarded by fragments of asteroids in the form of meteorites. But one of the big problems with studying meteorites is you don't always know where they came from, and it also can be contaminated.
Fair enough. It makes sense that we'd want to study something more pristine.
So how will NASA protect the sample once it's on Earth? And can I have some?
Oh, I wish we could have some of these samples. I wish I could bring one home with me to put on my dresser at home. But the reality is these samples will only be for educational purposes in scientific research. The samples will be transported to the NASA's Johnson Space Center. where they built a special curation facility just for keeping these samples safe and pristine.
This is also incredible. I'm so glad that NASA has teams of people that are searching for the answers to some of the biggest questions, like where did life and water come from? Where did our solar system come from?
I can't wait to see what we learn from the asteroid sample OSIRIS-REx is bringing to Earth. Thank you for all that you do.
This is also incredible.
Thank you so much for all you do.
Well, you just said that name. You just said OSIRIS-REx. That was the thing.
That was kick-ass.
How did you do that? I was like, what is this phrase?
I was like,
OSIRIS-REx.
OSIRIS-REx.
Yeah, Osiris. OSIRIS-REx.
Wow, talk about that mega wattage star power.
Scarlet,
oh
wow.
my gosh. It takes a huge, talented team with profoundly diverse skills to design and execute something as audacious as OSIRIS-REx. It takes years of planning and perseverance to see it through from that initial notepad doodle to a moment when the world tunes in to celebrate a huge success. It also takes leadership. And I'm pleased to say that we are now joined by the director of NASA Goddard Space Flight Center, Dr. Mackenzie Lystrup. Welcome.
Thank you so much. I'm delighted to be here and very happy about the results coming out today.
It is a great day indeed, and congratulations. This is a huge day for Goddard. It must go without saying that you are very proud.
Absolutely. This team is amazing. They've been through so much for so long. Goddard Space Flight Center, the special thing about NASA's Science Center, Goddard, is that we have scientists and engineers working side by side, and so that doodle on a napkin can turn into something like OSIRIS-REx. And scientists like Dr. Garvin here, who's joined us, really help us create a vision with other scientists of how you're going to do the engineering that gets you to this moment that we have today.
And Mackenzie, we have leadership across all domains on this mission, from system engineering to science to accounting to everything. How did your team in Maryland pull this thing off?
Yeah, we have people who have managed multiple parts of missions over the decades. Systems engineering is critical, and it's one of the things that Goddard really brings to the table. And systems engineering means that we take into account everything about the mission, from the science ideas to the launch to orchestrating the landing here on Earth, but making sure that all of the instruments are working together, making sure that the spacecraft successfully interfaces with the instruments and can carry out its job once it was at Bennu. All of that requires really understanding the entire system. So when we say systems engineering, we're really talking about that overarching, holistic perspective that our scientists and our engineers bring to the table. But it's true that we have some of the greatest scientists and engineers working on space missions, and they pull it off every time.
Awesome.
Fantastic. Well, really quickly here, Goddard will be one of the centers that will receive a sample, but who else will receive a sample of the asteroid?
Samples are really traveling all around the world. What I think is very exciting about this mission is that we're saving about 75%. And we're not sending that out yet. We're keeping that in storage for future generations to be able to use more advanced methods and instruments to be able to analyze. So about 25% of that material is going to be headed to scientific organizations all around the globe.
Fantastic.
Unbelievable.
Well, thank you so much for joining us this morning.
Yeah, thank you.
Thank you so much.
Congratulations.
Yes.
There's a big team of scientists, engineers, and so many others here in Utah working to make OREX a success. It should go without saying, everyone here is mission critical, from bus drivers to planetary geologists, helicopter pilots to logistics experts. With all of the natural excitement about the mission itself, let's stop for a few minutes and highlight those in OSIRIS-REx who made it live and breathe. Take a look. Boy, it's really hard not to get a little emotional when you see all those faces. These are a lot of the people that we've been seeing over the last few days, and they're getting their time in the sun. All right, let's throw it over to James for an operational update. Take it away, James.
Yeah, thanks, Lauren. So while we've been kind of waiting for the past couple of minutes here, the team has actually successfully bagged and prepared the sample return capsule for the long line operations. You can see on your screen right now, the SRC is bagged within thermal blanketing, and that metal thing you see on the bottom is the carrying fixture. This will then be actually loaded up into cargo netting and prepared for long line operations. One of our helicopters will take flight, carrying the SRC dangling beneath it. The SRC is going to be stabilized with that cargo netting. There is a gimbal that will keep it stable as we begin the flight to the clean room with our precious cargo on board. You'll notice a couple of tape markers on that SRC as well, the thermal blanketing there. Those are pieces of Kapton tape marking exactly where vents are on that SRC for team members here at the clean room, who will once again do gas and thermal readings once it arrives at the clean room. Just once again making sure team members are safe and secure as we begin to continue those recovery operations, getting the SRC into the clean room. And this is one of the last phases of the process of getting our SRC back and then opening it up, finally seeing that sample canister within and preparing that for shipment tomorrow on a C-17 cargo plane to the Johnson Space Center's sample curation facility. And this was a very quick process. I mean, if you're keeping time at home, this was only maybe about 20 minutes that they took to get out there once they arrived and wrap everything up really quickly once they were given the official confirmation to approach, get everything stored, prepared for those long line operations. This really has become second nature for these team members. They really are able to bag and prepare this SRC. And you'll see still quite a few flags around that area there. Once this SRC is flown away from the region, the landing zone, team members from the curation team will remain on site and continue to take samples of that surrounding area. They also have set up off screen here, you can't see it, but there is a air reading that they're going to be taking actual air samples of the area, atmospheric samples. All of this will be cross-correlated with samples that we actually get back from the asteroid Bennu to make sure that nothing from Earth here at the LZ or beyond got into that sample return capsule. And you can see some of those team members who are going to be taking those samples once again approaching the location. Dante Loretta is front and center with them. He has that armband on, and on his left arm you can see it there as he's carrying his bucket that has all of his tools that he needs to begin collecting these samples. It's a very tight procedure that they have to go through to make sure that they are properly taking these samples. You can see they are photographing the area first, documenting exactly where they are collecting the sample from. They then have a small metal scooper that they'll use to actually dig into the desert surface. It's a bit of a soft surface out there today. As I mentioned, we did have some rain that softened it up, so it should be easy to dig in there, grab a bit of sample, and then they will bag that sample, seal it up, and then send that off to the sample curation team at the Johnson Space Center. Admiring the region as well. It's a beautiful, clear morning there today. We've been rehearsing in a variety of different conditions, including in the middle of the summer where temperatures were over 100 degrees Fahrenheit, much cooler conditions. You can see our team members wearing their UV shirts today. A much chillier morning for them as they are doing these recovery operations. And this process does take some time as they go through and collect these samples. They want to make sure that they are accurately documenting exactly what's present at this landing zone for the team members who are at the sample curation facility of the Johnson Space Center. We're getting a great aerial view from our NASA helicopter. They've been doing a phenomenal job all morning tracking the action for us, and we don't give them enough credit. We've been training, obviously, all of the science and engineering
operations. The recovery team is moving the SRC to Helicopter 1 and preparing for long-line operations.
And there we have it. We are going to be moving towards those long-line operations. The rest of the team members approaching that SRC that has been successfully bagged and prepared to be loaded into the helicopter's long line. This will be the last time the SRC takes flight. We had a wild flight this morning. You can see two team members lifting that SRC up. It's about 120 pounds total once you have the SRC and the carrying fixture there together. They're going to be walking this over, preparing it for cargo netting, and getting that attached to the long line for helicopter operations. And as I mentioned, this is the last time the SRC is going to be taking flight. It had a harrowing journey this morning coming through the Earth's atmosphere at over 27,000 miles per hour. It is now being carried carefully by a couple team members here. So quite a deceleration from that initial entry, and really just a wonderful final journey for our sample before it is opened up at the clean room and prepared to be shipped to the curation facility at Johnson. And as I mentioned, this view is coming from one of our NASA helicopters. Just like the science and engineering teams have been preparing for this key moment, our NASA helicopter pilots have also been preparing to cover today's events. They're typically down at Kennedy Space Center in Florida, capturing launch coverage from Cape Canaveral. But this past couple months, they've been out here with us at the Utah Test and Training Range, preparing to document today's events, getting incredible footage for us all along the way. You can see those team members have a bit of a hike to carry it to where it is safe operationally. And you can see we have the cargo netting already laid out there. Our representative from Dugway, Jasmine Nakayama, is prepared with that cargo netting. She is going to help the team here get that SRC that has already been successfully bagged up with thermal wrapping into that cargo netting, and you can see the helicopter already there staged and ready to lift off. The helicopter pilot has actually removed one of the doors on that helicopter so he can lean out and look down as he carefully lifts the SRC off the terrain. We want to make sure that this is a careful, slow process as we safely transport this SRC to the Dugway clean room. And you can see Jasmine is picking up pieces of the cargo netting and beginning to wrap the SRC that has been placed already on the carrying fixture with the thermal blanketing. Team members observing their handiwork of getting that carefully wrapped up. We'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recovery operations, SRCs in the cargo net, and all the gear has been stowed in the helicopter.
Great news, everything sounds nominal for helicopter operations, and in just a few moments we should have liftoff of that SRC aboard the helicopter with that long line attached. Team members clearing the area to make sure that we can safely take off with our helicopter. These helicopter pilots have also been training in tandem with all the team members the past couple months leading up to this key moment. We've practiced these long line operations, we've practiced the flight back to the Dugway clean room, but obviously nothing compares to the real deal. I'm sure they are feeling the excitement, they are feeling the nerves as they know how precious their cargo is this morning that they're transporting to the Dugway clean room. See, Jasmine is donning a helmet, and the rotors are kicking on for our helicopter. Kicking off some dust as they get up to speed there. It is a dusty morning out on the desert. And this will be, once again, a very slow, deliberate operation. We want to make sure that sample return capsule is safe as we are lifting it off. The piece that Jasmine is holding in her hand right now is that gimbal stabilizer for the cargo netting. That will ensure that the SRC is not wildly spinning as we get to altitude with our helicopter. These helicopters can get upwards of over 100 miles an hour speed, but we're going to go nowhere close to that today. We're going to be taking this at a slow pace, making sure that SRC can get back safely and securely to our Dugway clean room. You can see one of our NASA photographers, Keegan Barber, taking some great pictures. I'm sure those will be phenomenal views of the operations that are going on just across the way from us at the Utah Test and Training Range. As soon as these rotors get up to speed, our helicopter will get off the ground. The terrain is a little bit soft today. Team members were out here yesterday testing out the grounds and had practiced actually landing with some of the helicopters. Those skids on the helicopters got about an inch into the wet terrain. It's presumably dried a lot more today. It's the sunny, clear skies have probably helped us out a bit, so it should be an easy liftoff for this helicopter to get into the air and help transport that SRC to the clean room. Off-screen, team members are presumably continuing to collect samples of the surrounding area, both environmental, soil samples, atmospheric samples. We'll be continuing to do those operations even as we bring this SRC to our clean room. Just a great view here from our NASA helicopter. And in just a few moments, we should have a stunning view of our SRC lifting off the ground. No part of this SRC comes in contact with the helicopter. As I said, it's been safely stored in that thermal blanketing. There's multiple layers of that blanketing, as well as a tarp being placed over it. Now, it is also in that cargo netting, thanks to our Dugway representative, Jasmine Nakayama. She's then attached this whole contraption to a long line that will dangle about 100 feet below the helicopter. And I can see a lot of dust kicking up now. The engine's really revving up on that helicopter, and it is off the desert terrain in the air with the SRC in tow.
Recovery operations. Helicopter 1 is cleared to depart the recovery site with the SRC.
And we have clearance to depart the recovery site. This is a key moment of those recovery operations. We're already getting that SRC out of the landing zone and on its way to the Dugway clean room. In just a few moments, that SRC with the long line attached will be lifting off its landing zone. Jasmine assisting with that final part of the lift, and it is now airborne. As I mentioned, a much more relaxing flight for our SRC on its last leg of its journey. We are officially departing that landing zone. Recovery operations will continue out at the Dugway clean room. I see team members waving goodbye. And look at that view. This is a stunning view of our helicopter. This is a long journey ahead. As I mentioned, probably about 20 minutes of total flight time. We may lose signal as we head out there a bit, but for now we have a stunning view of our helicopter carrying the SRC below, and you can see that stabilizer is helping to keep that SRC nice and stable below. We'll continue to track this transport to the clean room, but for now, back to you, Lauren and Jim.
Wow, check out that epic shot. Check it out.
What a ride.
Wow. All right. Thanks, James. The science community has serious questions about asteroids like Bennu for a long time. What are they made of? Do they hold any clues about the origins of life on Earth or elsewhere? And what can they tell us about our past and potentially our future?
It's all about chemistry, Lauren.
It absolutely is. Well, fortunately, Jim, we are joined by somebody who specializes in the kind of chemistry that you'd be hard-pressed to find outside of NASA. Jason Dworkin is the OSIRIS-REx project scientist. Welcome.
Welcome, Jason. Thanks for coming.
And congratulations. What a historic day.
Oh, it's
you
just
must be so relieved.
Fantastic, yes. Relieved, invigorated, excited, and
As we
so
all
much
are.
work ahead of us.
Right.
Indeed, indeed.
Fun work.
Fun work.
No, epic work.
Epic work. You must be so excited to dig into the sample yourself. But what makes this sample? You know, we've continued to say this is such an important sample from an asteroid. Why is it scientifically significant?
So Bennu is an ancient piece of the early solar system, a leftover component. It's a fragment of what happens when you make planets, and this fragment of rock it contains the ingredients that happen when you make planets, that happens when you make life. Right. So by studying a sample from the leftovers of space, we can study a sample from the leftovers of the formation of the Earth. Look at the chemistry in detail as you can only do on the ground, using instruments that are sometimes bigger than a launch pad, let alone the rock and the spacecraft. So we can interrogate the compounds, the minerals in fine detail to understand how they interact with each other and how they could have led to the history of the solar system.
And that's forensic science at its best. But I have a question, Jason, because you're an expert in this. So we're going to save some of this sample so that future generations, future techniques, future people not even born can learn from it in the future as we try to look at our place in space.
Absolutely. That's one of the parts I find the most exciting and gratifying, is that the work we do here will be available for scientists perhaps watching now, perhaps not yet born. They can make choices and come up with their own hypotheses, their own ideas, their own new techniques to look at the sample in new and exciting ways, just as we have for the Apollo samples. A woman in my laboratory studied Apollo 16 and 17 samples that were collected before she was born, using techniques that were not invented in the 1970s to then answer questions that were thought of but couldn't be answered.
That's
and so
incredible.
Since you mentioned forensics, we also have equipped future generations with the information to follow the chain of evidence from these construction of the spacecraft all the way to the collection now and then the distribution.
Awesome, Jason.
Wow, that is so cool.
Thank you.
Well, thank you so much for joining us.
Pleasure. Thank you.
Thanks, Jason. Good luck.
Careful handling of this asteroid sample is all about getting the most out of the huge effort to visit the object in the first place. Mission planners considered many destinations but settled on Bennu. Let's learn more about why. OSIRIS-REx was designed to retrieve a sample from asteroid Bennu and return it to Earth. So, of the more than 1 million known asteroids in our solar system, why Bennu? First, as a near-Earth asteroid, Bennu is easy to reach. It takes about 14 months to orbit the Sun and comes close to Earth once every 6 years. To get there, OSIRIS-REx was launched in 2016 on an Atlas V rocket with a single booster and a Centaur upper stage. It also got a big assist from Earth's gravity in 2017, allowing it to match Bennu's orbital tilt. The second reason that Bennu was chosen was its size and spin rate. Bennu measures about half a kilometer in diameter and rotates on its axis once every 4.3 hours, which is actually pretty slow compared to many smaller asteroids. This allowed OSIRIS-REx to map Bennu's surface up close, and to match its velocity, briefly touch down, and collect a sample. Before OSIRIS-REx arrived, scientists thought that Bennu's slow rotation meant a low risk of flinging away most of its sampleable material. But shortly after arrival, Bennu was caught on camera ejecting hundreds of pebbles. It turns out that Bennu regularly sheds small particles, but it still had plenty of loose material left on its surface for sample collection. The third reason for choosing Bennu was its composition. We don't know what ingredients were present during the formation of life on Earth, but primitive asteroids like Bennu serve as time capsules, preserving material from the dawn of the solar system. Spectrometers on OSIRIS-REx confirm that Bennu is rich in carbon-based molecules, including organics that are the stuff of life. When the Bennu sample is analyzed, it will help scientists to better understand the formation of the solar system and our own origins. So why this particular asteroid? Proximity to Earth, the right size and spin, and a carbon-rich composition. That is why we chose Bennu. As you can see in the bottom of your screen, that SRC is continuing its transit to the clean room.
Awesome.
All right, so turning our attention back to the rocks in the Bach, I have to ask Jim, how did they get it in here? What is this?
So this is the TAGSAM sampler head. It's about a foot long. It looks like an old Chevy carburetor, but inside is something much more precious. Inside, maybe 250 or more grams of that primitive material from the asteroid. And it has all the gear on it, including samplers on the bottom, little pads to grab sample, as well as the stuff inside that contains the bigger pebbles and all the dust. It even has witness plates that we use to do that contamination control that Jason was talking about. This is the box.
Mm-hmm. This is the big deal right here. And you know, the material went into this box. We've actually got some of what's called simulant here, and this is obviously not the actual sample from Bennu, but it is a good approximation. Is that right, Jim?
That's right. And so what we discovered on this amazing mission was the material properties and the microgravity of asteroid Bennu didn't behave like we totally expected. They behaved like an almost cohesionless fluid. And so while I pour this here and they fall pretty naturally, and this is about the amount of stuff we expect to find inside this sampler head, they flowed more like water on Earth than we expected there on the asteroid. This is new physics. We didn't know that was going to happen. And these rubble pile asteroids are teaching us something at every step. In fact, some of these bits, which are simulants here, may behave more like little balls of styrofoam than the kind of rocks we have here. So we're going to learn new stuff by just doing basic characterization of the goodies inside this sampler head.
And one thing I think is so cool is that, you know, on Earth, it poured directly into these other beaker here, but as you said, it acted almost more like fluid.
Exactly. We actually, when we took this sampler head on the TAGSAM, we pushed it into the asteroid, gave it a poke, let loose the gas, and let the stuff flow. We actually penetrate 50 centimeters. That's more than almost 2 feet. So we went deep into the asteroid, fired our thrusters, and backed away with the sample intact in this sampler head. That was cool. We didn't expect that. We expected contact, 5 seconds later, grab the good stuff and come home.
Right.
So dynamic interactions, learning about how these objects work. As you heard from Lori Glaze, this is how we get to understand the worlds that we need for planetary security.
And I've even heard this described as a ball pit. That's how loose the material was when they approached Bennu.
Exactly. If we had kept going, we didn't have that smart spacecraft, all that great engineering, we could have engulfed ourselves in this rubble pile of stuff. Not good. But no crap happened, and we're on the way home, and we have a sample that's coming here to the clean room right here a mile away.
All right, fantastic. Well, now that the team is bringing the SRC back to the clean room here in Utah, what can we expect?
So the next step is really important. We'll wheel that special apparatus that's carrying sample return canister with this thing inside it right to the clean room, bring it in, take off the elements of the aeroshell. That's the thermal protection system in the back shell. We'll take those off and set up the plumbing to get the nitrogen purge on this particular sampler head. That's critical.
All right, that's next. All right, let's get an update from our gal in the field. Take it away, Sophia.
All right, let's put these puppies down.
Lauren, things are much quieter over here now. But for those of you who are just tuning in, this is where the helicopters departed that were carrying our teams of experts that are now having been through a large part of the recovery process today. But really, that's all I have for your updates here from Wig Mountain, overlooking that vast landing zone. But if you do see, we are miles away from the live broadcast hangar, and it took me 30 minutes to get that 12.5 miles, and that gives you an idea of how long it takes to traverse this tough terrain, which is also why the recovery teams chose to use helicopters to get that capsule safely to the clean room. I luckily had a chance to talk to the pilots of those helicopters just the other day, so let's take a look. The OSIRIS-REx sample return capsule just endured a lengthy 3.8 billion mile journey. But the adventure doesn't end once it touches down. The landing zone itself is so large and the terrain so difficult to navigate that the recovery team delivers the capsule to the clean room by helicopter.
Joe's going to be the man hauling the capsule out on the long line. And then Ryan McDonald is another member, and he will be hauling scientists along with myself, the rest of the capture team.
So Ben, can you tell me about the actual procedure of taking the capsule on the long line?
It's a 100-foot long synthetic line. It's got an electrical cord with it. That will hook on the belly of the helicopter. There you go, point it out.
Right here.
Yep, that's the hook that the line will go on. The pilot will lower this hook down to pick up the capsule. They'll fly it back to the clean room, lower it down, and when he lowers it down, he'll hit a little button on his collective. It'll release that hook, and he'll fly away with the long line.
This is not a normal ride. Can you show us how you fly this for this particular mission?
Yeah, so in this helicopter, when we're doing vertical reference, that's what you call it when you have a line on. Now to see the end of the line, I'll be leaning out like this. It's an awkward position, and kind of lean out and look back because my hook's going to be right down in the middle of the helicopter. It will be this button. This button here is the remote hook, and that will keep the line on the belly, but it'll open that little green remote hook when you push it forward.
The experience of these pilots is all a part of preserving this pristine sample of ancient solar system material. And we all cannot wait to see what chemical compounds the capsule holds.
We're now joined by Robert Lightfoot from Lockheed Martin Space, representing the team that built and flew the OSIRIS-REx spacecraft for NASA. Robert, welcome.
Well, thanks for having me. What a great day. Pretty exciting.
Hey, Robert, thank you.
Pretty exciting.
So this spacecraft has many firsts and some unique tech as well. Can you tell us more about some of the new technologies that were integrated into OSIRIS-REx?
Yeah, you know, there's three that come to mind for me. The first is obviously the touch and go sample collector, where we had to come up with what we called the pogo stick. How we're going to hit the asteroid and collect the sample. So that was the first thing. The other thing, we had a natural feature terrain activity that we did that was really associated with, it was kind of a backup for guidance and navigation, but we ended up needing it because when we got to the asteroid, you remember there were very large boulders we didn't expect to see that we had to fly through. And then finally, probably the most unsung part was our digital twin. We created a digital twin for the spacecraft, which, if you remember, this was right in the middle of COVID.
Right.
And so being able to do the sample and use the digital twin to do all the practicing before we took the sample was probably those are the three things that come to mind for me.
And Robert, you mentioned the TAGSAM, that critical pogo stick, and we heard that it all began with a red cup and some conversations with napkins and things. Can you tell us about that?
That's exactly what happened. It was somebody doing, it was a solo cup and some kind of activity that we did there, and really think about some of the most famous missions NASA has done. That's what we've done in the past. Is we've used somebody sketched it out on a napkin, and the engineers turn it into reality, and then the scientists get their reward.
To use it. Thank you, Robert. What a great story.
What a fantastic story. Well, thank you so much for joining us, Robert, and congratulations again.
Thanks. Really proud of the team, Lockheed Martin team, and everybody for doing
fantastic
Y'all
work.
take care.
Great job.
We're keeping our eyes on ground operations as teams work to secure the SRC, take measurements at the landing site, and get everything ready for its transit to a specially prepared clean room a few miles away. Today's landing is a big day, but to tell you the truth, NASA is starry-eyed about asteroids, and for good reason. Asteroids are time capsules for the solar system and are vital research destinations for learning about our origins and perhaps our futures. While today's events focus on returning bits of the asteroid Bennu, that's not the only asteroid in NASA's plans. Let's take a look at a glittering list of other places we're en route to visit. 1 year ago, on September 26, 2022, NASA's DART mission navigated to the small asteroid Dimorphos and deliberately crashed into it. Dimorphos is a tiny moon orbiting the asteroid Didymos, which is just a bit larger than Bennu and composed of stony material. The DART impact shortened Dimorphos's orbital period by 33 minutes, making it the first full-scale demonstration of asteroid deflection technology. This summer, while the Bennu samples were approaching Earth, technicians in Titusville, Florida were preparing the Psyche spacecraft to visit an asteroid of a different type. Psyche is named after its massive target, 16 Psyche, which is about 400 times larger than Bennu and more than 3 times as dense. The Psyche spacecraft will visit an asteroid that may consist of a significant amount of nickel-iron metal mixed with rock. It will remotely study 16 Psyche's elemental composition, topography, and gravitational and magnetic fields. The mission will provide insights into the formation of terrestrial planets like Earth. Psyche's launch window opens on October 5th. November may be sweater weather for folks in the Northern Hemisphere, but for the Lucy mission, things will just be heating up. On November 1st, Lucy will train its cameras on the main belt asteroid Dinkinesh. It will take pictures while rapidly flying by and test its ability to track asteroids during high-speed encounters. The Dinkinesh flyby will prepare Lucy for its next encounter with the main belt asteroid Donald Johanson in 2025. In 2027, Lucy will begin its long trip through the Jupiter Trojans, 2 swarms of primitive asteroids trapped in Jupiter's orbit that are thought to be the fossils of planet formation. As the weather starts to cool down, hold on to your hats. It's going to be an asteroid autumn to remember. A lot of work obviously went into getting this special delivery to Earth, but our pursuit for scientific answers is just beginning. Joining us now is Danny Glavin, co-investigator on the OSIRIS-REx mission. Danny, welcome.
Thank you. Great to have you, Danny.
It's great to have you.
Samples.
We got them.
It's incredible.
You know, so Danny, as somebody who looks for the building blocks of life in extraterrestrial materials, what are you expecting to find in the Bennu sample?
Yeah, so I mean, we're definitely looking for the building blocks of life, and we've been studying meteorites that we think look like Bennu. And so I'd fully expect to find amino acids, the building blocks of proteins, sugars, and energy source for life. Nucleobases, right? Parts of the genetic code. So we'll see what Bennu tells us. One thing I've learned from this mission is so many surprises. Sample analysis probably won't be an exception. We're going to be surprised.
So Danny, I want to talk to you about some of the new techniques you're going to use, but I'm going to introduce a guest we have. This little guest here is actually a meteorite from Mars, and you've looked at those.
Yeah.
This is a new one. We know it's from Mars because measurements from Viking and Curiosity tells us that. But it's, it's taking the ride from Mars here that Mother Nature gave it. So can you kind of talk about the techniques you'll use on those primitive materials that we have on the samples from Bennu versus those you use on these meteorites like from Mars?
Yeah, actually, there are going to be some of the same techniques. We've studied Mars meteorites. Of course, one of the challenges with all meteorites is they get contaminated when they get around. You're looking for the building of blocks of life, and the contamination really makes it hard to tease out what formed in space. That's why this is so special, these Bennu samples. Pristine materials, right? We're going to be able to trust the organic results from these samples. I just can't tell you how excited I am.
Well, so our Martian gives us the training to know that, to be ready for what you have on Bennu, and to get ready for Mars sample return when we conduct that.
Absolutely. I mean, we've been practicing on meteorites to get ready for Bennu, and we are ready.
They're ready.
We're ready. Let's go.
Let's go. And how exciting, a piece of Mars.
Touching Mars?
Oh my gosh.
You'll be touching Bennu.
Well, not with my fingers.
That's right.
Recovery operations. Helicopter 1 is approaching the clean room facility with the SRC.
All right, so you just heard we are approaching the clean room facility. Let's toss to James for an update. Take it away.
Yeah, Lauren, this is the final leg of the journey of the SRC. It has been loaded on the helicopter a few minutes ago with a long line to get those operations to bring it back to the Dugway clean room. And in just a few moments, we'll have a nice view from just outside us here as it comes back over. And I can see actually right now we have a view of that helicopter with the SRC attached below coming into view over the Dugway clean room. You can see this wonderful final view, and because we were able to transport it this way, this was determined the most efficient way to actually get this SRC to the clean room. It gives us a phenomenal final view here of that last flight, truly a parade for this sample return here, and just a stunning view of the Utah Test and Training Range, surrounding mountains, and there's that SRC beneath the helicopter with the long line. There's about 100 foot of that long line there. You heard from one of our helicopter pilots earlier that they do this very carefully. They hang out the window of that plane, or the helicopter rather, to determine the safety of that SRC, making sure that they are continuing to travel properly with this SRC to the clean room. And as we speak, team members are staged and waiting just outside that clean room, ready to get that SRC back on the ground once more. There are team members already in the clean room, gowned up. They've been waiting there all morning. They know what they need to do for this next step to get that SRC in. It's going to actually be wheeled into the clean room. They're going to go through a brief operation of cleaning off a little bit of the thermal blanketing, taking all of that off, and then wheeling the SRC and placing it into that room. They're going to remove the heat shield and the back shell of the SRC and actually get the sample canister out. And you just heard from Jim a few moments ago, the most important next step here is getting that sample canister on a nitrogen purge. And we'll remind you again, that is to keep the sample within pristine, uncontaminated from the atmospheric particles that surround us, getting that sample nice and on that nitrogen purge. Just a great view. You can see it hanging beneath our helicopter there, not spinning at all because of that gimbal that is keeping it stable. Low winds today. And that SRC is bagged in thermal blanketing inside that cargo netting. And in just a few moments, it's going to be lowered down to team members outside the clean room. The first team members to actually approach this SRC once it lands will be wearing personal protective equipment and gas masks once again. They're going to do another safety assessment of that SRC, approaching with those PPE to take gas measurements to make sure that the batteries did not heat up and outgas at all during this short flight. And then once they give the green light, there will be a brief team huddle. And then the next step of the recovery operations will continue. They'll get that SRC onto a small carrying cart, and you can see it being lowered down. The clean room, the top of the clean room, the building rather, is in view, and that SRC is coming down to the ground. Slowly being lowered. Everything about this has been carefully planned out, a very slow process. You can see a wonderful view of the SRC and the cargo netting. That metal piece on the bottom is the carrying fixture that helps team members actually carry this SRC. In just a few moments, the SRC will be back on the ground. Its second touchdown of the day, a much calmer one than we had earlier this morning. And you see two members approaching, grabbing that cargo netting to get the SRC on the ground, and in just a few seconds we will have a release of that long line. And there you have it. The SRC has arrived at the clean room. Claps from the audience in the background there. Very excited to have this back on the ground. And in just a few moments, team members will approach. A very excited celebration. Great to have it on the ground. And this is the last step of the process for today's events, getting that SRC in the clean room. In just a few moments, you'll see team members approaching and beginning to unwrap the gift within. You can see our first team members walking up with that gas mask on. This is once again for team members' safety, just to make sure that the operations are continuing nominally, that there are no possible outgassing from the batteries within. The rest of the team will wait for this initial safety assessment before making their approach. And there was some assistance for this step of the process from our team members out in the field. When they bagged the SRC.
Recovery operations. The SRC has been delivered to the clean room facility and is being prepared to transfer into the clean room.
So Zoe is removing the cargo netting now, and she's going to look at those X marks, those tape markers there. They're capped on tape that the team out in the field actually placed on that thermal blanketing. They let her know exactly where the air vents are, the gas vents on the SRC. So she doesn't have to unwrap the whole thing. She can just unwrap that small part and take her gas readings just to make sure that we're not outgassing anything from the batteries within. She'll take once again some thermal measurements just to make sure we're at safe operational temperatures. We don't anticipate any kind of additional heating on that SRC. You can see her opening up ever so slightly that thermal blanketing right at that capped on tape. Taking her readings, you can see another layer of that thermal blanketing there, and then the SRC is safely stored within. She's further unwrapping the SRC. There is additional thermal blanket. You can see there's a couple layers. There's 2 layers of the thermal blanketing and then the tarp over top everything. She just needs to access that interior part and take her gas reading. You can see her with the instrument now taking initial thermal temperature reading. A nod of the head there. Looks like everything is nominal. And she'll take a gas reading here. You can hear the helicopters buzzing overhead here. The rest of our recovery team just shortly, a few minutes ago, landed nearby. And as we speak on the other side of where Zoe is right now, there are team members preparing the clean room for the last leg of the recovery operations, getting that SRC inside the clean room and beginning the process of extracting that sample canister from within. Zoe continues to assess the situation here for safety. She is beckoning for her team to come over. It seems like it is safe for the recovery operations to continue, and 2 more team members will be joining her to assist with this next step of the operation. And here come a few more team members as well. Approaching now is Rich Witherspoon, who's been overseeing a lot of the operations out here at Dugway. There's been a number of rehearsals. We have a ground view now. Zoe is cleared to take off her gas mask. Big smile, very excited to get that SRC back here. It appears to be safe to continue the next step of the operations, getting that sample return capsule in the clean room. She's putting away her thermal protecting gloves. The rest of the team is there, ready to begin actually getting the SRC unwrapped and onto a small cart that will be rolled over in just a few seconds. Rich just giving the team an update on the status here. They do these team huddles just to make sure everyone's on the same page with the recovery operations. It is always simultaneous action. Everything is perfectly coordinated like a ballet dance. Especially once they get in the clean room, you'll see some of those operations. They are very well choreographed. And you can see they are bagging it up just a little bit more before they do this next step of the operation of actually lifting it up onto the cart that will then be wheeled into the clean room. Everything has really been thought out in advance, down to the actual material of the gloves the team members are to use in actually handling the sample return capsule. Nylon 6 is a polymer which is very similar to a protein, and so when nylon gets wet, hydrolyzes, it breaks up and releases a compound called epsilon aminocaproic acid that can be seen in some meteorites. So in order to distinguish between the chemistry that we see on Bennu and the chemistry that we see on nylon degradation, we need to make sure that these sorts of classes of compounds are kept away from the sample. So nylon gloves are not to be used. The gloves you see the team members wearing are made out of nitrile, which is safe to be used. And you can see 2 of our team members carrying that sample return capsule over to our clean room, our camera crew following behind, documenting this whole process. And you can see that cart in the background there. This is to help the team wheel the SRC into the clean room. That big metal door there will be open for just a few moments, and the team will wait just for the dust to settle. It'll kick up a little bit of dust. So they want to wait for that to settle and be visually clean, is the way the team describes it, before they continue to wheel that SRC in further, removing the tarp covering that thermal blanketing protective layer of the SRC. And you can see on the other side of the door, the team members for the clean room team are waiting to acquire that SRC within. And one big lift, all 4 members really digging down underneath there, getting that SRC up onto that fixture, a bit of a heavy lift you can see, and we have it successfully on there. There's some padding protecting that SRC as it rests lightly. You can see the white padding underneath the SRC. In just a few moments, teams will await clearance to open those gates, open that door, and get the SRC inside the clean room, getting in on that nitrogen purge. Just a few moments later, a knock on the door, and there it is. The clean room door is opening up. Our Johnson team on the other side waiting for their precious cargo to arrive, and it is wheeled into the door. We have the SRC inside, just sitting outside the clean room. You can see at the left of your screen with the NASA meatball and the OSIRIS-REx insignia. That is our portable clean room that has been set up here at Dugway for the sole purpose of this part of the operation. This last step of the process of getting the SRC opened up, accessing the sample canister within, getting it on a nitrogen purge, and then actually tomorrow morning we'll have a C-17 cargo plane flying this precious cargo down to the Johnson Space Center. At the Johnson Space Center, they've actually built a custom clean room for the OSIRIS-REx Bennu samples. As I mentioned earlier, they're going to be joining a historic collection that also includes samples from the Apollo program that were collected at the surface of the moon, as well as samples from Stardust and Genesis, both of which actually landed here in the Utah Test and Training Range a number of years ago, and also some Antarctic meteorites. We will not actually be opening up the sample canister today, so that we'll actually have to wait just a few days, so the team will have to be patient still as they wait for the official opening of the sample canister. But what you're seeing now, a bunch of team members will lift up the SRC for our curation team to reach underneath, scrape off any kind of dirt, and place it back on to our carrying fixture here. All of these samples will then be looked at as well. Any kind of environmental samples that potentially came in contact with our SRC are of interest to the Johnson team, so all of that will be documented for later as the team continues to shed the thermal blanketing layers that were protecting our SRC on its journey. On the long line, you can see a couple team members looking through the windows of the clean room, waiting for their part of the process to kick off as they get the SRC wheeled in. We get a nice close-up view of the SRC here. You can really see how charred it is from that entry into Earth's atmosphere. That is the back shield that you're seeing of the SRC, and the top part there has been sealed off. That is actually where the parachute was deployed from. You can see there's that yellowish-orange seal that was placed on top there where the parachute disconnected from the SRC. A brief team huddle here as they walk through the next step of the operation, making sure everyone is on the same page here as they will lift up the SRC ever so slightly, and the team has these brush tools. You can see one of our curators carrying one in her right hand there. They'll lift up the SRC, and she's going to scrape off any dirt from the Utah desert that was on the bottom. That will actually then be certainly of interest to the curation team as they begin to analyze the sample we got back. You can see they're giving it a little brush. Very charred surface of that SRC. That metallic portion below is the heat shield, which protected our sample on its journey through Earth's atmosphere to the Utah Test and Training Range. And you'll see a lift of that SRC for team members to access underneath, checking for any dirt. It doesn't look like we really had any develop. And this is actually great because what happened was, since the soil was so damp today, we had a little bit of moisture, it was actually a much softer landing, so not as much dust really caked on that SRC. It landed perfectly on the surface of the Utah desert. They're going to place this back down again. Seems like their operations are going perfectly according to plan here. They'll do another lift on the other side just so they can access where the team members were previously holding. And then if all looks good, they will clear this to be wheeled into the clean room. And really just backing up and thinking about this entire journey from where we started this morning. Right before, maybe about 4 hours before we kicked off our broadcast, the team at Lockheed Martin gave the go to release the SRC that you see right here from the main OSIRIS-REx spacecraft. It detached from that spacecraft on its 4-hour solo journey. There's nothing we could do at that point as it entered into Earth's atmosphere, began the punishing entry, descent, and landing, which took us to the Utah Test and Training Range. Out in the field, teams worked to recover the sample, and they actually continued to take samples, environmental and air samples of the region around where we landed. We successfully bagged this sample return capsule in thermal blanketing that you see right there beneath the SRC, that plastic-looking material. We transported it successfully with our long line operations. Big thanks to our helicopter crew today for helping us get this sample return capsule to the clean room. A couple more lifts here you see, and they're going to remove that last layer of thermal blanketing, placing the SRC on its own without any layering onto our carrying fixture. You can see just how charred up those gloves look. A lot of that char from the heat shield getting off on their gloves. You can just see how dark it is. Really heating up. Initially, when we hit the Earth's atmosphere, we were at over 5,000 degrees Fahrenheit. That's about half as hot as the surface of the sun. Quite warm. It's cooled off substantially, so obviously, as it's been transported throughout the day here, and is now just moments away from getting transported into our NASA clean room that you can see on the right of your screen. Team members are all gowned up, and inside that clean room there is a fixture dead center that this SRC will be placed on that will allow the team to be able to gather around and begin to open up this nesting doll protective layer, the SRC, to access our precious cargo, that sample canister within. Again, they want to make sure that everything is clear before they wheel this in. Everyone's ready to go. Everything looks good before they wheel that sample return capsule into our clean room. Just truly an incredible day, and the science that's within these samples is truly hard to fathom right now, just how influential this science is going to be. Keep in mind, these samples are from the origins of the solar system, billions of years ago. They hold the clues to how everything around us came to be. And in just a few short weeks, scientists will begin to analyze these samples and stow away even more sample for generations to come. Future scientists will be able to open these samples and continue the journey of OSIRIS-REx. As we speak, this incredible mission still has not come to an end. Our spacecraft, our intrepid robotic explorer OSIRIS-REx, is now dubbed OSIRIS-APEX, heading to the asteroid Apophis in the year 2029. Obviously, we do not have that sample return capsule or the sample tag SAM, which actually helped us collect that air filter looking thing that helped us collect these samples at the surface of Bennu. That is no longer attached because it's sitting right here in our clean room. But the mission will continue. The team will map the asteroid Apophis in great detail, similar to what we did with Bennu, descending down to the surface, firing its thrusters, kicking up a sample. And as we speak, the sample that it got from Bennu back in 2020 is just moments away from being wheeled into the clean room. The team doing one more sweep, cleaning off those wheels that came in contact with the pavement outside, just before getting this SRC wheeled over into the clean room. Just truly an incredible journey of this mission. 3.86 billion miles total to Bennu and back with this sample. And now it's just a few feet away from our clean room. You can see on your screen too some of the gas coverings to those vent covers that were placed out in the field that prevented any kind of contaminants from getting into the SRC. And as I mentioned before, that SRC is a nesting doll of sorts, very protective, and within there's a complex network of tubing, labyrinth-like tubing, preventing any kind of contaminants from getting into the sample. But the team still wants to get that sample canister on a nitrogen purge. That will ensure that it will stay clean, pristine from any possible atmospheric contamination. It's going to stay on that nitrogen purge all the way through its trip down to Johnson Space Center, where ultimately it will be opened at their curation facility. You can see in the bottom left of your screen our team members inside the clean room, all gowned up, and right at the bottom there, that kind of goldish bronze looking fixture is where this SRC is going to be placed for the next step of the operations. This, as everything has been, is a very careful process, choreographed every step of the way. Team wants to ensure that everything is cleared before they wheel that in We are just moments away from that wheel of the SRC into our portable clean room. You can see in the background in the pink shirt, Jason Dworkin observing. He is one of our astrobiologists from NASA Goddard. He will be looking at these samples along with hundreds of scientists from around the world, helping us better understand the origins of our solar system. The anticipation builds for this final moment. A massive sigh of relief at this part of the way, because we have that SRC now not only on the ground but just inches away from our clean room. The team looking inside there just to ensure everything is good to go. Get a great shot of that NASA meatball and the OSIRIS-REx logo on the doors of the clean room. The operations at Johnson Space Center, once this sample canister is transported there, will be truly a sight to behold as well. In just a few days, we're actually going to get our first science results from the sample within. And as I mentioned, they built a custom clean room at the Johnson Space Center for this very purpose. The team that you see on screen here has been rehearsing at that clean room, preparing for the big event of actually getting that sample opened up and beginning to parse it out and ship it to labs around the world, stowing a lot of it for future generations. Truly an incredible amount of science that we can't even begin to imagine is trapped within those rocks. And I personally am very excited to see exactly how much sample we got back. The original mission requirement was a mere 60 grams. We had an explosive tag event at Asteroid Bennu back in 2020, excavating over 6 tons of material when we contacted the surface and stowed potentially 250 grams of sample within that tag SAM device, that air filter that Jim was just showing a few moments ago. There are also no radio frequency signals allowed inside the building that you see here too. The building is on ordnance protocol. They want to make sure that everyone is safe here, that there could still be active ordinances from the parachute deployment with the OSIRIS-REx spacecraft. We had a mortar fire to release that parachute, that orange parachute that took us the last stage of our journey to the surface of the Utah Test and Training Range. Crew members pacing around inside that clean room, waiting to get that SRC inside. And so when they actually open up the SRC, removing that back shell, the sample canister, they will attach a couple tripod-looking legs to it, these small legs that will allow them to flip it over onto a table nearby. You can see that metal table in the back of the clean room. And at that point, they're going to put it on a nitrogen purge. You can see they're moving that fixture a little bit closer to the door because they're just going to lift that SRC off of the carrying fixture and place it onto the clean room's fixture. It's a quick little transfer, very quick opening of the doors. In just a second here, you can see our team members moving that a little bit closer. The doors are now open. We are entering into the clean room, and that SRC is about to be moved off onto our clean room fixture. Our clean room team members carrying that SRC in, and these doors will be slammed shut just as soon as we can get that SRC fixture out, and there we go. It is in the clean room. The SRC from the desert of Utah, earlier this morning arriving, has been successfully delivered to the Dugway portable clean room. And you can just see just how charred that SRC back shell and heat shield are. A great close-up angle here. You can really see our prized sample return capsule at long last in the clean room. It's hard to fathom that just a couple years ago, this sample return capsule that you see here was over 200 million miles away from us on the other side of the solar system. The OSIRIS-REx spacecraft worked to quickly stow the sample it got from the asteroid Bennu at sample site Nightingale into this sample return capsule. We slammed that lid shut and prepared it for the long journey back. It took 1.2 billion miles to get from the asteroid Bennu after sample collection to Earth's atmosphere. We entered in 82 miles off the surface of San Francisco, went through the punishing entry, descent, and landing, landed in the desert, and now here we have it, the sample return capsule in our clean room. The team's going to move this a little bit over to the center of the room so they can all gather around and begin the process of removing that back shell and then ultimately getting the heat shield off as well. So what's going to come up next here is that back shell that you see there. The team will remove that, get the sample canister that is within. It's a complex network of tubing to get to that sample canister, and this is also, like I mentioned, a nesting doll of sorts protecting our sample within. They're going to get that sample canister out. They're going to get it on a nitrogen purge. That is our safe point. That is what we're looking to get to today. As soon as we're there, operations for the day will effectively be completed. Tomorrow, the SRC, the sample canister rather, will be flown on our C-17 cargo plane down to the Johnson Space Center, where in just a few days it will actually be opened up for scientists to be able to see the sample within. It's been incredible covering the moments of today, the journey of our SRC from Bennu to the desert of Utah to our clean room. And for now, back to you, Lauren and Jim.
James, your coverage has been impeccable. We could not have done it without you.
Go, James.
So to be clear, the newly redesigned Apex mission will not be touching down on its destination asteroid Apophis. The big reason for that, of course, is that the vehicle's single-use sample collection device just arrived here on Earth, containing samples of asteroid Bennu. After more than hundreds of millions of miles in space, that sample will now travel a few hundred more miles to a specially prepared home where experts intend not only to study it, but also preserve it for future generations. That facility is the purview of our next guest. Eileen Stansberry is the chief of the Astromaterials Research and Exploration Division at the Johnson Space Center. Welcome, Eileen.
Welcome, Eileen.
Welcome.
Thank you.
How about that? Did you check out that all of that cool movement between the clean room and everyone preparing it?
Absolutely. It's so exciting. Anytime you get samples back, and being here today to receive the Bennu samples is a highlight. The team has been extraordinary. The work that all the variety of participants, team members, teammates that work on this mission have been extraordinary. From the flight teams, the mission development teams, operations, science, curation, all working together to bring these samples home to us. And it may seem as if it takes a lot of time getting into the clean room and processing in the clean room, but a lot of that is because of preserving the contamination, the scientific integrity, minimizing the contamination on the samples. Clean room protocol is always slow and methodical to allow any dust or particles that gets generated or any of the debris from the back shell to settle before you do the next step. So all of these steps are very carefully choreographed to ensure the scientific integrity and maintain the pristine nature of these samples.
And you'll be doing, Eileen, when you receive these in your laboratories at Houston at Johnson Space Center, you'll be doing the next phase of that very special curation. Can you tell us a little about that?
Yes, we have a special facility that was designed in particular for these samples to have all of the appropriate materials restrictions to make sure that these particular samples stay pristine for generations to come. As stewards of the scientific value of samples, we manage samples for future generations in addition to the current science that is available on these samples. So the first thing that we will do is bring them into one particular clean room, let it settle, and we will transfer the sample canister from one level of cleanliness progressively to next level of cleanliness to ultimately a continuously purged nitrogen glove box. So what they're doing here in the clean room in Utah is to remove the contaminating potential of the heat shield and back shell that were charred during reentry, and get the sample canister on purge to have nitrogen continuously flowing through that canister to ensure that there's no earth contaminations that will leak in, even though the likelihood of that is vanishingly small, making sure that there's a continuous nitrogen purge. So that nitrogen purge will stay on the sample canister until it gets into the nitrogen glove box in Houston, where we will start deintegrating the sample canister to get to the precious cargo inside.
Which are inside the sample head, which has...
Yes.
Right, okay. Right.
But there is the possibility of some samples being within the sample return capsule, this capsule here, because the TAG-SAM event worked more well than we had anticipated. There could be some sample of Bennu within the sample capsule.
Wow.
And so we will make sure that that sample also gets identified and saved to maintain its integrity here, so that it also retains its value.
Wow.
Amazing.
What an opportunity. We may have more goodies than we thought.
Yeah, we thought.
Jeez, Eileen.
Well,
Good
Eileen,
job.
thank you so much for joining us today. We've loved having you.
Right, really, Eileen, congratulations. Way to go.
Thank you, and we're so excited.
Your whole professional life has been planning for a future event, and then suddenly that day arrives, like today, which is probably a perfect segue to be bringing up something that may come as an unexpected surprise to mission fans. Today may be the conclusion of flight operations for OSIRIS-REx, but the mission is not exactly finished.
After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astromaterials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come. Having delivered its cargo, the OSIRIS-REx spacecraft will depart Earth, but its journey will not quite be finished. In a daring encore, the renamed OSIRIS-APEX will enter an elliptical orbit of the Sun, repeatedly passing within the orbit of Venus and pushing the limits of its thermal design. Beginning in 2029, it will chase down and investigate Apophis, a 1,200-foot stony asteroid destined to make an exceptionally close flyby of Earth. After 13 years in deep space, at the start of a new decade, alone on a new world, the journey will continue.
Jim, OSIRIS-REx collected its samples and is bringing them back to Earth for analysis, like we've all watched today. But how else is NASA planning to analyze its other samples?
So, as you heard from Eileen, OSIRIS-REx in Houston will start the sample preparation around hundreds of labs later. It's going to be fantastic. We also sometimes bring our laboratories to the samples themselves. Curiosity rover, she's carrying a huge payload, not unlike those we'll use in laboratories here. Sometimes we go to new places to actually bring the labs to study samples that we can't bring home. That's our new wrinkle.
And on that note, when I consider how many places there are to visit, I'm aware that a guy like you is probably weighing all of the choices, about where to go. So speaking of which, you are the principal investigator for a new mission called Da Vinci, which for those at home, principal investigator is basically the big guy in charge. So what is this mission about?
So Da Vinci is a mission to Venus. You can see it in the morning sky, and we haven't been back to the Venus atmosphere and all the complexity and how that formed and evolved literally in a generation. So together with a very big team, it's not just the PI. I mean, Dante is the gold standard PI for all of us. But with our team, we're going to bring a spacecraft with the kind of instrumentation we'll be using on the samples from Bennu and from Mars to the samples in the atmosphere that will tell us about the assembly of that atmosphere, whether Venus had oceans for how long, and come under the clouds and see the mountainous regions and their chemistry for the first time in history. And so we're excited to pick up on the great news from this mission, OSIRIS-REx at Bennu, and some Mars exploration, and take that forward to Venus so we'll get the next generation interested in our sister planet.
So everybody stay tuned for that one. So Jim, you've also been the PI of several previous missions. Put yourself in Dante's shoes. How would you feel today?
Dante must be both overwhelmed and overjoyed. Yeah. He's probably, as my wife says occasionally about me, beyond words. And he's been waiting literally his professional lifetime for this. It's here, it's happening, the science is going to flow, they can't miss. Honestly, I am sure Dante and his team are just sitting on pins and needles waiting for the transfer to Houston, all that stuff Eileen said, so we can get to work. This will be epic.
And Jim, not only are you the PI of Da Vinci, but you actually had a hand in OSIRIS-REx as well.
Well, way back in the dark mists of 15 years ago, we were all wondering how we can sample things as hard as asteroids like Bennu. And people like Dante and others had generated the idea we were all talking, because we wanted to think, how do we sample the solar system? Cruise to the moon, great. You know, giant sample return systems to Mars, fabulous. But these small bodies are also important, and they've been a priority for our National Academy. Cometary nuclei, asteroids like, of course, carbon-bearing ones like Bennu. So when those folks got together, we were all in conversation, and they proposed mission ideas, and some of us were able to participate in very small ways to help them get these missions going. It's just a thrill to see them succeed so well.
Especially after 15 years. As you can see, Jim is a wealth of knowledge. So on that note, we're getting questions from around the world about this thrilling mission. Let's take our final questions of the day. All right, at Oatmeal, today is my birthday. Can I have some of the asteroid sample? It would mean a lot.
Well, you know, you heard there's other birthdays today, too, including the Colonel.
I think Oatmeal saw that it was also Colonel Harwell's birthday.
But as Danny Glavin and Jason said, you know, the samples from Bennu are for scientific research, education, inspiration. They'll be used, you know, for future generations even, as Eileen said and Jason said. So, unfortunately, we can't give you Bennu. We can give you pictures and up-close vantage point like we've given you today, and as the science is done by the science community, and so you'll be part of that, and you can write proposals to work on samples if you have a neat new instrument you want to try. So stay tuned.
Stay tuned. And I understand, Oatmeal. I also want a piece of that sample, yes. But we got to, you know, we can't. All right, Jim, let's take one more. All right, at Electromanicia, I hope I got that right. What questions are we hoping to answer by studying the samples from asteroid Bennu?
Well, fantastic question, and there are many. It's all in the name. So we want to look at those building block chemistries of the earliest solar system. It's all eradicated here on Earth. We have to go to places like Bennu or other asteroids like it to get those records. So we're going to look in the deep time to understand our solar system from those chemicals. We're also going to look at how we use a real asteroid stuff to understand what we see of other asteroids through telescopes and flyby spacecraft. That's the ground truthing, or the asteroid ground truthing that we do. We're also going to look at resource potential. These asteroids contain bound water in minerals. Those are really cool. You can get the water out. That's neat. Also, interesting distribution of metals. So this is a really exciting opportunity to put that all together and also understand the mechanical behavior of these objects. They're rubble piles held barely together flying through space. So we're going to do all of that and answer questions we haven't even thought of yet. Dante's team will invent the questions for the future from what they do with these samples.
Fantastic. All right, I think we have time for one more. Let's take a look. At Horrors of Cody, is there any worry of possible bacteria or virus from the sample, regardless of the clean room?
So that's a very good question. And of course, the team, and you heard from Jason Dworkin and others, have been thinking about that for a long time. We think these types of asteroids and the materials from them are not life-bearing. And they're not life-bearing, and so we have classified this mission as a certain class of planetary protection. So we're not expecting any true life-bearing biological elements to be a part. But the fragments of organic chemistry, carbon-bearing stuff that you heard Danny Glavin talk about, the building blocks of life that got it all started in all the places it is here, but also maybe elsewhere, really important. So we don't expect to see any of that. We've contained the contamination. You see what's going on now in the portable clean room and at Eileen's place back in Johnson Space Center. So we're very optimistic. No worries about that stuff. We're good here.
So I think we talked about this a little bit, but I think one thing people are maybe wondering, or even maybe a little worried about, is could this sample contaminate Earth? Are we at risk of something catastrophic?
Literally so vanishingly small that no one would rightfully bet on anything like that. This is space, rock, and dust from a time so far ago that's been baked in the space radiation that wouldn't be good for any organic, any living thing, sorry. We're all organic. And so it's been sterilized by being in space, in effect. And we do the same thing when we go and sterilize stuff that we'll bring back from planets like Mars. So.
How long is this next process going to take? You know, we're in the clean room now, we're going to go to Texas. How long is this all going to take before we start getting some results?
So in the next few weeks, in the next couple of weeks, by October 11th, we expect the team in Houston, Eileen's team, and together with Dante's team, will have done that first proper containment and understanding all the possible sources of contamination, so they can document those for the future and also make sure they're through all those gates that Eileen was mentioning, so the samples are protected from anything from Earth, so they won't be contaminated. Then they'll do some first characterization with all these great machines they have in Houston, and we'll start talking about what they get by the end of October, going into the Christmas time. And by the end of January, I've been told the science team meeting, the sample leaders will start reporting to all of us what's going on.
Wow, that is soon. And you heard that unboxing day is October 11th. Did I hear that
That's right.
Okay.
It will be a Christmas party for samples.
Okay, that's right. So, Jim, I'm struck by how these last few minutes compared to the last few years. You know, here we just saw human hands wheeling precious scientific, cargo at walking speed, when just a few hours ago it was barreling through Earth's atmosphere.
Exactly. We went from cosmic velocity to velocity smaller than an ant would use to crawl across the table to pick up a crumb. And so that's the speed of science. To get it, the engineering flies cosmic velocity, sampling, all that great dynamics, and finally now the careful, methodical, snail's pace to get it done right so we preserve it. I mean, this is like geoarchaeology of samples from a place that's not Earth. Very special.
Yeah, absolutely. The sample return capsule isn't done traveling, of course. Once it gets stabilized on what's called a nitrogen purge to ensure everything remains dry and uncontaminated by intrusive gases, the entire apparatus will be loaded aboard a C-17 cargo plane for a flight on its way home to Johnson Space Center. Once it arrives, scientists are ready to start working on vital research on this extraordinary sample of the asteroid Bennu. But that airplane ride and the research plans waiting for it on the other side starts tomorrow. For now, the OSIRIS-REx sample return capsule has completed its solo journey of nearly 4 billion miles, landing in the Utah desert, and is now in the expert care of our on-site sample curation team. But we're not out of the woods yet. We did mention this nitrogen purge.
That's right.
So
we have to carefully contain this so we can do that work and literally, really transform knowledge for all time. This is the thing that we dream of, and with Dante and his team, 10 years ago, we're thinking of that. Transformational knowledge that will change how we think of ourselves.
And we couldn't let you go before we share something fun. So we just delivered a sample of the asteroid Bennu back to Earth, but the UPS can also deliver fun stamps of the actual asteroid Bennu sample return. Let me turn that over so you can see it on this side. How fun is that?
So we have brought an asteroid first-class delivery from OSIRIS-REx to Earth, and our postal service here in the United States is issuing stamps to build on that inspiration so they can deliver our packages for us.
How exciting. I know, everybody needs to get some of these.
Yeah.
These are really cute.
Yeah, I want one.
I would like one too. As we're wrapping coverage here at the Utah Test and Training Range, let me remind you that this is not the end of the story. Next up is our post-landing news conference scheduled for 3 p.m. Mountain Time, 5 p.m. Eastern Time on NASA TV, presented live right here on nasa.gov and other streaming sites. You can also find mission updates on X at NASA and on the web at nasa.gov. That's all the time we have for today. Jim, it has been a pleasure sharing the stage with you. We did it.
Way to go. Thank you, Lauren, for having me.
And a huge thank you to all of our guests for joining us today, and a warm thanks to all of you out there for watching us. Here are some highlights from today's exciting landing. Special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space.
We see.
PDL milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere. We have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. Disconnecting from the back shell. We'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recovery operations. SRC is in the cargo net, and all the gear has been stowed in the helicopter.
Special coverage of America's first.
$270 meters in closing. Crew Dragon expected to converge with waypoint 1 directly in front of the International Space Station in less than 5 minutes. You can see the views right over the shoulders of Commander Shane Kimbrough and pilot Megan MacArthur. Kimbrough on the left, MacArthur on the right from that view.
From this view from the International Space Station, you can see what we were mentioning earlier, where Dragon was below the station. You could see that previously when it had Earth in the background. Now it is almost adjacent, or almost in the same orbit as the International Space Station, as it's making its way to the docking axis at waypoint 1. This maneuver from below the station to in front of the docking port is almost complete, just a few minutes away.
Getting great views from all around, from the station side, from the Dragon side. The outline of the station you see on the displays inside Crew Dragon is in line with the position of where Dragon is relative to the International Space Station. It's almost at the docking axis, about 2.5 minutes to go until it converges with waypoint 1.
And as a reminder, Dragon is flying autonomously, so they aren't using those display panels to fly Dragon. They're just using them to monitor each step of the way. So the crew is basically just patiently waiting until they dock with the station.
Now seeing Dragon in a better view, a lot more clear now that it's only 240 meters away. You can see the nose cone clearly deployed, extended towards the space-facing side or zenith side.
A really good zoomed-in view, and you could almost make out those 4 bulkhead thrusters on the forward portion of the Dragon capsule.
There you go. The Cronus is adjusting the aperture of the station cameras.
Dragon SpaceX on the big loop. Approach 1 and soft capture ring extension will begin shortly. Dragon will continue to waypoint 2 with the additional lighting assessment occurring at 110 meters as previously noted. For awareness, if sunlight results in the loss of the Dragon Eye geofilters, Dragon will autonomously retreat back to waypoint 1, remaining on closed loop control using the time of flight filters. I'll copy.
We are in a handover period, so we may have missed a call as we were switching from TDRS satellites. We're looking at about 20 seconds to go until we converge with waypoint 1. There's going to be an approach burn maneuver using the Draco thrusters. That's called approach 1, and that'll move Dragon from right in front of the docking axis 220 meters away and start moving in, closing in to waypoint 2, just 20 meters away from the docking axis. Of course, they'll be monitoring along the way.
We did hear the Corps mention that they are going to have a checkpoint to make sure that there isn't too much sunlight on the space station, which will prevent Dragon from docking. If that does happen, Dragon will autonomously back out and wait until the sunlight has cleared to ensure a good docking with the space station. Because this is all autonomous, it uses some visual cameras to align with the docking port. So it's really important that we don't have that sunlight getting in the way.
Section over on the big loop, sound check.
SpaceX has you loud and clear on the big loop. Helm me.
Very loud and clear. Your last call, we copied most of it, but you cut out towards the end there. I'm not sure if there's anything important for us.
Copy. I'm going to repeat the end of the call. We did have a TDRS handover. Just for awareness, following the lighting assessment, if we continue but sunlight results in a loss of the Dragon Eye geofilters, Dragon Eye will autonomously retreat back to waypoint 1, still on closed loop control using the time of flight filters. I'll copy.
Okay, we copied all. Thank you very much for repeating.
No problem, Shane. And for awareness, the C2V2 link reconfiguration has been completed.
Copy, C2V2 complete.
And there, the Corps just reiterated that they will be checking to make sure that the sunlight is not in the way of the visual systems between Dragon and the space station. If that does happen, Dragon will autonomously retract and wait until we do get some good visual views for these systems to dock with each other. So.
That's right. Crew Dragon resilience actually coming into view a little bit clearer now from the cameras aboard Dragon. Docked to the zenith port.
Yeah, that was on the upper portion of the screen.
That's right. Now again, to reiterate, Dragon has passed waypoint 1, 220 meters in front of the station, executed a burn maneuver to go ahead and move in. So we're in approach 1, and it's heading towards waypoint 2. Now inside the keep out sphere. It's currently in the process of extending its soft capture ring that'll be used to dock to the international docking adapter of the forward port. We're monitoring the visual systems of Dragon. It would execute an automatic retreat if the sun was interfering with the optical systems as it makes its way towards an approach. We're at about 150 meters away from the station.
And we have such a great camera view here. You can really see the detail on Dragon. Again, those 4 bulkhead thrusters. You could almost read the logo, the Dragon logo on the side of the vehicle.
That's right. We'll get even better views as it makes its way even closer to make contact and capture with the space station.
There it is.
Yeah, based on the trajectory here, we may even anticipate a capture a little bit earlier than anticipating. We were looking at about 2:10 a.m. Pacific time. It might be at maybe closer to 2:07 p.m. The features of the space station coming into view very clearly.
Yeah, you can see a lot of the detail there, and as you mentioned, the Crew 1 Dragon.
SpaceX station on the big loop. Procedure review complete, ready for docking.
Houston copies.
All right, that was confirmation from Victor Glover aboard the International Space Station. From the space station side, he is go for docking. The soft capture ring itself is fully extended. We're 115 meters in closing.
Looking at your screen, the port that we are going to be docking with is directly in the middle of the screen, that circular area on the International Space Station.
Station Houston on 2 for Ike regarding SSC 17 and D2DM. We are seeing some strange configurations on the video, and we would like to close and restart that. We can take care of that from the ground if you would like. Absolutely. If you're seeing nominal, that works for us.
Okay, so Victor Glover aboard the station still has...
And Dragon SpaceX soft capture ring extension is complete. Additionally, we did beat the sunlight for the Dragon Eye filters, so we are not going to command a hold.
Copy, Bill.
All right, so that's great news. We passed the 110-meter checkpoint that the ground operators were referencing, making sure the sun wasn't interfering with the optical sensors, the Dragon Eye, that are part of the guidance and navigation and control system aboard Dragon. We passed that check mark. We're good to go. We beat the sun there. So we're now inside 80 meters and closing. Dragon will pause at 20 meters. That's designated as waypoint 2 to conduct a go, no-go poll for the readiness on both the Dragon side and the International Space Station side, making sure everyone is good for docking. If we are go, we expect to dock during this pass over an orbital daytime. Expected in less than 20 minutes. Some of the features there, you can see a lot of the visiting vehicles on board station. At the bottom is a Russian Soyuz vehicle that delivered crew to the International Space Station. Just in front of that, or actually above that, is the Crew Dragon Resilience docked to the Zenith port. Once Crew Dragon Endeavour arrives, there will be 2 Crew Dragons attached to the space station.
And this view from Crew Dragon looking at the International Space Station, it looks like it's this very slow and steady movement, but in reality they're moving at 17,500 miles per hour.
The rendezvous operations are absolutely incredible. You can sort of see the Northrop Grumman Cygnus cargo craft as well, some of the ultraflex solar arrays coming into view a little bit clearly.
And you can see that Crew 1 Dragon vehicle on the top of your screen. Once Crew 2 docks to the International Space Station, we will have 2 Crew Dragons docked at the same time for the first time.
That view right there was truly a representation truly of an international cooperation there. The U.S.-built Node 2 is where the Dragon will be docking today. It was flanked by the European Columbus module and the Japanese GEM.
On the big loop, visors down.
SpaceX copies. The visors are down. We may enter into a hold at waypoint 2. We are still awaiting ground go for final approach.
Never copies.
The detail of this camera view is pretty incredible. Here from the International Space Station, watching Crew Dragon as it is slowly approaching.
And as expected, Dragon holding at waypoint 2. It's at about 20 meters right in front of the docking axis.
If you're just now joining us, we are just waiting for a confirmation for go for docking. Currently holding Dragon at waypoint 2. And again, it looks like Dragon is just paused and not even moving, but again, as we just mentioned, both the space station and Crew Dragon are actually moving at approximately 17,500 miles per hour. So it's pretty incredible how it can hold these speeds so that it looks like they are just completely paused.
That's right. Teams on the ground, both from the station side in Mission Control Houston and Mission Control Hawthorne, Just checking and verifying all systems are go to proceed with docking.
And when we do begin docking, there will be two portions of this. There will be a soft capture followed by a hard capture. The soft capture will be a soft capture ring that basically just connects the Crew Dragon to the space station to enable the hard capture, which will be 12 hooks that will attach Dragon to the station.
Again, we're standing by the International Space Station, flying over the Indian Ocean now, just south of the Indian border. It's heading on a southeasterly course just south of Australia, and should cross over the Terminator line into the Pacific Ocean into an orbital nighttime. The expectation is for Dragon to depart here from waypoint 2 and proceed on with docking ahead of orbital nighttime to beat the sun.
You can see this camera moving around. Again, this is controlled from the ground from Mission Control Houston. And they're maneuvering this camera around so we can just get a more detailed view of the Crew 2 Dragon Endeavour patiently waiting, docking to the International Space Station.
Dragon on its second flight, about to dock to the forward end of the International Space Station for the second time.
And Station and Endeavour on the big loop. Ike, we are not able to recover that video for the D2DM, so you can close that window, and we should be ready to press into final approach shortly.
Station copies.
You did hear that call out speak out to Ike. Ike is actually referring to Victor Glover. That is just his nickname.
Dragon SpaceX on the big loop. Ground is now go for final approach. Upon confirmation of crew readiness for final approach, we will enable the approach. Please confirm crew readiness, and a reminder, once Dragon is inside the crew hands-off point, retreat and breakout are no longer permitted.
Crew is ready for final approach.
And got some good words that the crew is ready for the docking to the International Space Station. They no longer will have control of any aborts. If there is an abort needed, it will have to be done by the Dragon autonomously.
Houston on the big loop, monitor per steps 3 and 4 and 1.104.
Station copy.
Again, we are now moving into the CHOP, which is the crew hands-off point. As I was mentioning earlier, if there is an abort, it will need to be done autonomously by Dragon.
All right, we did get confirmation. Approach 2 has been initiated. So Dragon now making its way inside the 20-meter hold point at about 18 meters and closing. Final approach of Endeavour to dock with the International Space Station has started. Docking expected in about 3.5 minutes from now.
You can see on your screen as Crew Dragon slowly approaches towards that port for docking.
Sorry, we're 13 meters and closing, making a slow and methodical approach to the docking port. That's on the forward end of the International Space Station, that international docking adapter where Crew Dragon Endeavour has docked once before.
Meters.
Copy, 10 meters.
What that call out was Crew Dragon is just 10 meters away from the International Space Station as it continues its approach for docking. Docking will occur in 2 phases. There will be a soft capture followed by a hard capture, and what that hard capture means is 12 physical hooks will connect the Dragon to the space station.
Great views. Dragon just 6 meters away as the station and Dragon fly in tandem 263 statute miles over the South Indian Ocean in the background.
5 meters.
We're 5 meters and closing.
Copy, 5 meters.
Really start to see the detail on Dragon there as it is closing in on docking.
That's right, 2.5 meters, 30 seconds. Crew hands off point is called out.
Dragon SpaceX on the big loop, soft capture confirmed.
Copy, soft capture confirmed.
Great news with that call out. That soft capture is confirmed.
That's right, that soft capture time, 2:08 a.m. Pacific time, 4:08 a.m. Eastern. Station and Dragon connected 264 statute miles over the South Indian Ocean. Endeavour connected to International Space Station for the second time.
There are still a few steps to complete before Dragon is securely attached.
Dragon SpaceX on the big loop, soft capture ring retraction in progress.
That's good. The ring retraction is happening. Ring retraction happening as expected. And after the ring retracts, 12 hooks will latch, 6 at a time, to perform a hard capture, and will officially mate Dragon to the International Space Station.
Got this really awesome view of Dragon as it is connected to the port, currently making progress on hard capture.
Soft capture ring retraction does take some time. It is continuing at its anticipated speed. Things are looking good. Again, this is the first in a series of steps to officially mate Dragon to the station. If you're just joining us, we heard the call out for soft capture confirmed at 2:08 a.m. Pacific time, 4:08 a.m. Eastern time. Station and Dragon were 264 statute miles over the South Indian Ocean at the time of contact and capture. We're still in the process of retracting the soft capture ring and anticipating proceeding with the hard capture sequence, where 12 hooks will drive to officially mate Dragon with the International Space Station's International Docking Adapter at the forward port. Crew Dragon Endeavour docked to that forward port for the second time.
Dragon SpaceX on the big loop. Ring retraction is complete. Docking sequence is holding for MCS reconfiguration.
Endeavour copies all.
If you're just now joining us, as you can see on your screen, Crew Dragon has made contact with the International Space Station. And we're currently in progress of...
Endeavour and station, MCS is configured, proceeding with hook driving.
Endeavour copies.
Station copies.
Great timing there. This is now the beginning of the hard capture sequence. This is where 12 hooks will latch between Dragon and the space station, 6 hooks at a time. This will take a few minutes to complete.
That's right, that MCS is just configuring the International Space Station's attitude control. It needed to be configured differently between a soft capture and hard capture sequence. So now that that's been confirmed, they can go ahead and press to drive the 12 hooks needed to confirm a hard capture. To reiterate, the Dragon had contact and capture with the space station at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. Space Station and Dragon crossing over the Terminator line, just south of Australia, about to head over the South Pacific Ocean. Start seeing the views of Dragon get a little bit dimmer as we still undergo the hard capture sequence. All right, again, we're still undergoing the hard capture sequence. There's 12 hooks that drive to officially mate Dragon to the International Space Station, 6 of them driving currently. Station attitude configured to support the hard capture sequence, now operating on control moment gyros to maintain attitude control during the hard capture sequence. All right, and we have confirmation the first set of hooks, all 6 have been driven. They look good. The second set are driving and are looking good at the anticipated speed. Halfway there.
This will take just a couple more minutes for hard capture to complete. As a reminder, after hard capture is complete, they do still have some more steps that they need to go through in order to ensure that the space station and Dragon are safe for crew ingress. There will be the hatch opening as the crew the crew on board Dragon as well as the station will be walking through some procedures prior to ingress of the crew on the International Space Station, but once they do ingress on the station, there will be a welcome ceremony.
Again, half of the hard capture hooks have been driven and locked into place. The second set of 6 hooks, 12 total, 6 of them driving.
Dragon SpaceX on the big loop, hard capture is complete. You are go to open visors.
Copy, hard capture complete. Opening visors.
All right. Crew Dragon Endeavour officially made it to the International Space Station. That dynamic period of the docking phase is complete. The crew inside Dragon have been wearing their suits just as an extra precaution, but they can go ahead and pull up their visors. It's going to be some time until the hatches themselves are open between Dragon and the International Space Station. Still some things to configure on that side. The vestibule on the International Docking Adapter that separates the hatches of Dragon and the International Space Station, that's been exposed to the vacuum of space and has had the sun shining on it periodically. So when repressurizing the vestibule to equal the pressure inside the space station.
Station, hard capture complete. Welcome to ISS. We are so excited to have you aboard.
Thanks, Anna. We're glad to be here. We'll see you all in a few minutes.
International Space Station Commander Shannon Walker welcoming the crew. Now Crew 2 officially made it to the International Space Station. Again, it's going to be some time until they come in, but the commander of the International Space Station welcoming 4 new crew members for her expedition on board here shortly. All right, so again, there's a series of steps here as we enter into an orbital nighttime, completing the docking of Crew Dragon Endeavour to the International Space Station for a second time. That contact and capture occurring at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. We have a confirmed hard capture. The umbilical is in motion to connect the station to the Dragon and provide data and power and communication through that umbilical, so it no longer has to rely on its own systems. Everything's looking good for that vehicle. It's going to be some time again until we repressurize the vestibule and get those hatches open between the Dragon and the International Space Station. It'll be the crew inside the station getting that ready to be opened.
Endeavour SpaceX docking sequence is complete. Welcome to the ISS.
Thank you, SpaceX. Great to be here.
In some more official words, that docking is complete. The crew must be so excited to finally have arrived at the space station. Again, there is some more steps that they will need to complete and some checks before they can ingress on the space station. But the crew can now get out of their suits before moving into hatch operations. So now they can start to get comfortable again. They no longer need these suits now that they have arrived at the space station.
That's right. And so it'll be some time again until that area between the International Space Station and the hatches.
SpaceX Endeavour on Dragon to ground. Are you ready for us to begin suit doffing?
SpaceX copies. You are go to begin suit doffing and audio configuration. Procedure 4.012.
Copy, that's in work.
So again, it'll take some time. The crew will begin doffing or taking off their suits. It'll be some time to repressurize the vestibule. Station side, astronauts on the station side will configure the hatch, getting ready to open that up and welcome the crew inside the International Space Station. It was a pretty great docking. Everything happened right on cue and as expected. So it was a great to see Crew Dragon Endeavour dock to the International Space Station once again. We've enjoyed it from here in Mission Control Hawthorne, but to see how things turned out from the space station side of things as we work together to complete today's operation, let's go to Courtney Beasley for a refresher on what's ahead now that Dragon is docked.
SpaceX cameras are external.
Copy, thanks.
Thanks, Gary. It's great to see Dragon successfully docked to the International Space Station. Even through the face masks, you can see and feel the excitement in the room here in Mission Control Houston. Now that we're docked, Victor Glover is securing some hardware, and then he'll move right into hatch operations. First, he will open the large hatch at node 2 forward, giving him access inside the pressurized mating adapter. Then he will have to pressurize the vestibule, which is the small space between the hatches on Dragon and the space station. This was exposed to vacuum prior to docking, and he will need to fill it with air and make sure its pressure is nearly equal with the atmospheric pressures on Dragon and the station. He will use a small valve on the station's hatch to slowly introduce air into the vestibule, and flight controllers here in Houston will monitor the pressure and temperature readings inside and verify that everything is leak-free before we get ready to open up the hatches. We expect it to take about 2 hours to get everything pressurized and checked out before we open hatches. With Dragon successfully docked to the International Space Station, that's the latest from here in Mission Control Houston. And back to the team over in Hawthorne.
All right, thanks, Courtney. As mentioned, it will take some time to go ahead and go through those procedures, but we'll stay with you throughout today's coverage. Of course, one of the major things will be repressurizing the vestibule in between the hatches. There's a hatch called the APAS hatch. That's the hatch on the International Space Station side. And then there's the Dragon hatch itself. In between is a vestibule that's currently at vacuum. So in order to travel through both hatches, you need to repressurize that. Now that there's a hard mate between the two vehicles, they'll check the seal. They'll do some leak checks as they're repressurizing the vestibule up to vacuum. And that will take some time.
SpaceX Endeavor, check on the cabin mic.
SpaceX has you loud and clear on the cabin mic.
We have you the same, thanks.
You're hearing the crew inside Endeavor go through their procedures. One of the first things they're ready to do is take off those suits. They had to wear it through several of the operations of a launch from the Kennedy Space Center to a docking with the International Space Station. Launch is a very dynamic activity, so they had suits on up until orbital insertion, and then they were able to doff their suits, have a meal, go to bed, check out some of the systems, wake up, and then right before they entered into the approach phase of today's flight with the approach initiation burn, they got their suits on and were able to pressurize them, and they held pressure throughout that sequence of today's flight until docking. Now they get to take it off. They get to stretch out, change into something a little bit more comfortable, but not too comfortable, of course, because they will be. We will have an event to welcome them on board the International Space Station. We expect all 11 crew members to be there to welcome them. It's going to be pretty crowded, but it should be very exciting to see that many people on board the International Space Station.
And those call-outs that we just heard they were doing a comm check with the Crew Dragon communications because they've now taken off their suits. They have comms through their suits, but since they're not going to be wearing their suits anymore, they need to use the comms through Dragon. So very exciting. It sounds like they're getting out of their suits as we speak, or doffing their suits. And then we will soon begin the process to open up those hatches so that the crew can finally ingress onto the space station. So it will take a little bit of time, but we will be here with you through every step of the way. If you're just now joining us, the Crew 2 crew has finally docked to the International Space Station after an approximately 23-hour ride from Earth to the station. Again, they are going to be performing a few procedures here before the Crew 2 can ingress onto the space station. They will be opening the APAS hatch, which is the space station side hatch, followed by the Dragon hatch. But this will take some time. They will need to repressurize the vestibule in between those two hatches before the crew can ingress.
That's right, the umbilical on the Dragon side has been fully extended to provide power, communications, and data from the International Space Station to the Dragon, so the Dragon no longer needing to rely on its own power systems. And of course, when the hatches are open, they'll be able to mix the air from the environment that's inside the space station with the Dragon, so it no longer needs to rely on its environmental control and life support systems. In the meantime, it is still doing so because the hatches are closed between both the Dragon and the International Space Station. There is a gap called the vestibule in between them that's currently at vacuum. That vestibule has been exposed to the vacuum of space on the forward end of the International Docking Adapter. So when bringing the pressure back up, there may be swings because of the temperature variation. There may be swings that need to dampen out before an effective leak check could take place. So the process of repressurizing the vestibule in between those two hatches does take quite a long time. It's expected to be about 2 hours until both of the hatches are open because of the length of time of repressuring that vestibule. Now from the station side, Victor Glover will outfit the APAS hatch. That's the one on the station side. He'll open it up and remove, once the vestibule is pressurized, he'll open that up and remove the docking target and install some padding onto the APAS hatch so that there's no unnecessary contact as astronauts are coming through the hatch from Crew Dragon to come inside of the forward end of the International Space Station.
Station Houston on 2 on the big loop. You are go to pick up and ingress part 1, step 1. Note that the pre-ingress ventilation in step 1.6 is not required.
Okay, picking up step 1 and 1.6 not required.
Dragon SpaceX, no response required, but ISS power connection has been established.
There you go. So Victor Glover on the International Space Station side already going through his procedures to get the hatches configured for ingress, essentially supporting the opening of the hatches, repressurizing in the vestibule. There's a lot to happen before we can open up the hatch and welcome the crew on the inside. The umbilical has been fully extended, and we just got confirmation that Dragon is drawing power from the International Space Station, so the solar arrays on the station providing power downstream to the Dragon. Dragon no longer needing to rely on its power. That officially confirmed. It will again take some time until the Dragon hatches are open. Dragon and Space Station hatches are open. And we've noticed for the past 2 times that Crew Dragons have docked to the station. The past 2 times being when Crew was aboard for Demo 2 and for Crew 1. We did notice that the crew inside Dragon took some time before to get themselves situated, make sure everything on the Dragon side was configured before they left it and entered into the International Space Station. We should see celebratory hugs from the crew on board as they make their way one at a time, as they'll be together for the next few days until they have to say farewell to the Crew 1 astronauts aboard the International Space Station. Shannon Walker handing over command of the International Space Station. Before she does that, she's going to hand command over to Aki Hoshide, who's currently on board Crew 2. He'll take the responsibility of International Space Station commander through the duration of Expedition 65 until he's ready to hand it off to the next crew. That all happening in the next couple of days.
Crew Dragon Endeavour is docked to the International Space Station as we speak. The crew on board the space station as well as Crew 2 are preparing for a couple procedures here for hatch opening. That is the hatch opening on the space station side as well as the Crew Dragon hatch. And this will take approximately an hour, a little over an hour and a half to walk through all of these procedures. So though Crew 2 is at
station on the big loop, node 2, forward hatch is open.
And Ike, we copy, and you are go to continue through step 2, pressurizing vestibule.
Continue through step 2.
As I mentioned, they are walking through several procedures to get those 2 hatches open. As you can hear that communication between Victor Glover on board the station with the ground team helping him out with the procedures.
That first hatch that he mentioned is the node 2 forward hatch. From inside the Node 2 segment of the International Space Station, there are 3 hatches to get from Node 2 all the way down to the Dragon itself.
Dragon SpaceX, if desired, reference procedure 4.400 for monitoring vestibule pressurization.
Copy 4.400 for vestibule depress.
So now that Node 2 forward hatch is open, Victor Glover inside the pressurized mating adapter. Down the PMA is the APAS hatch, the hatch that separates the International Space Station now from the Dragon. With the Node 2 forward hatch open, Victor Glover can work to manually pressurize the vestibule. And we just heard from here in Mission Control Hawthorne that the crew on board Dragon Endeavour will be able to monitor the vestibule pressurization on their displays from the side of the Crew Dragon. You're getting a live look at both of the flight control rooms.
On the big loop. APAS equalization valve closed at 0938.
Houston copies 0938.
You're looking at both of the flight control rooms on the left. SpaceX headquarters in Hawthorne, California. Flight controllers there successfully monitoring the navigation of Crew Dragon Endeavour that autonomously made its way from the Kennedy Space Center in Florida to the International Space Station, docking at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. With the International Space Station as they've been flying over the South Indian Ocean. The control teams are now working to configure Dragon for its stay aboard the International Space Station. They've hard mated it using 12 hooks that drive to connect it to the International Docking Adapter, and have connected an umbilical and confirmed that power is being drawn from the space station to the Dragon, Dragon no longer needing to rely on its power source during its stay. All right, if you're just joining us, you're getting a live view of both of the control rooms. On the left is SpaceX Mission Control in Hawthorne, and on the right, Mission Control Houston with the International Space Station Flight Control Room. Crew Dragon Endeavour is officially docked to the International Space Station, and right now teams on both the station side and Dragon side are working to get ready to open up the hatches in between them. It's going to take some time until we get to that point where we're able to open up the hatches. Victor Glover on the station side is currently inside the pressurized mating adapter. He's working to manually pressurize the vestibule that exists between both of the hatches. It's going to take some time because that vestibule has been exposed to vacuum since before Crew Dragon just docked at 2:08 a.m. Pacific time, 5:08 a.m. Eastern time. And because it has been exposed to vacuum, the thermal environment causes it to have a little bit of oscillation as the pressure is rising. So they need to have some thermal equalization in the vestibule before beginning the pressurization to ensure that the leak checks are accurate. So they'll do a leak check on the way up to pressure, which is a little more than 14 pounds per square inch. They'll do a pressure check at 5 pounds per square inch, make sure everything's good, that the vestibule is holding pressure, and then they'll continue on up to match the pressure between the International Space Station and the Crew Dragon. In the meantime, Victor Glover will open up the APAS hatch on the International Space Station side. That's the hatch that separates the vestibule from the Dragon hatch. He'll outfit the APAS hatch by taking off the docking target, which is a long rod with an X on it, and was used for some of the optical navigation equipment on the Crew Dragon for Dragon's approach and eventual docking to the station. He'll remove that, he'll put some pads on the APAS hatch, make sure no one bumps their head on the way in. And then when he heads into the vestibule, there's a little window. Hopefully he'll be able to wave to his crewmates before they actually open up the hatch of the Dragon itself. After both hatches are open, the crews on both sides will get positioned. Well, first the Crew 2 astronauts will just make sure everything is okay on Endeavour's side before they go ahead and officially leave that vehicle. Crew from inside Endeavour will enter or ingress into the International Space Station one at a time, being greeted by the 7 crew members that are currently aboard the International Space Station, including Crew 1 astronauts. You have Mike Hopkins, Victor Glover, and Shannon Walker from NASA, and Soichi Noguchi from the Japan Aerospace Exploration Agency. Also on board, arriving on a Russian Soyuz in April, earlier this month, was Mark Vande Hei of NASA, and Oleg Novitsky and Pyotr Dubrov from Roscosmos.
Dragon SpaceX for audio configuration.
Go ahead for audio config.
Shane, we are about to transition to hardline audio with ISS.
Copy.
All right, so you just heard the confirmation. The Dragon and International Space Station are mated now by not only the International Docking Adapter, but there is an umbilical that's extending to the space station. We did have confirmation that we have power that's being drawn from the space station to the Dragon side, so they're configuring some of the other channels, including communication. So they'll configure that one at a time. Some of the sequence of events that's going to happen over the next couple of hours until as we continue to repressurize the vestibule and get the station and Dragon outfitted to eventually open up the hatches. We'll be with you throughout the entire duration of this sequence until we have those hatches open and provide a live coverage of a welcome ceremony, show the inside of the space station and the crews of Dragon, both Resilience and Endeavour, and of course the MS-18 Soyuz vehicle that are all on board the International Space Station now as part of Expedition 65, welcoming each other officially aboard.
and Endeavour Houston on 2 on the big loop for hard line. We are ready for comm checks with SpaceX, ISS, and Houston.
All right, so it's a little hard to see from this view. It's a external camera view aboard the International Space Station. On the port truss, you can sort of see the nose cone flipped up, but that's Crew Dragon Endeavour on the forward end of the station. It's hard mated using 12 hooks that have driven to hard capture Crew Dragon Endeavour to the International Space Station. It's also connected by umbilical to the station. We've confirmed that power is being drawn from the station to Dragon. Dragon no longer needing to rely on its own internal systems for power. That umbilical also provides a communication line. Now coming up will be a test of that communication line between the teams, between the Dragon itself, Crew Dragon Endeavour, and the International Space Station, and the ground teams, making sure that that connection that we've been hearing throughout the approach and docking phase of today's flight on the big loop.
SpaceX Houston in station. This is Endeavour. Comm check.
And SpaceX has you loud and clear, Endeavour.
And Houston has you loud and clear.
And this space station has you loud and clear on hard line.
We copy it all on hard line. Loud and clear.
All right, so the same control teams that we've been hearing through the approach and docking phase of the flight on the big loop. That includes the SpaceX flight controllers in Mission Control Hawthorne. The voice you're hearing is Core or Crew Operations and Resource Engineer Arthur Berrialt. He confirmed from here in Hawthorne. From Mission Control Houston, Capcom Kathy Bolt confirmed the hardline communication network is working on board the International Space Station. That was the voice of Victor Glover, who is currently working through the procedures for opening up the hatches, including the repressurization of the vestibule. Still awaiting some temperature equalization there before that begins. But that'll be some of his next steps. And then aboard Crew Dragon Endeavour, Commander Shane Kimbrough confirming that hardline communication is working. So we got good power and good communication through the umbilical line to the Dragon from the International Space Station. We'll continue to provide periodic updates throughout this sequence of repressurizing the vestibule and opening up the hatches, configuring the Dragon and the International Space Station as they are mated together in space.
SpaceX Endeavour for some reports on 4.400 when you're ready.
SpaceX is ready to copy for 4.400.
Okay, for tablet percentage MS177, CDR 84, PLT 87, MS2 79.
All right, SpaceX copies. Reading back. Tablet power is MS177, CDR is 84, PLT is 87, and MS2 is 79.
Good read back.
Station Houston on 2. We've had a good vestibule pressurization and leak check. You are go to pick up and ingress part 2, step 3.
All right, that's great news. Picking up in part 2, step 3 for ingress. Thanks.
If you're just now joining us, you are watching the live broadcast for the Crew 2 mission for SpaceX and NASA. The Crew 2 Dragon Endeavour has docked to the International Space Station. They're currently working some procedures to process opening the APAS hatch, which is the hatch on the International Space Station side, as well as the hatch on the Dragon, Crew Dragon, prior to crew ingress onto the space station. And what you're looking at on your screen is Crew Dragon Endeavour docked to the International Space Station. We are hearing some call-outs as they're walking through some procedures, so we're keeping up with the teams. Again, this process does take a bit of time.
So if you're just joining us, the Dragon itself is attached to the International Space Station. The crew inside, namely Victor Glover, is making incremental steps to open up the hatches between the International Space Station and the Dragon itself. Glover waited for thermal equalization of the vestibule in between each of the hatches, the station side and the Dragon side. After thermal equalization, he brought it up to about 5 pounds per square inch, performed a leak check, and everything looked good, so he proceeded to increase the vestibule pressure to equalize with the International Space Station's pressure. With vestibule pressurization complete, and after a few checks, Glover will be given the go to open up the station side hatch, the APAS hatch. Once that's open, he'll be able to see the Crew 2 astronauts inside the Dragon Endeavour. There's a small window on the Dragon hatch that he'll be able to see them. And his main job before opening up that hatch will be configuring the station side hatch. That hatch is configured with a docking target. It's a small rod with an X on the end that provided guidance for the Dragon during its approach to dock with the International Space Station. He'll remove that docking target and provide some padding to allow safe entry into the International Space Station for the Crew 2 astronauts.
Victor Glover is one of the NASA astronauts that flew on Crew 1 about 6 months ago. So he is the one preparing, who has been preparing the space station for Crew 2's arrival. This is Victor's first mission on the International Space Station, and first time that he has been to space, so it's pretty cool that he gets to welcome the Crew 2 team and help get them on board the space station.
And Station Houston on 2 for Node 2 video.
Go.
Yeah, we were wondering if we could get permission to come on board in Node 2.
You're welcome. Please come on board.
Okay, and we'll need the high-def camera powered on.
All right, so we've been very lucky with some of the external views here. This coming from a camera on the Japanese exposed facility pointing at the forward end of the International Space Station where the Dragon is currently docked. Crew Dragon Endeavour. Very shortly, with permission from Victor Glover, we should be getting some views from the inside of the International Space Station and seeing what Victor Glover is up to. He's at the forward end, inside the pressurized mating adapter, going through his procedures to configure the APAS hatch, getting it ready to open. We did hear confirmation earlier that the vestibule is pressurized between the two hatches, those hatches being the station hatch and the Dragon hatch.
Looks like we got that live view on the station.
I think that's Soichi Noguchi on board the International Space Station. Colonel Mike Hopkins, NASA astronaut and commander of the Crew 1 Dragon Resilience, coming into frame as well. There are 7 crew members currently aboard the International Space Station, not counting the Crew 2 astronauts who are on the other side of that hatch. Once that hatch is open, there will be 11 crew members on board the International Space Station. Sort of forget that you don't really need to be in an upright position to work from this orientation. We're looking sort of in an upright position. If you look down or nadir from this position, you would go straight down towards the Earth, but you can see clearly Soichi Noguchi upside down. Mike Hopkins was just upside down. You don't really need to be in a particular orientation to work.
Coming into frame, that is Victor Glover.
And there's Mark Vande Hei from NASA, who arrived earlier this month on the Soyuz MS-18 rocket launching from Kazakhstan, with 2 Russian cosmonauts, Oleg Novitsky and Pyotr Dubrov. They'll be joining for the welcome ceremony to welcome the Crew 2 astronauts aboard as well.
Another thing to point out, you could see that each of them are just wearing socks. Don't really need shoes to be on the space station, since they're not really walking anywhere. They're floating around.
Yeah, they use their hands really to propel themselves from module to module, but their feet, you can see some of the blue handrails situated around the International Space Station. Ooh, there's a good shot of how astronauts typically use those handrails. They'll wrap their feet underneath them to stabilize them. Looks like the pressurized mating adapter is used for some stowage, so there's looks like Noguchi and Glover are reconfiguring some of the stowed items to allow some room to open up the APAS hatch, the hatch on the International Space Station side, and provide a pathway for the Crew 2 astronauts to come through the hatch to be welcomed in Node 2. So again, the vestibule is pressurized between the Dragon hatch and the station hatch. You can see Noguchi working on the station hatch. His next procedure is to go ahead and open it. And you can see, confirmed, APAS hatch is open. Noguchi taking some initial photographs. Part of the procedures would be to survey the hatch itself, inspect for any foreign object debris.
Houston Station, Big Loop, APAS hatch open, and it's dry, and seals are clean.
And Houston copies, and you can continue in step 4.
Dragon SpaceX for procedure 4.400.
Go ahead, SpaceX.
All right, Shane, when you're ready with that APAS hatch call, that does unblock us to go into section 5 of 4.400 when we get there. Additionally, when you're ready, we are ready to collect inventory in section 3.
Okay, inventory coming to you, and we're ready for section 5 after that.
SpaceX copies, thanks.
Thank you for Thomas for the inventory. So just quickly compared to what I reported prior, the only delta is 2 bottles from location, from bag 204 in location 9. All the rest is as per our previous report. So I'm not sure you need all the details of what's remaining because I kind of gave the detail of what we consumed from the food locations. I can give you the details. It's your call.
SpaceX copies. If there's no delta from your previous report, we don't need it, but I will read back. That was 4 bottles from bag 204.
Two.
Copy that. 2 bottles from 204. Last question for section 5 of 4.400. Does that 2 bottle include the additional bottle that will be used in step 5.1, or will we require an additional bottle?
And that's a good question, Arthur, and we're working on this, so you can add another bottle for this section, and we'll grab it from 206.
All All right, SpaceX copies. Thanks, Tama. We'll take one bottle from 206. And Tama, SpaceX, last question. Can you confirm no food deltas from previous report, or did you also consume midday meals for today?
No, we didn't consume anything. The latest last food consumption was the one I reported before.
All right, copy. Thank you.
All right, you just heard the core here in Mission Control Hawthorne communicating with the crew on the inside of the Dragon. They're behind this camera view that you're seeing here. This is the center line camera of Crew Dragon Endeavour. You're getting a look at Soichi Noguchi as he outfits the APAS hatch, getting ready for the astronauts inside Endeavour to come through the hatch. The hatch to Dragon is still closed as Noguchi continues to outfit that APAS hatch. He took some photographs upon entering into the vestibule that you see here and took some photographs to survey the APAS hatch, make sure the seals look good, reported that they all looked good, so he's continuing with the procedures to attach some pads and remove the docking rod from the center of the APAS hatch. APAS standing for Androgynous Peripheral Assembly System. It's just the hatch on the station side, the last one until you get to the Dragon hatch.
Dragon SpaceX, question on procedure 4.012, suit doffing.
Go ahead, SpaceX.
Right, Shane, just wanted to follow up. We wanted to confirm that all 4 suits are drying, and then when ready, when we can come back on board.
All 4 suits are drying. Some of them have been drying for an hour already, and you are welcome to come back on board.
Copy that, Tama. Thank you.
Very cool. Got some words that we might get some camera views inside of Crew Dragon with the Crew 2 team already doffed their suits, confirming that their suits are drying as they are waiting for ingress on the International Space Station. What you're seeing on your screen is Soichi Noguchi getting this vestibule area set up for the Crew 2 ingress prior to opening the Crew Dragon hatch. Once that hatch is open, the crew will not immediately ingress onto the space station. They do need to follow a few more procedures just to make sure that everything is good to go before they ingress on the space station.
So you see some of the padding that's needed to outfit that APAS hatch. He's just wrapping it around the metal structure that is the station side hatch. He'll do this to completion. On the other end, we'll hopefully be getting some views from the inside of the Dragon cabin and seeing both perspectives from the Dragon side.
Dragon SpaceX for awareness. Cameras are back on board.
Thanks. Welcome on board.
All right. We'll hopefully get those views inside Dragon soon. Meanwhile, Soichi Noguchi continuing to outfit the hatch. Again, this is one of those steps to get all of the hatches open in between Dragon and the International Space Station. Now getting views from inside Dragon. The crew have doffed or taken off their suits. And so now they're dressed and ready for the welcome ceremony. Once they get on board, we'll have some hugs, and they'll have a chance to talk with some of their crewmates before getting in front of the camera to officially welcome the crew 2 astronauts aboard the International Space Station, an orbiting complex that will support a crew of 11 until Wednesday the 28th is the planned undocking time for the crew 1 astronaut, Soichi Noguchi, currently one of those astronauts that will be departing, along with 3 American astronauts, including Shane Kim, Mike Hopkins, Shannon Walker, and Victor Glover. All right, looks like Noguchi has that APAS hatch wrapped. You can see just above him, he used a series of padding and blankets to wrap the metal structure that is the station side hatch, and now he's inside the vestibule. See some of the tubes he's bringing in the vestibule section that are peeking through towards us on the pressurized mating adapter side. That'll allow the circulation of some of the air from the station side and remove any carbon pockets that may appear in the environment of the space station. So we're a little more than an hour and a half removed from the docking, the official docking
Houston
time.
Hawthorne Endeavour Station is ready for Dragon Hatch equalization.
Houston, copy.
Endeavour copies. Endeavour copies.
NASA astronaut Mark Van High coming in to help out. The crew on both sides getting confirmation. The next step's underway to get that other hatch open. There's one more hatch. You see the station side hatch open at the back end of the pressurized mating adapter there. There's one more hatch, the Dragon on the Dragon side. And the crews on both ends are working through to open up that hatch and welcome the crew 2 astronauts on board. Just going to stand by for a few minutes for pressure to equalize between the International Space Station and the Dragon hatch before go ahead and opening that final one.
And Endeavour Houston, can you confirm readiness for hatch equalization?
Endeavour's ready. Endeavour's ready.
Okay, station and Endeavour, stand by for equalization. It's expected to take 5.5 minutes.
station, copy.
Endeavor copies. Endeavor copies.
All right, so you heard that equalization time. A timer is set for about 5.5 minutes to allow that pressure to equalize between the pressure inside the environment of the International Space Station and the pressure inside the Dragon. That pressure has to be equalized within both spacecraft before the Dragon hatch is open, one of the steps to open up that final hatch. So we'll just stand by as that equalization is underway. In the meantime, you can see in the pressurized mating adapter, Mark Van de Heij currently moving some stowed items around, creating a clear pathway for the Crew 2 astronauts to enter the International Space Station once they head through the hatch, being assisted by Suichi Noguchi. We've also seen Victor Glover, who was primed for monitoring Crew Dragon's approach to the International Space Station. So it looks like Glover is resetting the camera position there. That view provided a nice angle downward into the pressurized mating adapter to see some of the activities happening for opening up the hatches. Now Glover's just getting that camera set up for the next activity, which will be a welcome ceremony. Putting it in a good position to frame or allow to frame 11 astronauts to squeeze into that shot. I think that'll be an impressive feat by itself.
Yeah, that is quite a bit of people, especially for the International Space Station. But it'll be really cool to see them all together.
So right now it's looking like the procedures to undergo opening up the hatch. Again, we're still waiting for pressure to equalize between the space station and the Dragon itself before opening up that hatch. But it seems like we're on a good timeline to start a welcome ceremony on time. That's expected to begin at 4:45 a.m. Pacific. Should be 7:45 a.m. Eastern. gathered inside node 2 now. You see over to the left is NASA astronaut Mark Vande Hei. Going from left to right, we have Crew Dragon Resilience Commander Mike Hopkins, followed by Soichi Noguchi and International Space Station Commander and NASA astronaut Shannon Walker. How do you fit 11 people on camera? That's what we want to know.
And that's what it looked like they were trying to figure out. Trying to get into position to see probably where that camera should be and where they should be facing.
Yeah. All right, we'll get periodic handovers from the views we were seeing on board the International Space Station as well as Dragon. The views being provided through tracking and data relay satellites, geosynchronous satellites that provide that video feed from the International Space Station. Right now you're looking at mission control in Hawthorne, flight controllers looking after the Dragon Endeavour and its systems. Dragon will be configured for a long duration stay aboard the International Space Station, eventually being configured for a quiescent mode. Will remain there for 6 months with periodic checks, of course, to check on the status and health of the spacecraft itself before it departs 6 months down the road.
And Endeavour and Station, hatch equalization has started. 5.5 minutes wait time.
Endeavour copies. Station copies.
All right, so the pressure is... The equalization process has been started between the International Space Station and Crew Dragon Endeavour. The clock starts 5.5 minutes. After that clock runs out, the teams will verify that the hatch is good to open between the Dragon and the International Space Station. We're still tracking to start the welcome ceremony at 4:45 a.m. Pacific time, 7:45 a.m. Eastern. We'll hopefully get to see the crew in early, but they'll be able to do some hugs, get settled, and then get in position to start the welcome ceremony. We'll keep you up to date if that time does change, but it seems we're looking good so far for the Endeavour crew to enter into the International Space Station.
It looks like we got that live view back on the International Space Station where they are preparing for the Crew 2 to ingress and getting set up for that welcome ceremony. You can kind of see them all coordinating with each other on where the cameras need to be. and where they want to do this welcome ceremony. We're currently waiting for equalization of pressure between the International Space Station and Crew Dragon prior to opening that hatch on the Crew Dragon.
So again, we're in the middle of a 5.5 minute timer as equalization is underway between the pressure inside the International Space Station and pressure inside the Crew Dragon Endeavour. So we'll just wait on the status after that 5.5 minute timer and the OK to open up the Dragon hatch. It may be some time after the Dragon hatch is open until the Crew 2 astronauts enter into the International Space Station. But we're tracking a welcome ceremony to formally begin as of now in 45 minutes. Keep you up to date in case that changes.
Looks like we just have a different camera view on the International Space Station. That is JAXA astronaut Soichi Noguchi that you see in the frame right now.
Preparations happening on both sides. We're mostly getting views from the International Space Station side, but the Crew 2 astronauts are inside the Crew Dragon capsule getting configured. Because once they enter through the hatch, they'll join the 7-member crew of Expedition 65 that's currently aboard the International Space Station and conduct a welcome ceremony. We'll see some hugs and shared camaraderie among the Expedition 65 crew for a little bit, and then formally welcome them to the to Expedition 65 aboard the space station.
Dragon SpaceX for 4.400.
Go ahead, SpaceX, on Dragon to ground.
Hey Shane, just looking for confirmation of completion of section 5 of 4.400.
Section 5 is complete.
SpaceX copies, thanks. And additionally, last check is completion of procedure 4.012, suit doffing.
Yeah, sorry, we didn't let you know that. 4.012 is complete.
Much appreciated. Thank you, Shane.
All right, a few checks from the crew operations and resource engineer.
Dragon SpaceX on the big loop for hatch open.
Go ahead for hatch open on the big loop.
All right, Dragon, you are go for hatch opening per the decal on the hatch, followed by the remaining actions in procedure 4.400, section 6.
Okay, that's in work.
Good words that they got the go for opening the Dragon hatch.
It's fantastic news. We can kind of see the hatch from this angle. Hopefully it remains unobstructed. We may be able to see the, yep, you can see the handles moving a little bit. Yes, there it goes.
Again, this is being opened from the interior side of the Crew Dragon vehicle. So this is the Crew 2 crew performing this work right now. It looks like the crew on station is getting excited, peeking in.
I can feel the energy for sure. All right, Dragon hatch is open.
Already seeing a bunch of smiles.
All right, that Dragon hatch, the final hatch that we've been waiting for since Endeavour docked to the International Space Station 2 hours ago, 2:08 a.m. Pacific. 4:05 a.m. Pacific is the time that Dragon hatch was open. Already seeing some smiles.
So again, as we mentioned, the Dragon hatch is open, but the Crew 2 members still need to finish walking through some remaining procedures before they can ingress onto the space station, including photos. It looks like you can see the the crew posing for some pictures there.
On the big loop, hatch is open.
SpaceX copies on the big loop. Hatch is open.
All right, again, the hatch was open at 4:05 a.m. Pacific. The space station and Dragon flying together in unison. Attached, Endeavour attached at the forward port. Those vehicles were 267 statute miles over the South Pacific to the east of New Zealand.
SpaceX Endeavour 4.400 complete.
SpaceX copies. 4.400 is complete.
So as a reminder, even though the Dragon hatch is open, it still may be a couple of minutes until the crew Dragon Endeavour astronauts actually ingress or enter into the International Space Station to be welcomed by all of the expedition's 65 crew members currently aboard who are eagerly awaiting them to come on board their new home, the International Space Station, for the next 6 months. It's a couple of procedures. You see some of the air ducts.
And Houston Dragon in 2.102, step 6, 1 IMV duct installation complete. You are go for IMV fan activation.
Houston copies. We'll put that in work.
Okay, yeah, so some of those procedures that are happening on the Dragon side, they're going to install some IMV ducting, mixing the air of the International Space Station environment with the air inside the Crew Dragon Endeavour. They're going to seal some of the LiO, or lithium hydroxide cartridges that scrubbed carbon dioxide inside the Dragon capsule on the ride up to the International Space Station. They're going to check some vent valves, so it may be some time until we actually see them welcomed aboard. But just these last final checks are critical before they leave the capsule that brought them up to the International Space Station. Make sure it's good to go, because it will remain docked here for the next 6 months.
Looks like the station side crew is ready, and they're just waiting for the Crew 2 crew to ingress onto the space station here in a few minutes once they finish their procedures. And lots of smiles. They look very excited for this right now. If you're just now joining us, the Crew 2 Dragon Endeavour is attached to the International Space Station. We are just eagerly awaiting the crew on board Dragon to ingress onto the space station here shortly. They're finishing their final procedures. Both the APAS hatch and the Dragon hatch are open. So we should just be a few minutes away from the Crew 2 astronauts ingressing onto the space station.
Meanwhile, in the frame now, you can see the 4-person crew of Crew Dragon Resilience. From left to right, you have Victor Glover, Shannon Walker, Soichi Noguchi, and Mike Hopkins.
And Soichi doing some flips for us.
That's right.
This is the Crew 1 crew waiting to welcome the Crew 2 crew, whom they will hand the baton off to. They'll spend approximately 5 days with the Crew 2 astronauts as they do a handover prior to Crew 1 coming back to Earth as early as April 28th next week.
Endeavor Houston, you are go, and step 6.3.
Copy, go, and 6.3 for Endeavor. 6.3 for Endeavor.
We got some communications from Houston to the Crew 2 members on board Dragon. Continuing with the next procedure. Again, they should be ingressing on the International Space Station here very shortly. Crew 1 crew hanging out on your screen there, waiting for Crew 2 to ingress.
Again, all the hatches are open between the International Space Station and Dragon. The crew of Endeavor just going through some last-minute checklists to make sure that Dragon Endeavor is configured properly before they leave it, which successfully carried them from the Kennedy Space Center in Florida to the International Space Station over the course of just a little more than 23 hours. Docking with the space station earlier this morning at 2:08 a.m. Pacific. Coming into frame here, you see at the forefront of the frame is NASA astronaut Mark Vande Hei joining the Crew 1 astronauts, all of them currently members of Expedition 65. It's part of their mission to stay on board the International Space Station for a long-duration mission of science, maintenance, technology demonstrations, and upgrades.
If you're just now joining, you are watching the live broadcast for the Crew 2 mission. We are currently waiting upon the ingress of the Crew 2 astronauts onto the International Space Station. They have already docked. Both the APAS hatch and the Dragon hatch are open.
New to the frame on the left there is Roscosmos cosmonaut Oleg Novitsky. He was the commander of the MS-18 Soyuz spacecraft that made its way to the International Space Station earlier this month with NASA astronaut Mark Vande Hei. Also on board is Pyotr Dubrov, who hasn't been in front of the frame yet, but he'll be part of the welcome ceremony as part of the 11-member crew that makes up Expedition 65 currently aboard the space station.
Station Houston on 2. Houston on 2. We're seen at voice check for upcoming TIO event. We're good with the scene check if we could just get a voice check. And Shannon, we are not picking up any audio.
How about now? Having things on works better. 1, 2, 3, 4, 5.
And Shannon, we did hear you that time. We're checking. And Shannon, can you give us another long count?
Sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Copy. Thank you. We're checking. And that's a good voice check.
and SpaceX Endeavour on space ground for LIO.
SpaceX is with you on space to ground for LIO.
We were trying to install the LIO with the bag cover, that is LIO 1, oh, correction. Yeah, LIO 2, in the bag and in the non-active storage area. And while we were pushing in, it tore the bag, and it cut that bag pretty big. Would you like us to proceed with this or go without the bag?
Copy that.
Just to let you know, the seal is on that LIO cartridge too.
Copy that, Dragon. Just to read back, there's a tear in the LIO bag as a result of trying to insert into the LIO slot. Stand by, we're going to get you some forward actions.
Okay, copy. And we do have a camera pointing at it right now. It's a Conga camera.
Copy that, we see it, thanks. Dragon SpaceX, can you confirm if it is LIO cartridge 1 or LIO cartridge 2?
Yeah, the LIO cartridge 2 is in the bag. LIO cartridge 1 is secured in the active location with the seal on.
Copy that. Stand by 1. Dragon SpaceX, we're going to have you stow that LIO cartridge without a bag. How copy?
All right, for those of you joining, we're in a handover period with some of the tracking and data relay satellites, geosynchronous satellites that provide the video feeds we were seeing and enjoying from the International Space Station as we eagerly await the crew inside Endeavour to enter into the International Space Station. The Expedition 65 crew members, all 7 of them gathered inside of the station on the other end of the Dragon's hatch, eagerly awaiting for them to get inside. Flight controllers here in Mission Control Hawthorne just undergoing a series of checks, final steps really, for the astronauts inside Endeavour to undergo before they enter through the hatch and leave the capsule that brought them up to the International Space Station. Some of the LIO cartridges you're hearing are lithium hydroxide cartridges that scrub carbon dioxide from the environment of the Dragon Endeavour capsule. Now regaining some of those views. Once the 4-person crew of Endeavour comes onto the International Space Station, there will officially be 11 crew members on board as part of Expedition 65. We're still on track to start a welcome ceremony here in a little less than 15 minutes. We'll have representatives.
Dragon SpaceX, repeating a call. We did have a teacher's handover. Want to confirm that we will stow this cartridge without a LIO bag. We just want to verify that the seals are secure on each side of the LIO.
And just to verify, seals are secure on both LIO cartridges 1 and 2.
SpaceX copies. Thank you.
And SpaceX, please let us know what to do with the bag itself.
So from left to right inside the International Space Stations.
Dragon, SpaceX copies. We do want to save this bag so we can look at the RIP in the future. Stand by. We're going to get you words on where to store it.
And Endeavour copies.
Crew of Endeavour still working through those last-minute procedures. Again, LIO cartridges are lithium hydroxide cartridges that scrub carbon dioxide from the environment of inside Crew Dragon Endeavour. You're getting live views from the International Space Station side. From left to right, we have Roscosmos cosmonaut Oleg Novitsky, followed by International Space Station commander and NASA astronaut Shannon Walker. coming down from the...
bag. Sorry, could you repeat where to stow that bag?
Yes, stand by, Dragon. We are finding a good common bag to put it in for temporary stowage.
Okay, copy that. We'll just stow it for now.
Copy, Dragon. If possible, we can also put it in a trash bag in location 17. That would be bag 111.
Okay, copy. We'll get a trash bag from location 17, bag 111, and put it in there.
Okay, copy. That is bag 111, and that is actually location 18.
Location 18, bag 111.
In this frame, all 7 crew members of Expedition 65 currently on board the station gathered to welcome the Crew 2 astronauts aboard Endeavour. On the top left is NASA astronaut Victor Glover. You see Soichi Noguchi in the foreground on the right there. On the far right is NASA astronaut Mark Vandehei. Mike Hopkins is just behind Soichi Noguchi there. And Roscosmos cosmonaut Pyotr Dubrov is on the zenith or space-facing side, sort of the ceiling from this shot, all gathered and eagerly awaiting for the 4-person crew of Crew Dragon Endeavour to come on board.
Soichi Noguchi doing some backflips as they eagerly await the Crew 2 astronauts to ingress on to the International Space Station. The Crew 2 crew is finishing some final procedures. Once they complete all of those procedures on board Crew Dragon, they should be able to ingress on the International Space Station. And once they ingress, there will be some welcoming hugs and smiles, and then we will have an official welcome ceremony.
It's been a long journey for the 4-person crew of Endeavour. It took them 23 hours to make their way to dock to the International Space Station earlier this morning. That docking time at 2:08 a.m. Pacific. The Dragon hatch was opened at 4:05 a.m. Pacific. We're counting down to the Endeavour astronauts to enter into the International Space Station, and we'll begin a formal welcome ceremony to officially welcome Endeavour to the International Space Station, and we'll have representatives from the space agencies of the crew on board Endeavour, including NASA and the European Space Agency and the Japan Aerospace Exploration Agency, chiming in to congratulate the crew 2 astronauts and the support teams that helped to get them to the orbiting laboratory today.
Station 2, unless anybody's opposed, we're going to progress with ingress.
Endeavour, welcome aboard. You are go to ingress.
Endeavour arriving.
Got some confirmation that the crew is go for ingress, and you can see Aki is the first to ingress onto the International Space Station.
And Gwyn.
And Gwyn.
Followed by Thomas Pesquet from the European Space Agency.
Lots of hugs and smiles right now.
Pilot Megan MacArthur of Crew 2 is next, being welcomed by the Expedition 65 crew members, and Shane Kimbrough bringing up the rear. The 11-person crew of Expedition 65 now together inside Node 2 of the International Space Station.
Though we can't even hear audio in there, you could really feel the excitement just by the looks on their faces, the hugs that they're giving. Now they're getting ready for this official welcome ceremony. You can see them getting into position.
Let the Tetris game of fitting 11 crew members into a single frame begin.
Right. 12. Gwyn.
Oh, that's right.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
Mr. Jursic, please call Station for voice check.
Station, this is Steve Jerzik. How do you hear me?
Steve, we have you loud and clear. Welcome to the International Space Station.
Hey, man, it is awesome to see the 11 of you on station. It's incredible. Congratulations, Crew 2 on an amazing launch yesterday. Coming to Kennedy Space Center and watching launches never gets old, and seeing the pre-dawn launch yesterday was amazing. So congratulations. I also want to congratulate the NASA and SpaceX team for our third commercial crew mission in less than a year. A lot of firsts on this mission, including the first crew handover of commercial crew vehicle, and it was really cool during docking to see one Dragon docked on the Zenith port and the other Dragon coming in for docking. So it was amazing. April has been an amazing month and a really busy month for ISS, with Mark, Piotr, and Oleg launching to ISS. Kate and her Russian colleagues coming back. Crew 2 there, and now preparing for Crew 1 to come back. And I am really excited for all the research, technology development that is going to be able to be enabled on station with these regular crew rotations and having 4 crew up there consistently. It's not only important for advancing research technology development to benefit folks here on Earth, but also to prepare for Artemis and our return to the moon, and eventually are preparing for human missions to Mars. So it's just an incredibly exciting time for ISS. You know, Shane, Megan, Aki, and Thomas, we thank Tomas. We thank you for everything you do for the agency, the country, and the world, and we look forward to an amazing expedition. Crew 1, you guys have had an amazing 6 months. Mike, Victor, Shannon, and Suichi, I've followed what you've done to upgrade the station and all the research and technology you've been able to accomplish. And just want to congratulate you on an amazing expedition. And we look forward to your return next week. So again, I'm just really excited for this new era for ISS and all that you all have and will be able to accomplish. So thank you.
Thank you, Steve. It is very exciting to have Crew 2 with us today, and so I'm not going to take up any time here. I'm just going to hand it over so we can get their thoughts.
Thanks, Shannon. Thanks, Steve. And on behalf of Crew 2, we are just so excited to be here. I'm very excited to be here. In some ways, it's been a long journey. In other ways, it's been a pretty quick one-year assignment flow. So it's taken a tremendous amount of work from a lot of different teams to get us here. We, of course, have our excellent training team at Johnson Space Center, also an outstanding training team from Hawthorne, and the entire ISS program and commercial crew program working together to get us here, of course, as well as along with our international partners. We're just really excited to be here and be part of this historic mission with the 2 Dragons on board. First reuse of a capsule, first reuse of a booster. It's just a tremendous achievement on behalf of our partner SpaceX. So I want to congratulate and thank them. And we're so excited to be here. We're ready to get to work. There's a lot of great science that I know we're going to be doing, and we're just excited to learn and get started. So thank you.
Thank you, Mr. Jerzik. We now welcome Associate Administrator Kathy Leaders to provide remarks. Ms. Leaders, please call station for a voice check.
Station, hi, this is Kathy Leaders. Do you hear me?
Kathy Leaders, do you hear me?
Kathy, we have you loud and clear.
Wow, you know, I just don't, I think I could see Endeavour approaching station maybe one more time, you know, near and dear to my heart to see that going on. And, you know, I think both Steve and Megan mentioned how amazing it was to see resilience there on the station. The folks, Crew 1 folks and the other parts of the ISS team, Mark, and you guys had the best view, but it was really cool seeing it from here on Earth. Like Steve talked about, wow, this is, and Megan too, we talk a lot about this being, and exploration being a team sport, and this mission so far has really exemplified that. You know, with our commercial partner, SpaceX, with our international partners, and with Thomas and Aki, and obviously Megan, you and Shane, you know, holding up on the NASA side here, and then our commercial crew and ISS teams. Congratulations to all of you. It's just been an amazing, amazing mission, and I know you guys are going to be doing some really great things. I've been here watching the folks here on station waiting for you, and I know you guys will be having a lot of fun together over this direct handover period, and with all of you on board, it's going to be a lot of fun for you, and getting ready for Crew 1 to come home. So I just wanted to really, from the bottom of my heart, say thank you. Thanks to all of you. Thanks to the whole team, the international, the commercial, you folks there on the space station now today safely, and looking forward to, like Steve said, seeing your accomplishments over the next 6 months. Thanks again.
Thank you, Kathy. Really appreciate your support.
Thank you, Ms. Leaders. We now welcome JAXA President Dr. Yamakawa Hiroshi. Dr. Yamakawa, please call station for a voice check.
Station, this is Yamakawa Hiroshi from Scuba. How do you hear me?
Dr. Yamakawa, we hear you loud and clear.
Well, thank you, Aki. Well, congratulations to all. I watched yesterday's launch on TV and really feel relieved by your safe arrival to the station now. In this tough situation around the world, I believe you have brought courage and hope for all of us. It is a great pleasure not only for me but also for Japan that 2 Japanese astronauts, Aki and Soichi, have boarded the operational spacecraft of the Crew Dragon twice in a row. This represents the many years of close cooperation between close cooperation on the International Space Station. I'm so happy to see both of you with big smiles today. And I understand that Aki advocates teamwork for this long-term mission, which comes from your experience in rugby football. The ISS is a symbol of international cooperation around the world, and we are looking forward to seeing you work as a team, build a scrum with all of the crew members from NASA, ESA, and Russia on board, and keep scoring tries to maximize outcome during your mission. Soichi, we wish you a safe return to the Earth, and Aki, good luck and enjoy your stay in space. 野口さん、地球で待ってます。星出さん、これから半年間頑張ってください。Thank you very much.
Thank you very much. It's an honor to be part of this team. We have a 11-person scrum right here, and with 4 countries representing. It's really an honor and privilege to fly on Crew 2 Dragon and get here. Thank you to all the people that worked very, very hard to prepare us and the vehicle. We got here safely, and now it's time to work here on board the International Space Station. And we look forward to working with everyone around the world. Thank you very much.
Thank you, Dr. Yamakawa. We now welcome ESA Director General Joseph Ashbacher. Dr. Ashbacher, please call station for a voice check.
Station, this is Joseph Ashbacher. How do you hear me?
Hey, Joseph, we hear you loud and clear. Welcome to the space station.
Thank you, Thomas. This is really great to see you, that you and your crewmates have arrived safely on the space station. Greetings to all of you, 11 of you at the station, from all of us at ESA. It is really a fantastic effort to see you all so nicely grouped together in the group photo. I think the station needs expansion, seeing that you're all crowding together so nicely. On ESA, Thomas, we are all very, very proud of you and what you're doing for space, for Europe, for the Space Agency, also for France. You're extremely popular, as you know. We're all very proud of you, but of course we're also very proud of all the other colleagues which are next to you, because astronauts are so fascinating and they give so much inspiration to all of us. So this was the first launch of an ESA astronaut on a Crew Dragon. It was spectacular, and together with Philippe Baptiste, the newly elected Knesset president, we have followed very closely from the suits up all the way to the orbital journey to the station, and now just recently, just a few minutes ago, the hatch opening, and this was really so exciting and really fantastic. It has been, I think, a long day for all of you, but you all look extremely in good shape and in good spirits. You're all smiling. This is really fantastic to see down here from Earth. But ESA is really very happy to see your assignment, Thomas, towards the end of the mission as the ISS commander. And I really would like to take this opportunity to thank the partners of the space station for this honor to give to Thomas, which certainly is a sign and a recognition of his quality and also his personal qualities, but of course engineering and technical qualities to be the commander of the station, and also recognition for ESA as being a strong partner and supporter of the space station all the way. So I know that you have a long and very intense training period behind you, and you're all set to go. There's a lot ahead of you. Hundreds of experiments are waiting, and all of you will be kept extremely busy, but we all look forward to see the results of these experiments. So Thomas, really very best wishes from all of us. Good luck and bonne chance.
Hey, thanks, Joseph. It's really unbelievable to be here on Space Station. Space Station has changed quite a bit since last time I was here. I've never seen so many astronauts on board. I've never seen so many different spacecrafts on board, and I think it's a tribute to how strong the program is going. I want to echo what Megan has said. It took a lot of effort from all kinds of people, you know, from the highest manager to all kinds of support persons to bring us here. So we want to thank all of them. And I want to say a few words about international cooperation. You said a lot, but it's been 20 years since it's been 20 years. Actually, Shane's line, I learned it from Shane. It's 20 years since JAXA and ESA and NASA and Russian astronaut have been together in space. So it's actually pretty historic what's happening today. We can't wait to start our work on the space station. We can't wait to see what's ahead on the adventure for us. In those 5 months, we're so happy to see our friends. We're going to have to say goodbye to them soon. We wish we could keep them a little bit longer, but not too long as well, because 11 people is a lot on space station. But yeah, it's good to be here. Really, we're impatient, and it's going to be unbelievable. I want to say a few words in French. Je voudrais surtout remercier tous les gens qui ont travaillé sur cette mission en français, et puis un petit mot pour les familles et les amis qui sont déplacés jusqu'à Cap Canaveral. Ça n'a pas été un voyage facile. En tout cas, ça m'a vraiment fait chaud au cœur de les avoir avec moi. Donc je voulais les saluer un peu particulièrement. Voilà. Merci à tous.
All right, go ahead and...
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Acting Administrator Jersic, Associate Administrator Leaders, Dr. Yamakawa, and Dr. Osbacher for your participation in the Crew 2 welcome ceremony. Station, we are now resuming operational audio communications.
Wow, what an incredible morning, Gary. It is so cool to see the crew on board with the rest of the astronauts on the International Space Station.
That's right. They were welcomed by leaders from each of the space agencies that represent the cadre that is the Crew 2 astronauts aboard Crew Dragon Endeavour. We first heard from Steve Jerzik, who's the acting administrator of NASA, based at NASA headquarters. We also then heard from Kathy Leaders, who's the associate administrator for Human Exploration and Operations Mission Directorate at NASA headquarters. Then we got to hear from the president of the Japan Aerospace Exploration Agency, Hiroshi Yamakawa, and Joseph Aschbacher wrapping up the comments as the Director General from the European Space Agency, each of them chiming in and talking about just what it took to get to this moment with 4 astronauts on board, 4 additional astronauts on board, I should say. An 11-person crew now makes up Expedition 65.
Yeah, it's been an incredible 24-plus hours for this Crew 2 mission. This was NASA's SpaceX Crew 2 mission, and we have been with you all from the beginning, starting up with suit-up of the astronauts in the suit-up room at the ONC building, following the crew on the NASA Causeway in their Teslas as they made their way to the launch pad, go up the fixed service structure and ingressed on Crew Dragon Endeavour. We had an on-time liftoff yesterday morning at 5:49 a.m. Eastern Time, with the first stage separating and coming back to Earth for its second flight and second landing on, of course, I Still Love You, while Dragon, separated from second stage, had a good nose cone deploy. We had 5 major burns on Dragon as it made its way to the International Space Station, and finally docking to the space station, where we just a few moments ago watched the crew ingress onto the International Space Station. So an incredible past day watching this mission. On behalf of SpaceX and NASA, thank you for watching today's webcast and for your interest in this exciting second rotational crew mission. Now that Dragon Endeavour has reached the International Space Station, it will spend approximately 6 months docked there until it's time for Crew 2 to return home via a splashdown in the Atlantic Ocean.
And now that Crew 2 has arrived, we're less than a week away from the return of Crew 1. We'll be taking you along as Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi return home after their long-duration stay aboard the station. They're currently targeted to return on Wednesday, April 28th, so be sure to tune in as NASA and SpaceX bring you live coverage of every step of their journey. Be sure to follow NASA and SpaceX on social media for real-time updates. And thanks again for watching our coverage. Go NASA, go SpaceX, and go Crew 2. We'll see you again real soon.